This week on BSD Now, we bring you a recap of FOSDEM, followed by the full Cantrill special. We bring you the whole trilogy of interviews we've done with Brian Cantrill in their original glory, in the original order. No machete order here. So you won't want to miss that. Stay tuned to the place to be, BSD.
BSD Now, episode 181, the Cantrill Trilogy. Not the special edition, though. Recorded February 15th, 2017. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
And we're glad to have you with us this week. We got an exciting episode. This is actually going to be more of a marathon, so I suggest really quick, if you're going to listen to this all, it might be 3-4 hours long. You may want to go get a comfortable chair, make your nachos or whatever. We're going for the gusto this week.
You're going to bust a gut, though.
Yeah, it's good stuff. So we got the Cantrill Trilogy. For those who have missed that in previous episodes, probably our most requested and best episodes, best interview for sure. Mm-hmm. And everyone likes hearing it all over again. So we are going to be playing that this week. I guess Jupiter Broadcasting's got the week off. Yes. Is it a holiday? Or
I think the person who edits the videos is just going on vacation back home to see his family on the opposite coast of the country. And so he won't be around.
So a single point of failure. Okay.
Yeah, and we're both very busy, and so it was fine to work that out. But we do have a little bit of stuff for you anyway.
Okay.
So I just got back from FOSDEM, and they have the videos posted already. So we had the BSD Dev Room, which had a bunch of talks, including packaging Go in package source, which that covers all the BSDs and like Illumos derivatives and even Linux and Mac and so on. There was the first half of the My BSD Sucks Less Than Yours talk by Baptiste Cresson from the FreeBSD project and Antoine Jacotot from the OpenBSD project. That was very entertaining. I'm looking forward to seeing the even more polished version of it in Tokyo, where hopefully they can actually get to the storage chapter of the talk.
Right.
And then there's my video about Gellyboot, just describing how I made that work. And then there was a very interesting talk by Tom Jones from the University of Aberdeen in Scotland, talking about the evolution of the transport stack. So a new system that you build on top of the BSD sockets API. So when you write a program, you don't have to think about it. Sure. In particular, you tell it what type of stream you're going to need, and it picks the best protocol. So it can actually use like SCTP if it's available, but if not, fall back to TCP. But your program doesn't have to know about that. It's just like, I want to have this stream of video go from here to there or whatever. And they've also been working on a congestion control protocol for the new kind of video streaming. So when we do the type of video streaming that we do on mobile devices now, or HTTP live streaming, is basically HTTP where it downloads chunks of video, like say 10-second chunks of the video. And so it can, if the internet connection is fast enough, it can buffer ahead, right? It will download, the next 3 chunks, and then it can't go any further forward because it's live video. You have to wait for the next chunk to happen. So that means the connection goes idle for a little bit until there's another chunk to download. Well, this really screws up all the congestion control algorithms that are all designed to, if you're downloading a file, you're going to be going as fast as you can the whole time. You're not going to have a pause in the middle of it. If there's a pause, it means something's wrong and we need to slow down. And so that causes that kind of video streaming to not work as well as it could. And so he's talked a bit about his new congestion control algorithm and the problems with trying to integrate it in BSD. In particular, we have a pluggable congestion control system, but he needs to poke a couple things that aren't in the pluggable framework to make this work. Sure. So that was interesting. And then Ed Schouten did his cloud ABI for FreeBSD. How does it actually work rather than just what is it? So that was a very interesting talk as well.
He should be one to have back on the show at some point, right? And kind of get an update on that. It's been at least a couple of years.
If he's in Tokyo, we should chain him to a chair.
Yeah. Yeah, he would definitely be a good interview because it sounded fascinating years ago, and I don't know what like the new stuff is that's happened since.
But yeah, FOSDEM was great. I manned the FreeBSD booth for a good part of the morning on the Saturday and all day on the Sunday. It was very interesting to see what people's questions are, and everybody was. So the stickers were definitely the most popular. We ran out of BSD Now stickers in like the first 2 hours. People liked the pens even. The FreeBSD Foundation had pens with a highlighter on the other end, which is quite useful. And then we had lots of pamphlets. There was a decent amount of interest in the Teach BSD stuff as well. People hoping that maybe the university they're at will start teaching an operating systems course, and so on. And our booth was next to the Illumos booth, so I had a lot of fun talking to those guys. Also, just watching one of them booting up a VM, and it's got the FreeBSD bootloader, and it wasn't working. And so I was helping him work through the problem.
They brought that on purpose just to show you, Al, get some free tech support.
Yeah.
I see.
Well, no, it's the default bootloader on Illumos now.
No, I mean, I know. They just wanted you to debug it. That's what it was.
They didn't know I was going to be there, though. Not at the booth anyway.
Yeah, I'm sure. That was coincidental, huh?
And, had some stroom waffles and so on. But yes, it was a very good time. And we had the Dev Summit on the Friday before. We got quite a bit of work done, including the list of project ideas for the Google Summer of Code for this year was very, very bare. I think there were 3 ideas, and that was it. So we got together and brainstormed one afternoon and came up with 10 extra ideas to put on the list, which helped a lot.
Okay.
Baptiste, Bernard Spill, and myself looked at some of the SSL stuff and what it would take to transition so that the base SSL is private or something like that. So Bernard had made a list of programs that depend on OpenSSL in base, and we looked at them, and I actually deleted one of them. There's a command line tool called BDES, which allowed you to encrypt and decrypt files with regular DES, not like triple DES, just plain DES. And it turns out with an initialization vector of 0 always. So it was really, really bad encryption. So I deleted that. We actually moved it to ports because it turns out there is still one use for that program. Kirk McCusick encrypts the videos for his online class with it.
Well, you got to keep Kirk happy.
So we moved it to ports, actually based off, he has a package for it on his website because not everybody taking his course necessarily maybe runs FreeBSD. And so he had the plain C version of it up on there. So we turned that into a port for people that still need it. I thought originally that you'd be able to just decrypt it with OpenSSL, and you kind of can. Right. So it because this DES has a block size of 8 bytes, right? So it encrypts 8 bytes at a time. And so because not every file is exactly divisible by 8 bytes, you have a partial byte at the end. And the BDES program encodes as the very last byte a number between 1 and 7 of how many bytes of the block are the actual file and how much is just gibberish. Whereas in OpenSSL, they do it slightly differently. I'm not actually sure off the top of my head what they do, but it's encoded differently. And so when you use OpenSSL to decrypt it, you get the entire file except for that last partial block. Somewhere between 1 and 7 bytes of your file might be missing, which makes a big difference in a video file, whether it will play or not. And so we couldn't just replace it with a shell script that did it with OpenSSL, sadly.
I was going to say, close doesn't really cut it.
So, maybe Kirk could encrypt it with OpenSSL going forward and maybe actually use something like AES GCM, which will be a lot faster too. But anyway, so we got around to deleting that and looking at a couple other things. And we talked about, we came up with some ideas for package in particular, just talking about our different nits with package and what we wanted to do with that. So package 1.10, it's currently 1.9.99.11 or something like that in the ports tree under package-devel. Will be released as 1.10 very soon, so please go test that for bugs. That'll fix a couple of things, including locking over NFS. So if you're booting a machine with no disk and it's all doing over NFS, the locking will work correctly. That's a configure option you have to enable, I think, though. Yeah.
Oh, so it's not
But
automatic.
it's something you can put in your package.conf and it'll turn it on and it'll all be good. Or you can turn it on with an environment variable as well. So it's easy to script. But some of the plans for package 2.0, which Baptiste has started on now, sound very interesting. And we encouraged him.
Can you share any tidbits?
Well, the
what's
big one
most
is
exciting thing
having
you heard?
flavors and subpackages. So, the stuff we've been talking about for a while, but it would mean that
Yes.
you'll actually be able to get Nginx and Nginx with this module or whatever a little more easily. And also the subpackages will mean things like PHP. Currently, there's the PHP, which is just itself, and then there's a PHP-extensions module, which by default pulls in a certain set of modules, but it's not actually giving you everything, and then you can kind of install things manually ad hoc. But the idea will be to have one package in the porch tree that just builds every possible module and puts the files for each one in a separate package file. And then you can just grab the ones you want, and it works.
That'd be nice. That's a lot of work. But that's going to be
in
nice
addition to
when it gets
that,
done.
for PHP, that'll be slightly easier, but it'll also build a lot faster because currently it has to extract and run the configure once for each module. Whereas with this way, it'll do it once and then package it up separately.
Yeah,
And then Nginx, again, now that it has dynamic module support, it can do a very much similar thing, meaning that you'll be able to get that extra module you want for Nginx without having to custom compile it. So with this, I think it'll solve most people's problems where they have to fall back to ports because the pre-built package from the project doesn't have that one option they need or whatever. And that should fix things up a lot.
Oh, very nice. Okay, so it sounds like a lot of good, new, exciting stuff's coming down the pike here. So our next full episode, we'll have to get into a little bit more depth on these. And
But there's
package 2.0. So excited.
There are videos on from all the stuff at FOSDEM, so you should definitely check it out. Like I said, the My BSD Sucks Less Than Yours was very humorous. I liked it. And the evolution of the transport stack that Tom Jones did was also very good.
Very cool.
I didn't get to see Ed's because I had to go back to the table and help run stuff, and because I managed to get Tom Jones to come outside and do an interview with me, so I had to have to watch out the video. I'll have to grab the video off that.
Okay. Well, cool. It's about time we should start playing our first Cantrill episode because it's going to be a long one, so sit tight. But before we get to that, we have to go to our first sponsor this week, which is going to be DigitalOcean, and the website for that, of course, digitalocean.com. You go there, you get signed up, you create an account, and when you do, use the coupon code FreeBSDNow. There'll be a little section to apply that. Now, aside from letting them know that you heard about it here on this awesome show, it also tells them that you want to get that $10 credit. So what will happen is you'll get a $10 credit applied towards your account, and that can be used for running 2 months of their lowest NVM, which is typically $5 a month. Or if you want to rent and pay by the hour or whatever, spin something up on the weekend, do a little work, you can totally do that as well and stretch that out.
And the interesting thing is,
way to try before you buy.
There's no difference between the two. So even when you're getting it monthly, you're actually paying by the hour, and just the monthly price is a cap. Basically, if you did the math on the hourly, each month would be slightly different price, but it'd be like, $5 and a couple cents. So they basically just set a cap, depending on the size of your VM, of what the price will be at the monthly price. So that means, if you started today, which is like the 15th, it means you wouldn't actually pay $5 for the first month. You would pay like $2.60. And then you'd only pay the full $5 a month on next month when you spend a whole month. And actually, because it's February, you'll probably pay a little bit less.
Right? Shorter month. Yeah, it's good. It's definitely good. And of course, the cool thing about DigitalOcean, which we've told you over the years, is they support FreeBSD. Like they have it, it's a button. You click it, boom, FreeBSD deployed.
ZFS.
That's right. That's right. So definitely some cool options. Of course, if you're an Open or Dragonfly fan, don't worry. You can make that happen too. They got you covered. Nice HTML5 console and interface will help you get everything you need done.
And if you're paranoid, you can even use that interface to do full disk encryption on your VM, and then use the console to enter the password at boot time, even though that password, that's before the operating system is even loaded, because their console is a real console.
Yeah, it's really, really nice. So check it out. They get locations all over the world. So if you want to find a data center close to you, great. Want something far away, great. You can do that as well. Check out their website. They have a nice little speed test and ping test that'll tell you, which data center, what kind of bandwidth you can expect, and what kind of latency. So definitely check them out today. They make the whole just deploying FreeBSD or heck, even Linux up in the cloud really painless and easy. So definitely check out DigitalOcean today. Okay, so our first Cantrill episode starts now, so buckle up. You're in for a wild ride. I know it was. I didn't know what to expect when we did this interview with him. It just kind of took off.
I had seen one or two of his talks before, but I'd never actually spoken to him in person. And then
it's kind of like drinking from the fire hose and you didn't know it was coming, right?
This is Ubuntu Slaughters Kittens.
That's right. Enjoy. We're joined now by Brian Cantrill, CTO over at Joyent. So first of all, thank you so much for coming on the show with us this week. We appreciate it.
Oh, thanks for having me.
Great. Well, we'll just get right into it. So since we haven't had you on the show before, we got to ask, tell us how you first got into BSD or Unix in general. What led you there?
Yeah, so I'm old enough. My kids know exactly where all the gray hairs are. They may be hard to see, but they're all there. I can assure you. And so I'm old enough that for me and for people of my generation, my first exposure to Unix was when I got to university. So when I grew up I was an abused child and grew up on fucking DOS and Windows 3.1 and everything, and had a little bit of Unix exposure in my high school. I went to a magnet high school, and they had what I later learned was a 3B20 sitting in the corner, and I had a tiny bit of Unix exposure, but I didn't really get Unix exposure until I got to university, and was on SunOS 4.x. And on good old Sun 4Cs, SparkStation 1 Pluses. And for the first time in my life, I actually had true multitasking. And actually there's a picture that actually my father took of me at that first parents' weekend of me gleefully showing off having 4 different terminal windows up, doing an FTP to Woo Archive to download some EGA game on one window, doing an LS on another window. And, and this is obviously all, post-internet, but very much pre-web. And I mean, the idea that you could actually have these things running securely and that the operating system didn't just keel over, and that, that every program was a TSR, a terminate and stay resident program. So it was really mind-bending and amazing. And so I was very kind of excited by that. And again, to kind of be of that generation that I now realize is a bit of a relic that didn't really discover Unix until I was 18. And then was discovering computer science at the same time, was very excited by computer science, and I ended up taking an operating systems course, a very good operating systems course, and got lucky and took that relatively early in my college career, and then decided that I wanted to do OS work. And I was reading, I was on my way home, I remember vividly where I was. I had a layover in Chicago. I went to school in Providence but lived in Denver, so I spent a lot of time in Chicago, but all of it in O'Hare. And I was reading Byte magazine, a little moment of silence for Byte magazine. And Byte magazine was doing an alternative OS roundup. And I had just completed the OS course and had really, really enjoyed it. It was a very intense experience, but I really enjoyed it. And, this was during an era, and I now realize in retrospect that the mid 90s, early 90s, which is when this would have been 1994, was really a bleak period. This is like December 93. This was like a really bleak period for operating systems, because this was when Unix was being left for dead. And that we were going to go to this all Windows world. And Windows was the future everywhere. And where Windows wasn't the future, it was in stranger, more alternative operating systems, object-oriented operating systems. So, Sun is going through this very painful Solaris transition at the time. Meanwhile, the cool kids are off doing things like Spring at Sun, which actually, I still have the distro sitting in my house somewhere. But Spring was a total dog. And C++ was in vogue, and it was going to be kind of these object-oriented operating systems. But Unix was basically a relic. C was considered to be a dead end. And Windows was kind of the future, which I was not down with, having been, I'd had enough of that in my childhood. And so Byte did this alternative OS roundup where they reviewed all of these kind of alternative operating systems. And the one that was really captivating was an operating system called QNX, QNX. And QNX was this was when the microkernel versus monolithic debate was very much raging. And we had developed a prototype microkernel in this operating systems course. And here QNX it actually seemed to be a real actual microkernel. And so I reached out to the guy who had actually written the article for Byte. And this is before I realized how the world worked and didn't realize that this was basically an advertising vehicle for the company. But, Sure. And I reached out to the guy, a great technologist by the name of Dan Hildenbrand, who's since passed away. He died really young of brain cancer, unfortunately. But reached out to Dan and said, hey, I would love to come work for you guys as an intern. I'd love to go intern for you guys. And I was a sophomore in school, in my second year of university. I much to my surprise, Dan got back to me and said, yeah, let's have a conversation. I talked to Dan Hildebrand and Dan Dodge, who was the president of QNX. And they were very excited to have me come work for QNX for the summer. So I went up to work for them that summer. And then I worked for them the next summer. And then by then I knew I wanted to do OS development. And I had fallen in love with the challenge of OS development. Because the great thing about developing an operating system is it's really hard programming. And there are lots of different variants of hard programming. Numerical programming can be very hard. Distributed systems are obviously very hard. But one of the things I still like about an operating system is because it controls the abstraction of reality. It is actually responsible for the illusion that is a machine, right? A process has this model that it has this address space and it's that it has a CPU. But of course, that's an illusion that's created by the operating system.
Sure.
And when that illusion fails, the pathologies are so intriguing and devastating in a way. You have these really, for the first time in my life, I had bugs that I thought I'm never going to be able to debug. I actually will die with this bug not debugged. I will die in inadequate, pathetic human, unable to debug this issue. And on the one hand, it was terrifying to have that feeling. On the other hand, when I actually nailed that issue and others subsequent like it, the feeling of exhilaration you get from doing that, from actually solving a really hard problem, and you knew it was hard, or hard for you anyway, because you suffered and you thought you were never going to be able to solve it. And that to me is the definition of a hard problem, by the way. A hard problem is the one where there's a voice at the back of your brain saying, actually, I don't think we can solve this. Right. And you're like, shut up, brain. We need to solve. But there's that voice, that nagging voice. When you have that voice, that's a hard problem. And on the one hand, it's terrifying. On the other hand, it's very exhilarating to be able to solve those problems. And I love doing OS kernel development. Coming out of school, and this is in 1996 now, I knew I want to go do operating systems kernel development. That's what I want to do. Sure. And I was told by a bunch of people that doesn't really happen anymore, that people don't really do that, and that the operating system is a solved problem. I didn't really believe that. I didn't think that the OS was a solved problem, largely because I was actually trying to use them to do interesting work and appreciate it. It's amazing to think that in 1996, anyone could have believed that the operating system was a solved problem. You go back to how primitive those systems were in so many different ways. But that's what I wanted to go do. So I talked to every computer company, everyone that was developing an operating system I wanted to talk to. Of course, there were very few companies that were actually developing an operating system and would actually be, proud about that. Again in 1996. So I talked to BBN, I talked to Data General, I talked to DEC, and in all of these companies, the OS group was kind of this. Was viewed as a fossil. They were viewed as kind of like essential, but basically relegated. Unix was definitely not the future. The future was Windows, which was just nauseating.
Sure.
And there were basically 2 companies on the planet in 1996 that were interested in doing interesting OS work. Actually, 3. Because the third being SGI. SGI was just beginning the transition to a Windows strategy. So SGI in 1995 still believed in the OS as a differentiator, but by 96, 97, they didn't. So SGI, I fell out of, I was no longer interested in SGI, and the 2 that remained were Sun Microsystems and B. Remember B, right? The BIOS. B Inc. And those were the 2 companies that were interested in doing OS development. And I talked to the folks at B. First of all, I knew I couldn't work for B because my mom was like, B like bumblebee? I'm like, no, Mom, not like bumblebee, like the verb to be. And she's like, who would name a company that? And I'm like, well, turns out Jean-Louis Gasset, but never mind. So, when it doesn't pass the mom test, like that's a very real problem, right?
Sure.
So I talked to B, and then I was kind of like, God, is this it? I mean, on the one hand, I love the enthusiasm. On the other hand, like it was a small company, and it was very clear it wasn't an environment that I really thought I was going to learn from. And then I had the very good fortune. So I kind of into this, like I don't know what I'm going to go do. I'm going to talk to Sun, but I don't know if I'm very interested in that. And I had the very good fortune of walking into Jeff Bonwick's office, and in Jeff there was just a total, felt like a lightning bolt from the future. I mean, Jeff, it was exactly what I was looking for: energetic, opinionated, super sharp, and someone that I could learn from. And I knew that I wanted to work from Sun because he was asking me what I'd done my senior thesis on, and I had done it on the end-to-end scheduling model. So recall that this very bad idea that is being unfortunately resurrected by Go and others, where you have many user-level schedulable entities scheduled on fewer kernel-level entities, the end-to-end scheduling model. And Sun had been the proponent of this, and so we're talking about my work. And I made kind of my entree to this. I'm like, well, you may know that the end-to-end scheduling model is very intricate. And I'm trying to basically speak euphemistically to this because I think by this point, I'm convinced this is a bad idea. And Jeff said, intricate? It's fucking busted. And I'm like, oh my God, I want to work here. I mean, this is like, wait a minute, like, didn't you guys develop this? He's like, yeah, but that guy's an idiot. And I'm like, okay, like, yes, this is what I'm looking for. Yeah. This is someone who was invigorated about operating systems, passionate about operating systems development, and I, that was the beginning of the rest of the story in terms of, I got very lucky, and Jeff and I together went and recruited a bunch of other like minds, and around like 97, 98, like if we actually with the team that we're pulling together here. We wanted to be the Xerox PARC of operating systems, pull together, and I actually, in kind of retrospect, I'm amazed at my prescience to realize, even though I didn't realize that it was going to end so kind of apocalyptically, to have the prescience to realize that this is actually a unique period of time. Because if you wanted to do interesting operating systems work in 1997, 1998, 1999, Sun Microsystems was the place to do it. And as a result, we built this unbelievable group of folks who did these incredible things, and containers came out of that time. Zones came out of that. DTrace came out of that. ZFS came out of that. SMF came out of that. The fault management architecture came out of that. Fire engine came out of that. All these things that we're still using today came out of this hothouse in the first 5 years of the 21st century. So it was a very, very exciting environment. So that's an extremely long answer, an excruciatingly long answer to your question.
No,
but those were the kind of foundations for my career and where it came from.
Yeah,
that was the longest answer we've had on the history. But that was great. That was a whole interview.
Quite a few long ones, though. That question is specifically tell us a story, and we like the long ones.
Right.
There you go. Yeah, well, that's the story, or the beginning of it, anyway.
So if you kind of go on with the story, what are the areas of the operating system you're most actively developing currently?
Yeah, so I mean, when we going back to that kind of that very important period where we developed all those very important ideas, and Jeff, from the moment I met Jeff, he wanted to rewrite file systems. When ZFS, it took us basically 4 or 5 years to get the operating system to the point where it had sufficient foundation to go build ZFS, go build DTrace, go build zones. And what we're doing now is we're really continuing to flesh out that vision. I mean, we were right on a lot of that stuff. And I mean, and to be fair, jails were right. Right with zones, we were very much we were inspired by what BSD had done with jails, and wanted to take that to an even further extreme. Slightly different design center, not just secure containment, although certainly that is a constraint. But bluntly, Sun wanted to. We were selling machines that were too big for a single application, and we wanted to be able to have different folks that didn't necessarily trust one another run their apps on these very big machines, and the app had outgrown the process in the late 90s, early 2000s, and an app was an entire environment that came with it. So we were strong believers in containers, and then there was this kind of regrettable dead end that we're still kind of exploring in terms of hardware-based virtualization. And I had kind of always thought that I didn't like Zen. I thought Zen was a waste of time. I'm not a huge fan of hardware-based virtualization. We ported KVM to SmartOS actually after I came to Joyent in 2011, which gave me once you've seen inside of that sausage factory, you will come out a vegetarian. I mean, it is absolutely horrific. The things that fall into the hardware virtualization sausage are absolutely horrific. And if you wonder where that gamey tang is coming from, it's definitely from the vermin in the hardware virtualization sausage. And so, I was a really ardent believer in containers, and doing hardware-based virtualization at Joyent made me an even stronger believer. I mean, that's the reason I came to Joyent. After the end of Sun, I was kind of looking to recreate what had drawn me to Sun, and for us, we still believe very strongly in the operating system, and we believe very strongly in containers. And with containers, I joke that we were in the right place for the wrong time, for kind of an extended period of time, in that we saw the advantage of containers, but I think the broader world didn't really get it. And it really took until like the last year for the world to actually get containers. And to the world's credit, the reason they didn't necessarily get containers is, now looking at it in hindsight, we had somewhat of the wrong emphasis, in that we were always emphasizing the operational advantages of running containers directly on the metal, running jails and FreeBSD parlance directly on the metal. And that's great, and you get tenancy advantages and so on. You need to be a bit technical to understand those advantages. What actually connected containers to a much broader audience was Docker's work, frankly, in connecting it to developers and allowing developers to think of, actually, containers are a way of actually taking my application and reflecting the operational nature of my application into this much larger binary. As Roman Shapachnik from Pivotal calls it, a former colleague of mine at Sun, he calls Docker 21st century ELF, ELF being the executable linking format. And that's what it is, basically. It's the new binary. And developers are like, this is great. I can actually develop on my laptop and deploy into production. And that is what is that's been the catalyst for containers. And now people are like, wow, I love containers. I just wish they could be made operationally efficient and secure. You're just like...
right?
Yeah, it's like, okay, yeah, I know. We actually...
It's like, we've had that part first.
Right, we actually did that part first. Like, really funny story. We did that part first. It's like, wow, who would have thought, actually? Yeah. And, and this is where I've always felt that we've got a very much a shared kind of cultural value with the BSDs in general, with FreeBSD in particular, in terms of the way we developed containers is the way that FreeBSD developed jails, but is not the way at all that Linux developed namespaces. And which is there is not a Linux container. A container is an upstack illusion that has been, I mean, that has been basically, it's wallpaper over a lot of air gaps in namespaces and C groups in Linux. You would think, coming from FreeBSD or coming from Illumos or coming from SmartOS, that like, okay, Linux is done containers, so like, where's the container T? It's like, yeah, there is no container T, actually. It's a namespace with C group, whereas like the way we developed, the way FreeBSD developed it is like, no, you start off with a zone T that can't do anything. And it's totally secure, it just can't do very much. And then you slowly add things to it, and so it can do more and more and more, but it's always secure. Security is the constraint, like, obviously. But no, that's actually not the way it was developed. It's just like total facepalm. But so that's the opportunity. I mean, that's what I again still believe in the operating system, and there's still so much to do on all those things. So much to do on SMF, on DTrace, on ZFS, on networking. We still do a ton of kernel development, and so much to do, and especially as we move to this true all container future. Where so what we've done, and I see that FreeBSD's done as well, which I think is great, is we have added the ability to have a Linux system call table, or really actually extended this ability that existed in Sun, but it had not been really fleshed out, to allow you to run Linux binaries directly on a SmartOS kernel, which allows you to run a Docker image in a SmartOS container, or you can run Ubuntu or whatever, and it's actually Linux. I mean, it's funny because one of the major points of principal divergence between FreeBSD, Illumos, SmartOS on one side, and Linux on the other is what is the definition of the operating system. And to the BSDs and to us and to most operating systems, the operating system is the operating system kernel and the system libraries. Like, duh, I mean, is this a trick question? It's like, well, that's actually not the Linux definition of what the operating system is. The Linux definition is the operating system is the operating system kernel. The end. There is no more. And glibc, that's just your opinion, man. glibc is, no, you can have, there can be, why only glibc? You can have other libcs. And indeed, there are other libcs. I mean, there's like, if you want to get into a really strange alternate universe, there's a universe of alternative libcs for Linux. And they're actually pretty interesting. And this thing called Muscle, actually, which is pretty cool. It's a very thin libc, basically. You can't do that for FreeBSD, and you can't do that for us. But because of that definition of the operating system, what it allows us to do, us collectively, BSD and us, well, it's actually not that hard to get Linux binaries to actually execute, because all you need to do is give it a system call table that's convincing. If you give it a system call table that actually executes every Linux system call that something wants to execute, you're done. That's Linux. We've kind of, I've got zero interest in fighting the binary fight, just as I have zero interest in the SVR4 versus BSD-isms. I mean, I just don't care. Because that to me is not where things are interesting. So we've just Linux binaries are effectively first class on SmartOS, and we've got the ability to actually run native binaries side by side in the same zone with Linux binaries, which allows you to actually like detrace your Linux app. So it's like, it's very nice to be able to bring clean water into the slum that is Linux observability. It's like, wow, our babies are no longer dying. It's like, yes, your babies no longer die.
Right.
It's like, oh, we just have gotten used to having 15 babies, and we know that only 4 of them survive into adulthood. It's like, he's like, you don't have to do it that way. Infant mortality is like, we have a solution to this problem.
Yep.
We understand what spreads cholera. But anyway. Stop pooping where you drink. It's amazing the health issues that actually clean themselves up. So we're able to do that. We're able to now kind of bring a different approach. And the reality is that many of the people deploying on Linux systems actually want that. I mean, it's like I think in the non-Linux communities we have thought that people actually, if they don't actually want reliable systems, or they don't actually, they don't actually want ZFS, or they don't want this, they don't want DTrace. It's like, actually, no, that's not it at all. It's that people run Linux because they want to be able to Google their stack traces. That's why Linux. They're not upfront about that necessarily, because no one wants to be like, actually, you know what? I just want to be able to like Google my stack traces and solve my problem. I want, for every problem I see, I want to know that someone else has seen it before me. That's basically what it boils down to, which is fine. I mean, I actually don't. I get the value of that, certainly. So I think the opportunity for all of us in the kind of alternative OS world is, hey, we can actually bring a different set of values, and we can actually go execute these Linux binaries. Because, by the way, the other thing is that we should know is that and the other reason why at Sun we didn't think it was viable to make a Linux binary personality is because Linux was just moving too quickly in 2004, 2005. Well, that stopped, and the Torvalds, to his credit, is more extreme about ABI compatibility than I feel that like we ever were. I feel, I mean, in many ways, he has discovered religion late in life. And like many that discover religion late in life, he's like a crazy evangelical nuthouse he's a total like ABI fundamentalist. Which is great. From our perspective, it's great because, man, pour Lucite over that sucker, and let's have that binary interface be something that we can all commit to, because then we can actually innovate underneath it. Then you can have a FreeBSD kernel or a SmartOS kernel, and you can have CFS, and you can have DTrace, and you can mix and match, and it's an all-open world, and there's a lot of opportunity for OS innovation.
Cool. Well, that's a good segue, because you've mentioned DTrace a whole lot here, and that's something, honestly, we've not talked a whole lot about on the show. So can you give us a little bit of the story on DTrace, how to get started, and where is it used today? Yeah,
so I mean, DTrace got started. I mean, kind of going back to the in terms of my coming out wanting to do OS work. I was working on this end-to-end scheduler on what was then Solaris 2.5, and found that when I even held a candle into the end-to-end scheduler, I discovered things that were wildly broken. No one had done any observability work, and I developed a tool that allowed you to actually see how these things were being scheduled. As it turns out, the user level threads were being scheduled totally pathologically on the kernel level threads, and no one knew because no one had bothered to turn on the lights because the lights hadn't been invented. And part of doing that, I used a truly, truly terrible in-kernel instrumentation facility that had been introduced in Solaris 2.5 called TNF. TNF stands for Trace Normal Form, which is just kind of tells you all you need to know. And TNF was basically the best thing out there, and it was god awful. And I'm thinking like, man, it seems like what you should be able to do is dynamically, safely instrument kernel text to be able to revector control into something that could actually instrument the system arbitrarily. So when you didn't want to actually have it on, there'd be no effect. It would just be the instructions, and then you could revector control when you wanted to. And so I was kind of running these ideas for instrumenting running program text and running kernel program text in particular. I was running this by some folks, and one of the things I heard is like, yeah, that must be impossible, because if they could have done it, they would have done it by now. This is, more in this theme of like, everything's already been invented.
Yeah, everything's solved.
Everything is solved. So if there's an open problem, it's tautologically unsolvable. It's like, Jesus Christ. I mean, one thing I have vowed is to never do this in my life, because if you are kind of intellectually coming of age, that's a suffocating message to send to a 22-year-old who's excited about solving unsolved problems in the world. To basically say like, hey, bad news, everything is solved, and the stuff that's not solved is tautologically unsolvable. It's like, well, everyone should go kill themselves now. It's like, no, that sucks. I was like, but at the time, I'm still basically a kid. I've got an adult that has told me this, and I'm like, okay. So was talking to Bonwick, and was interviewing with those guys, very excited, and we were coming back from lunch. We were in Bart Smalder's minivan over the 101, coming back on Willow Road. Remember very, very vividly where I was, sitting in the backseat with Jeff, sketching out DTrace, what became DTrace. And actually what I wanted to know was, I know that this is impossible. I just want to understand why this is impossible. And Jeff's like, no, that sounds like that would work. I'm like, okay, so why haven't you done it? It's like, I don't know, man. Like, we just haven't done it yet. Like, we got a lot of shit to do. We just haven't done that yet. And I'm like, okay. He's like, you should come here and do that. Like, okay, noted. Much more invigorating, a much more invigorating and inspiring kind of attitude. And so, that is more or less what happened. I came there in 1996. I had DTrace kind of at the back of my mind. In 1997, I remember vividly because it was my birthday, in December 1997, we were working on a benchmark. We had the E10K, God bless it, the E10K, Sun Microsystems E10K, the best acquisition in the history of the computer industry. So the backstory there is that a division of Cray called the Business Systems Division had developed the RS6400, I believe was the name, which was a 64 processor Spark-based machine at Cray. And this is like, it's the Business Systems Division of Cray, which is to say the division that actually is like going to make money as opposed to not.
Sure.
All right. So SGI buys Cray. And it includes the business, this machine, the Spark machine. Well, obviously they're not going to it's SGI. It's kind of still at the, just coming off the height of the SGI versus Sun kind of, cross-peninsula rivalry. It's like the gangs of Mountain View. It's like if they do a West Side Story for Mountain View, it should be SGI versus Sun in 1995. When you're with IRIX, you're with IRIX all the way. Anyway, this is one of these things that's like small demographic, I think, would be attractive to this. We're just kind of coming off that rivalry. There's no way SGI is actually going to ship this product. So instead of doing what they should do, which is put a bullet in its brain, they decide to sell it to Sun. But of course, Sun's like, who else is going to buy this thing? And Sun paid, I believe the figure is still undisclosed, but it was well south of $10 million to buy this division. That division did $1.2 billion of revenue in its first year at Sun. That's a pretty good acquisition. And so that box, this is right after that acquisition. That box is a monster. It's the biggest box we've ever seen. They're running a benchmark with 5 of these things, 64 processors, 64 gigs of DRAM, which the fact that my laptop doesn't yet have that 20 years later tells you that was a really, really, really big machine at the time. It was just an unspeakable Goliath at the time. There were 5 of these machines. One running the actual benchmark is an SAP benchmark. One running the benchmark, 3 to drive load, one running the database. So they would run the benchmark, and they could tell that they were on track to blow away the world record in this benchmark. And then the sad time would happen. And the machine would just stop doing the benchmark and would start doing something else. No one had any idea what. It would spend all of its time in system time doing God knows what for like a minute and a half. And then it would come back, be like, okay, so I got some benchmark to do. And it would continue to rumble on the benchmark. And so these guys are like, what the hell's going on? Like, no, like you were doing so well. Like, you're winning. It's like Usain Bolt, like, stopped to get a lemonade during the 400. It's like, no, Usain, not now. You got to run the 400. Come on, bud. So they're trying to figure out what's going on. And they're pulling in everybody. I mean, this is actually sitting on a huge amount of revenue. General Motors is going to basically buy this configuration if it can hit this number. So when we're talking like real money's at stake, they've got everyone pulled in on this problem. And I ended up being the one pulled in from the OS group. As I was in the Solaris performance group, it was Bonwick and me and Kevin Clark, and I hopped in to actually figure out what the hell was going on. And I could not figure out what was going on. This thing was in the system, and it's so frustrating when these are synthetic systems. We built everything about them, and it's right in front of you doing something frenetically. What are you doing? And the system can't tell you. It's so frustrating. And I was very frustrated and was using the only tool we had was a tool that Bonwick had developed called Lockstat. And Bonwick had added some profiling capabilities to Lockstat. And I was using that very heavily. And then I was taking a modified Lockstat driver, and I was using that to by hand instrument these various parts of the kernel. And every time we'd have to do this, I was loading a kernel module and then unloading it. And if I misstepped, the box would bounce. And that box took 2 hours to reboot. Took 90 minutes to reboot. Yeah. So it's like, and there is no worse feeling. Like, okay, I'm load the new module. Okay, load the new module, and then you're like, enter.
And then your face just turns red, and you can just feel it getting hot.
Your face turns red. And you're like, oh, I'm taking a walk.
Yeah, that's lunch, guys.
Lunch. Hey, everybody. I'm an idiot. Ring the bell. So that was very frustrating. And I'm like, man, this is there's got to be a better way. But the entire time we were chasing that problem, I'm like, on the one hand, there has to be a better way. On the other hand, like, this is a very unusual problem, and there's clearly there's a kernel issue, a networking stack issue here. That's what as we were honing in on. And we found a bunch of things that were symptoms of the problem. We found something that was like quadratic in terms of time. And then, so we kind of fixed that, but then it didn't really improve the performance. And it was kind of like one of these things like, well, this is quadratic, but this list should never be this long. What's going on? And again, we couldn't instrument the system, so we just had no idea what was going on. Mm-hmm. And we finally, after 2 weeks of literally around the clock, around the globe work, where you are actually like handing off your state to someone who just woke up 8 time zones away, right? Around the clock, around the globe, we figured it out. And the problem was the box had been misconfigured. It had been misconfigured to act as a router. And totally unrelated, there was a router that had a busted firmware rev, and every couple of minutes, every like whatever it was, 15 minutes, 30 minutes, that router would just pop and reboot. So the router pops, and all these things are like, God, we're trying to route packets. And this E10K, this benchmark E10K, one of the world's most expensive machines, is like, I could be the world's best SAP server or the world's worst router.
Right.
And I know it. Yoo-hoo, I know how to route packets. And so it would sit there and route packets, like da-da-da-da-da, and then finally, like, the router would come back online, and it would start routing packets again. And then you take it back, all right, now I'm back to benchmarking work. So it was doing exactly what it was told to do. And it's like, oh, God. And for me personally, this was chilling, actually, because my assumption was this is so deep in the innards that, yes, it is horrific that we are taking so long to solve this problem, but this is a problem that only we could have. Mm-hmm. And then you realize, like, no, wait a minute. Anyone could do that. Anyone could do that. That was, I mean, it's like Etsy no default router was not set. This is really, 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 really easy to do. This is like a common error. And you're just like, wow, how does anyone diagnose these systems ever? It's like, doesn't this mean that there are a lot of systems that just randomly suck and no one's able to figure out why? As it turns out, yes, that's exactly what it means. Mm-hmm. And like, man, we have to do something better. So, I mean, the ideas for DTrace were kind of at the back of my head, but I'm like, man, we got to do this. I got lucky in that I was able to kind of to recruit a friend from school to come out and work for us in the group, Mike Shapiro, and I convinced Mike once we kind of get things stabilized with respect to a bunch of other stuff, we got to go work on this. And starting in the fall of 2001, we started working on DTrace and realized pretty early on that, like, wow, this is going to be a project that stretches us to the very, very limits of what we can go do. Mm-hmm. And worked on it through 2002. And we actually, I remember very vividly giving a presentation. By the time we started working in November, by the time we hit March, we were at the point where we had enough of a prototype where people were like, wow, that's actually pretty amazing that you can go do that. And demonstrated that for the kernel group, and had at that point, because we kind of given ourselves 6 months of total focus to prove that this was a viable path. By that point, we'd kind of proved that. We added Adam Leventhal to the team, who was another engineer who we recruited to join us, and that was a really essential addition. And then the three of us, basically starting from March 2002, finished it up, shipped it put it back in September of 2003. I was married in October of 2003. That was a fun month. And then I continued to flesh it out for the next couple of years, basically. Mm-hmm. And when we had done DTrace, it was done kind of for us for that E10K problem, but had a hunch that actually we're going to find a lot of issues with this. And oh my God, I mean, we just found it was fun. And it's always fun to go in a system that has never had DTrace run on it. And actually it's been great to have this experience all over again with Linux and be able to run DTrace against like Ubuntu logging in. I mean, Ubuntu, I mean, slaughters so many tens of thousands of kittens every time you log in. It's just ridiculous. You're in this, again, this target-rich environment. And when you're in these target-rich environments, you just discover so much that's suboptimal, so much that's broken that people have just kind of accepted. It's like, I don't know, I guess it kind of works. It's like, actually, no, it's terrible. I think that the world was really ready for it. It was overdue. And there was a lot of, we got very lucky. We were in the right place at the right time, solved the right problem. And it took off. And people were excited. I think it gave some real substance to what we've been saying about, like, actually, we've been the ones really focused on OS innovation, and that's going to pay off. And then, of course, when we went to open source the system, very excited that DTrace led the charge and was the very first component that we open sourced, because we didn't view open source at Sun. Open source was not capitulation. It was not actually like, well, we're just going to open source the dregs that we're not working on. It's like, no, we're going to open source the crown jewels, and we're going to start with the crown jewels. So actually, the very first piece of the system we open sourced was DTrace in January 2005. We didn't actually open source the rest of the system until May, because it just takes a long time to open source things, as I've learned the hard way too many times. And then DTrace from there, and it was going to be interesting. It's like, well, when is this going to show up in Linux? Because at the time, and again, I was naive, I thought that, like, there was so many folks using Linux wanted DTrace. I'm like, this is going to show up overnight in Linux. And I underestimated one of the most powerful forces in technology, and that is the not invented here syndrome, NIH. And actually, Linux as a community was not really interested in the best tool for the job. And in particular, at that time, just had come to caricaturize Sun in this kind of ridiculous way, and very much had a, like, Linux was kind of a teenager to Sun's kind of teenage parent. And there was a lot of kind of I hate you slams. They just could not deal with the fact that actually we'd done some pretty interesting work, and had no interest in actually taking DTrace. So DTrace kind of went to every other system except for Linux, and it went to FreeBSD. FreeBSD was one of the first systems. John Burrell, who has unfortunately passed away, but was a terrific. Got to know John. John was such a character, and I really an engineer's engineer. John kind of led the charge with FreeBSD, and then the Apple folks wanted to meet with us. We were working in San Francisco at the time, and they're like, "Oh, we want to talk to you about DTrace." I'm like, "Look, a lot of people want to talk about DTrace, so like, well, why don't you come down to Cupertino and you can come talk to us about DTrace?" It's like, yeah, like, why don't you, jump in a lake? Like, I'm not gonna go down. Like, I'm not gonna go down to Cupertino. There are essentially zero conditions that would get me to go down to Cupertino. Coming from, I live in the East Bay and work in the city. Like, no way. And they're like, okay, like, well, if you want to talk to us, you have to come up to San Francisco. And they're like, okay, how many people can we bring? Like, I don't know. How many do you want to bring? Like, well, can we bring 10? It's like, you can bring 10 people. Like, what the hell is this? So we sit down with these 10 Apple engineers, and immediately one of the engineers is like, so there's a code path where you have PID-lock held and acquiring P-lock, and it seems to me that there's a lock ordering issue here. Like, okay, what? Like, this is like, we went from, like, all of a sudden they're asking these, like, super, super, super in-depth questions about the implementation. And after that meeting, we're like, what the hell is going on? Like, you guys are seriously way up in the underwear of the implementation. And one of the guys like, look, I can't tell you anything, but I think classic Apple secrecy, I can get you some tickets to WWDC. And at that WWDC, they announced DTrace has been ported to the Mac. So, which is great. DTrace was ported to the Mac, and it's been ported to QNX. It's been ported to a bunch of different operating systems. Which is great. I think that a lot of people see the value in it, and I personally still use it every day. So, it's for me, I really was just trying to create the thing that I need to do what I want to do with operating systems. And it's very rewarding to still be using the thing that we developed to do that.
Nice.
Yeah.
Another short answer.
No, but keep them coming. So in the mostly kind of Linux-centric cloud world that we're kind of in now, what are some of the main advantages to using something like a BSD or a Lumos or SmartOS for that kind of a space?
Well, I mean, the advantage is that Linux was really not designed for the world that we're in. It's not designed for a world of multi-tenant containers. It's not designed for a world of many spindles and how to deal with that optimally. I mean, it's not designed for a service-oriented world. And if you look at ZFS, if you look at DTrace, if you look at jails and zones, if you look at SMF, at least from an Illumos perspective, SmartOS perspective, there are basically bad knockoffs of all of these things in the Linux world. What they should do is do what the BSDs did, which is like, hey, ZFS is a good idea. Like, it's open source. Like, we should port it. And this is what we do. Like when the BSDs do, and my great regret, and which I'll just apologize for now, but it happened a long time ago, was we should have just implemented KQ. So when we did DevPol first, KQ was done in the BSDs, in part inspired by DevPol. And when we went to go solve that problem in 2001, we did it with, it kind of tried to take the best of all worlds, and we did something called event ports, which is very similar to KQ. But in retrospect, I wish we'd just done KQ, because event ports is so similar to KQ that it's like, well, actually KQ was already available. So if we were to replay that history now, just as BSD ported ZFS to BSDs, we would just port KQ to Illumos, because that's the right idea. And we agree about the right idea. That's not really the way Linux operates. So when Linux went to go do ePol, for example, have you ever looked at ePol? I mean, okay, yeah, so you should do this, because you're probably like, oh, ePol, like, it's probably not that bad. Like, ePol, it's like KQ for Linux.
How bad could it be?
How bad could it be? I mean, ePol post-dates ports from Windows, event ports from, at the time, Solaris, and KQ from BSD. So they can learn from everybody's mistakes, right? Well, that actually assumes the development of a frontal lobe, which Linux doesn't necessarily have. And they just didn't bother at all. And this is one of the things that drives me absolutely nuts about the way that operating system has been developed, is there's no reverence for history. And there's no idea of like, well, maybe I can learn from a previous system and a different group of technologists. Maybe I can learn what they did. And even if I want to go do something that's similar, I can at least I can internalize their experience. Sure. And if they'd bothered to do that, they would have realized that, like, actually what you want to do with ePol, which kind of feels like it makes sense. So just a brief kind of tangent on a tangent here. So the way that when we first went to solve this problem in the kind of mid 2000s, late 90s, rather, it's like 97, 98, 99. The problem is, it's the internet's here, that's great, I've got tons of connections, and now select and poll are a dog. Because the semantics of select and poll are, every time an event is ready on one of these things, I've got to scan the whole thing. And that sucks. And the first kind of thought that we had, actually it was a Bonwick's idea, actually, in like 97, is, try to be sleazy. In that, and you always, there's a very fine line between sleazy and elegant. And, often, sleaze that you get away with is actually elegance.
Right.
And elegance that you miss the mark with becomes sleaze. And, sometimes you think like, wow, if I just do this, I can solve this problem. And the just do this was, so let's keep the basic poll model. I've got a set of file descriptors I'm interested in. But instead of actually scanning the set every time, I will just tell you which one is ready. And so instead of having poll the system call, I'll give you a device interface, that's dev poll, and I'll tell you which FD is ready, but other than that, it's the same poll interface. Okay, feels great. So we do that. And then we discover it's got a fatal flaw that's pretty subtle. And the fatal flaw is that when I tell you about an event, if I haven't deregistered that event, that is to say, if that event can happen again, how does the thread that has consumed that event prevent another thread from consuming that same event? So data arrives on a socket. So FD5 is ready. So I'm going to tell you FD5 is ready. Well, FD5 is still ready as long as there's data on it. So the fact that there's data there means that FD5 is ready. So another thread comes in and is like, hey, what FD is ready? It's like, oh, FD5 is ready. FD5, and I'll give FD5 to 2 separate threads. It's like, well, that's bad. Mm-hmm. And then all of the ways of dealing with this, you're like, oh, okay. So that means when I give FD5, I need to say FD5 is no longer ready. But then, and we kind of like played this out mentally. It's like, no. But then what if more data arrives on FD5? Then I've given FD5 out to 2 threads again. But because there's data that arrived a little bit later, but it's that same connection. It's that same logical connection. Now, again, this is where we had the frontal lobe to realize that making that edge triggered instead of level triggered is fundamentally a bad idea, but where Linux would later just would gleefully quote solve this problem with edge triggered events. But that doesn't work. What we actually needed to do is like, no, when FD data's on FD5, we need to say I'm going to enqueue FD5, and then that FD is no longer associated with the event source until the thread that I've given it to says so. Mm-hmm. And that's the KQ model, and that's the event port model. Is that when an event happens, it's automatically dissociated from its underlying event source until you, the thread, reassociate it. So I assumed that ePOL did the same thing, but no. What ePOL did is that dev pool model. And it's like, well, wait a minute. If they did that, how the living hell does this work with multi-thread programs? Turns out it doesn't. And the ePOL man page is remarkably frank about all the design defects involved. Mm-hmm. And you're to the point where it's just like, when you were writing this man page, didn't feel like, God, this feels really wrong. But right. It's like just the act of documenting it should have made you realize how pathologically broken this is. And actually, ePOL is even worse than this. And this is actually amazing. In ePOL, the event is associated not with an FD, but with an underlying file tape, effectively. Mm-hmm. You're like, hold on, wait a minute. But there's an FD on like the structure you get back. Turns out that's just a union. Like the FD that you gave it, that is literally like, it's just giving back to you what you gave it. It's like, you can put any number there you want. Like that's got nothing to do with the file. So you take that file descriptor and you move it around, it gets duped around and closed or whatever. It's like, you have the old FD number on it. It gets better than that. Because you're just like, I was thinking of this like, wait a minute. What happens if I fork? So, and this is stunning. You have an ePOL control descriptor. You've got an FD. I'm interested in FD5. Okay, fine. I fork. Okay. I close FD5 in the parent. I'm not interested in FD5 anymore. Meanwhile, in the child, an event arrives on FD5. You get the event in the parent. The file descriptor is closed. It's like, the parent's like, what the hell is this? Like, right. And you're like, okay, like, how do you deal with that one? Like, honestly, like, seriously, walk me through how you deal with that one. And they're like, well, you should have a different structure. You're like, and? It's like, well, you have a different structure, but then it's like, yes, but then, oh, yeah. Yeah, then you don't know when to free it. Like, you have a structure, fine. You have an opaque structure, a pointer that is associated with this thing. When do you free it? When all children have vowed to no longer receive events on FDs that happen to be open when you forked? It's like, this is the kind of thing that's like, oh my God, it's like, this is where you do feel like the parent of a teenager, where it's like, you are a child driving an adult's body. It's like, where is your brain? Like, what the living hell are you thinking? It's like, that doesn't make any sense at all. You can't build anything with that. And if you read the ePOL man page, like, oh yeah, I guess you can't really build anything with this. It's like, But this is like and this is the story over and over and over again. And they've kind of tried to solve this problem, but they can't. They realize it's unresolvable. And again, not an ounce of self-awareness or reverence for the fact that, hey, by the way, jerks, some other people that solved this problem before you didn't have this problem because they thought about it. Right. It's like, why don't you just do what you should have done in the first place and implement KQ for Linux, for Christ's sake? Mm-hmm. But this is this is the pathological inability to look outside of that echo chamber, mm-hmm. and you don't want to cast too much judgment, but I guess it's a bit late in the day for that. And I mean, as a result, so it's like this is why you don't have DTrace on Linux. This is why DTrace is like everywhere but Linux, and this is why ZFS is everywhere but Linux. It's like, I hope you enjoy your Butterfs. Bon appetit with System Tap. And these are things that have replay. I mean, the ePOL thing is kind of it's an inside baseball difference, but it's important. Whereas like you look at like System Tap and Butterfs, these things have got glaring design defects. I mean, the KQ and event ports are T-ball compared to ZFS and DTrace and jails, and I mean that stuff is a lot harder. And if you got the little stuff wrong, I mean, if you can't get yourself to high school on time, it's like no, like trust me, like there are much bigger problems, and much harder problems, and that's the. So anyway, that was another long answer that I guess disappeared into kind of a ranty black hole.
Someday historians are going to go back and watch these interviews and stuff and start writing the history of all this stuff that happened in the 90s, and it's going to be epic.
They'll be like, wow, we didn't realize that mental illness had such early onset, was so common in that there was apparently an early onset pathology of dementia.
Right. Well, as kind of a follow-up to the original question, though, we were talking about the BSDs and Illumoses. So what do you think, what are areas that could be improved in both of these?
Well, I mean, I think the container revolution is here, and I think that that it's a target-rich environment. So, I think that for us, we're really focused on what that looks like in the cloud with elastic infrastructure. So, running, I think the Linux binary interface that's here. That's like that should be, and I think both systems. And it's been great to see. The BSDs have done actually what we've done in terms of supporting Docker via the Linux emulation, and I really want that to be first class in FreeBSD as well, because the more of us that do that, the better. And the more we can say no, the ABI has stopped. Like that is like the end of ABI development. The more we can focus on that downstack infrastructure in terms of ZFS, in terms of zones for us, containers, the jails for FreeBSD, and there's tons of stuff to go do still. As we move to this world in which we've got increasingly interpreted languages, distributed systems, we've got service-oriented microservices, service-oriented architectures. There's a lot that the operating system can go provide in terms of debuggability, in terms of performance. It's like all of the OS problems to me are more current than ever. I mean, I'm more energized about the OS as an axis of innovation than I ever have been, really. I continue to believe what I've always believed, which is you can do things uniquely in the operating system that you can't do in other layers of the stack. And that's not to say that those other layers aren't important. The other layers are really important, more important than ever, but you can go do really interesting things in the operating system. And when you can depend on that, when we can depend on ZFS everywhere, when we can depend on DTrace everywhere, we can begin to go build interesting up-level abstractions. So,
so speaking,
a lot to go do.
Yes.
Yeah, for sure.
And meanwhile, and then there's also the I mean, I think you see this in the Linux community as well, where they're kind of solving all these things badly. But there's certainly the passing of the popcorn, watching the systemd total fiasco, and I mean, you should have. I mean, just as like Oracle is helping Postgres, I think systemd is helping alternative operating systems a great deal, because they are actually systemd is one of the first things where I feel that. The arrogance of Linux is being pushed too far, and it's being pushed on a community that is actually not so into it, and people are beginning to look for alternatives. Which is great. I mean, they should look for alternatives, and we're in an all open world, so there should be the more kind of mutants, the better. I think. I think choice is good, alternatives are good, and especially when there's a lot of hard problems to be solved, we should be able to borrow one another's innovation. We should be able to, in different innovations are going to come from different places, and we should be able to create different mutants that incorporate those innovations.
Yeah, there's only so many of us. We can't waste a bunch of time all working on the same problem when there's so many problems to solve.
There's so many problems to solve. Yeah, and I think again we're in this. This is what I love about being in the all open world. in the all open world, we can go solve problems that are that might be interesting to only a particular company, a particular startup, and provided that and hopefully, although ultimately, at least with us and with FreeBSD, it's up to that company to figure out to what degree that's going to remain proprietary versus being upstreamed. But we believe strongly in upstreaming all of our stuff because we want other people to leverage it, and we want people to be able to leverage what we're doing to do. I mean, I don't know how much it can be done, but I would love if the Linux layer that we built could be used by FreeBSD. Certainly, it can be used as a reference to be able to go to be like, okay, hey, how do these guys do this? How do these guys do that? And let's improve each other. I mean, that's the whole. To me, that's what we can do now, and we couldn't necessarily do that 2 decades ago. I mean, when I contrast this era with the era that I came up in, it's just no comparison in terms of the potential and the excitement and so on.
Yeah. So kind of speaking about Upstack and about, not reinventing things when the problem's already solved, could you tell us a little bit about how Joyent uses NetBSD's package source and the Joyent repository?
Yeah, exactly right. A totally good example of so for SmartOS, we needed a packaging system. Really didn't want to reinvent the wheel there, and loved what NetBSD did with package source. And really the emphasis on being able to compile these things from scratch. And so we developed package source for SmartOS, and we've been using it. And then Jonathan Perkin, who leads the charge on that at Joyent, also generates packages for the Mac as well. Which I think has been a huge community service. And so package source for us was it's the right model. It's a really thin, lightweight model. It's kind of a sensible model. And there were a couple times when we kind of, because package source is not necessarily used by everybody. And there were a couple times when we reevaluated, like, okay, is package source actually the right model? And every time we would do a kind of a comprehensive evaluation of packaging software, we would come back to package source. It's like, actually, this is what we want. This works really well. We're happy. I mean, it's been great for us. We've been able to engage with that community and contribute. Jonathan, there's a package con every year in Berlin that Jonathan's able to go to. So that's been great and a good example of how we like to be able to take the best from all worlds.
Nice. So how's the relationship going between Lumos and the BSDs? Are you guys sharing code regularly, or are there any other interactions besides maybe ZFS and DTrace at the moment?
Yeah, I mean, I think ZFS and DTrace are obviously the big ones. I would say that ZFS is probably the big one right now.
Sure.
Which is great because we've got there've been Justin Gibbs has been huge and Justin's been doing a bunch of stuff. And contributing that back to Lumos. Lumos remains the repo of reference for ZFS, but it's the repo of record. But it's very important to us all collectively that it continues to operate very well on FreeBSD. That's kind of, we've got areas of collaboration there, areas of obviously collaboration with package source, and then I just think a bunch of Upstack stuff where we've got, we have basically shared values, so when we go into a Docker community, or say, the ones in the room that we're going to agree with are going to be the FreeBSD folks.
Sure.
And so, it's very helpful. You see things like Jetpack, which is, which I think that's a Rocket implementation on FreeBSD. That's great for us. We really encourage, for us, because the driver model is broadly compatible. If we can get driver support for FreeBSD, we can usually turn that into driver support for SmartOS. So we're talking to IHVs. We're really pushing hard for FreeBSD drivers. And we hope that, I don't know if it's been the case, but if there's been hardware that has had SmartOS support but not FreeBSD support, hopefully the presence of the SmartOS support has made the FreeBSD support easier. I view that there's a lot of opportunity for collaboration and cross-pollination because, again, there are so many shared values. I also like I think that even though the distinction is kind of historical at this point, I would liken it to the distinction between, two cities that may share values. It's like you shouldn't nuke one city and all move to the other city. It's like, no, it's like that there are these are things that you can that you can learn from one another and you can share with one another. And I think that having a community that is there's a broader community of shared values, and there's kind of fluidity among the actual specific OS camps. But then having those specific OS camps also helps in terms of actually getting specific about what that innovation looks like. So to me, it's a very healthy relationship. It's been great so far. I mean, it's always been very viewed FreeBSD as a very important cousin or even sibling to SmartOS and Illumos.
Cool. So what are your thoughts on the differences in the container systems? Like, could you tell us a little bit what's different about Solaris Zones compared to FreeBSD jails?
And that is where I will have to confess a little bit of ignorance in terms of FreeBSD jails. I would say with zones, we really tried to take it to its extreme. We were really focused on multi-tenant operation. So, for example, and I don't know if this is true for jails or not. Every zone gets its own IP stack. So we have its own net stack. That's also been made to be very high performance. So you're totally isolated from a security perspective, from a networking perspective. We've got a VNIC architecture where we create a VNIC per zone or multiple VNICs potentially in a zone, and give it its own networking stack. That's very deeply integrated into the system. We've done things. I'm not sure what FreeBSD has done with like DTrace integration, but we've allowed you to run DTrace in the zone. For us, and I imagine for jails as well, but you can have root in the zone and there's no real effect. I think shared values, I would say that we've been really focused on the multi-tenant use case. That's been our the public cloud use case has been our kind of driving use case. And then we also use zones as containment for hardware-based virtualization as well. So we ported KVM to SmartOS, but when we run KVM QEMU, we actually run that inside of a zone. So that if should there be an exploit, should you say, for example, exploit the floppy disk controller and get out of there, you just find yourself in a zone that can do nothing. It doesn't actually have the privileges to do anything. So I think they're pretty broadly similar, albeit with different histories and so on. But I think that certainly, at least from my perspective, very shared values.
Yeah, they're more similar than they are different, especially compared to some of the other options.
Yeah. So are there any other interesting Unix-related stories you'd like to tell us? Alan, I know you mentioned something about a blog post this weekend, so I don't know if that's one you want to discuss. But
originally when I wrote the question, it was the story about Tail that you told at one of the conferences in the lightning talk, but that was an interesting one. I'll have to put a link to that one.
What's that?
I'll have to include a link to the YouTube video for that one.
You have to include a link to that one. I don't know if I can summon up the rage. All that rage on EPO earlier is kind of like, man, I'm getting hypoglycemic with all that EPO rage. I'm worried that I'll just like pass out on the keyboard if I talk about Tail too much. It is kind of funny that the one of the things that I like, and I know that the BSDs also like, is we've got a source base that's 40 years old. We got a source base that is just slightly older than I am. I was born in December of 1973, and Unix was born in August of 1973. I like that. I kind of like I like that because I think that we, for better and for worse. And actually, one of the funny things actually about Tail, unrelated to that particular, what you're referring to as a Surge 2013, I think, lightning talk, in which I went into the Tail minus F does not do what people think it does. Tail minus F has got a lot of issues, but that we've resolved, and BSDs have resolved as well, actually. But one thing that's funny is that that Tail existed long before Head. That Head did not. Which is kind of funny. Do I have that inverted? I may have. I reserve the right to have that inverted. No, I don't think I got that inverted. I think that's right. I think that there's like a 10-year gap between Tail and Head, and you'd think like, isn't one obvious the other? But like, no, apparently not. Which is kind of funny. It's fun to work in a system that is so. Fun for the really ancient Unix isms. Some of the SVR4 isms we've actually tried to rip out that you guys don't have. Because remember that AT&T, after the Bell Labs those guys split off and the BSD split off, this is truly like ancient. This is like the way back in the day, the Peloponnesian Wars. Way back in the day, the AT&T did a bunch of crazy things. They did like this crazy menu-driven thing, FMLI. If you remember that, like go Google that if you want to get something truly weird. And so we've been ripping a lot of that out, a lot of the truly weird SVR4isms, and some of those things are just too strange to live. And that's where you get into like really the true Antiques Roadshow, and things like I discovered one year the BFS command, which is you're like, oh, like breadth first search. It's like no, not that's not breadth first search. That was the big file scanner. It's like big file scanner. That does not sound right. That's not right. So you discover things like that, which kind of are either enraging or amusing, I guess, depending on
especially what the definition of a big file would have been when it was written.
Yeah.
Yes. Oh no. It's files up to 1 megabyte, I believe. It's like, right. Ooh, hey. It's pretty funny. But I like having and I think some of these ancient Unix systems we kind of dealt with. I do think it's kind of funny. I don't know what FreeBSD has done for this. If RM minus RF of slash. I don't know. What does that do on a FreeBSD system?
Works. It does what it's supposed to do.
Ooh. Okay, now we get into an interesting. So, many years ago, we made that not work.
Well,
we made that.
It doesn't work because certain files have file system flags that make them immutable. So even root can't delete them.
Right.
So you can block it.
So we did it, what we ran it, and I would recommend this is a Lumo system that I would recommend borrowing. But what we found way back in the day, there was a bug in patchadd. Patchadd being patchadd, ancient history, of the many things that I don't remember fondly, Solaris patching is probably first and foremost among them. Solaris patching was always a disaster, and patchadd was the command that did this. Patchadd took this kind of tarball that wasn't tarball, it was CPI archive that was a patch, and it very much expected that this was a patch issued by Sun, and if you gave patchadd something that was not a patch, it had this really nasty bug. It was a shell script, and it would do an RM minus RRF of $1/$2, and $1 and $2 would both be unset, right? And this is how you end up in this like really nasty trap where a shell script is like, oh, I'm just going to do an RM minus RRF, and you're like, no, yeah, that was slash. So the compiler group issued a patch that was actually a tarball, and the first person to get a hold of this. The first admin to get a hold of this is like, all right, I'm going to go add this thing. So add the patch. And it's like, the machine's like, rumble, 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 rumble. It's like, oh, okay. It's like, it's working. Great. Like, she goes off, gets a cup of coffee, comes back, and it's like, can't remove /devices /. It's like, that seems weird for a patch. Can't remove /net /mumble /other machine. It's like an RM minus RF of slash actually will obliterate your network if you let it. Right? And so she reports this bug, and we're like, "Oh my god, we're so sorry! Like this is the worst bug possible. We nuclear bombed your system." And we found the bug relatively quickly, and went to the engineer responsible for this. Like, oh my, like, hey, funny story, you have the worst bug in human history. And we kind of walked him through. He's like, well, why are you patch adding something that's not a patch? It's like, no, okay, so like that's a capital crime now? Like that's something that, like you believe that systems should be executed for adding a patch that's not a patch. So we got him to fix the problem. Then we're just like, why does RM minus RF of slash actually do this? Because like this is never your intent, right? It's like we don't need a self-destruct button in Unix. So we're like, okay, we're gonna just eliminate this. But then as you might thinking, like one of the standards guys, and maybe Alan, maybe you got a little bit of this in you, but our standards guy was like, no, wait a minute, you can't just do that because the user has asked you to RM minus RF of slash. The standard says you can't just like choose not to implement the POSIX standard. I'm like, that's ridiculous. Like, I mean, what POSIX test is going to validate that an RM minus RF of slash blows away the system? I mean, it's a little hard to validate.
It's like, well, if you delete the whole system, isn't that undefined behavior?
Right.
Okay, so you're on the right track. So what we did is we took apart the standard very closely, and what the standard says is if you attempt to remove a file that you cannot remove or is not available, there's an error. If you remove multiple files, or you have an RM command that implies the removal of multiple files, and one of them fails, you're undefined. Everything from there on out undefined. So you RM foo and bar doesn't exist, foo may or may not be there. Implementation is welcome to do whatever it wants. Okay. 1. 2, always illegal to remove the current directory.
Yes. And also, you can't delete a mount point if it's still mounted usually as well.
That's right. But it's always, which is also true. But you can't remove the current directory, which for our purposes was even easier.
Yes. Sure.
Because one thing we know about RM of minus RF of slash, it involves the removal of the current directory. So the order in which files are actually removed is implementation defined. So if you remove foo and bar, the implementation can remove bar and then foo, or foo and then bar. It's allowed to pick. So we say fine. Our implementation, RM minus RF of slash, the first thing it tries to do is remove your current directory. That fails, and then the operation fails. And it says removal of RM minus RF of slash is not allowed. And literally, our standards guy is like, ugh!
I've been defeated.
Boy. It's like,
Right?
What is wrong with you? What is wrong? Seriously, what is wrong with you? I feel like I'm talking to my kids. Like, what is wrong with you? Like, we just deleted a person's machine, and all you're thinking about is how can I intellectually preserve our inalienable right to do so in the future? Right. That's wrong. That is antisocial behavior. I mean, this is like pooping on the carpet. Don't do that. Don't do that. Yeah. Other people are here. Come on. Anyway, so we fixed that, and actually it's funny because then the footnote of this is I was telling a customer about that, that whole story. I can't remember how it came up, but as you know, I'm prone to go on tangents from every now and again. And the guy's like, okay, so if I do an RM minus RF slash on Solaris, it won't do it. I'm like, yeah, that's right. He's like, but you're running Solaris on your laptop. I'm like, I am running Solaris on my laptop back in the day. He's like, all right, so do it now. I'm like, do what now? He's like, do an RM minus RF slash as root now. I'm like, on my machine? Like,
right?
He's like, well, you said you did this. Like, go do it. I'm like, no, I don't need to do it. I told you we did it. Like, I don't need to do it. He's like, do it. I'm just like, okay. Like, we did do that, right?
You're like I patched that in, right?
The patch actually shipped, right?
We talked about that, and I'm pretty sure we put that back. I'm like, oh god. And then I'm like, all right, if you're gonna go out big, right? I'm just like, da-da-da, here we go. RF slash. Not allowed. I'm just like, oh, thank God.
Right.
Thank you. But and that's and you saw that this happened with the Steam.
Steam, yes,
recently,
I was going to bring that up.
Right. And it's a common pathology. I mean, people don't accidentally type RM minus RF slash. Shell scripts accidentally do it because they've got variables that are unset. I mean, that's
Red Hat recently did it too with like a GNOME package or something. It was a beta that didn't actually go out to everybody, but they did the same thing.
Totally. It's an easy mistake. It's actually an easy mistake to make. And so this is why we are just like, okay, not allowed. And it's kind of fun to be iterating, because we're still iterating on some of these abstractions and still polishing them even 40 years after they were originally invented, which keeps it fun.
Yeah. And the other one I was going to bring up was exactly a week ago, the patch tool in FreeBSD was patched to, because of a vulnerability, because it runs the patch through ed. You could, in a specifically malformed patch, inject random commands into the patch.
Oops. Wow. Yeah. Nice. There you go. Well, this is like my NROF hypothesis. Mm-hmm. So do you know the story with NROF? No. So NROF was developed. It was the new ROF, and it was developed by Joseph Asana at Bell Labs. And by all accounts, Asana was brilliant. He was one of the ones that he was older than some of the other engineers, and everyone really looked at him. A brilliant guy. And he died, tragically. So he died in 1977. Mm-hmm. And he had generated NROF in C by porting it from the PDP, from the assembly. And no one had or has any idea how it actually works. And if you go into the NROF source, you see things like KK or equals octal 13, J and equals octal 17, if ZZ and octal 12 do, and you're just like, okay. And we still, like, every time you run man on an Illumos system, Joseph Osana is summoned from the grave, and Osana alone is able to generate your man page for you. And supposedly, I don't know if this is apocryphal or not. Actually, I've been able to confirm this or not with him or not. But supposedly, Brian Kernighan went into Enroth being like, "Oh, this is ridiculous. Like, come on, let's just see. I'll figure it out. I'll rewrite it." And went in and been like, I actually don't know how it works. I actually don't know how or why it works. And I mean, all the files have very convenient names like N1.c, N2.c, N3.c, N4.c. But all right, so we still have that code. This is my Enroth 10,000 year hypothesis, is that because the thing about that code is it works. We don't know how or why, but it works. And for the problem it solves, it's always going to work. And this is the amazing thing about software, is that when you actually get it working, people think of software as like, oh, it's always broken and it's fragile and so on. It's like, well, that is true, but it's really like math. And once you get it working, it stays working forever. And my Enroth 10,000 year hypothesis is that in 10,000 years, humanity somewhere will be running Joseph Osana's code, and we still won't know how it works.
Right.
So, I mean, that's kind of why I remain excited about operating systems. Is I feel like we're laying down this substrate that is going to be immutable at some level. I mean, it's not to say that it's solved, but there are problems in the operating system that, like, well, I wouldn't actually necessarily go resolve that, and because the way it's solved is basically it works. And we can move on to other things, go solve other problems. There's still a lot of unsolved problems out there, and a lot of unsolved problems in the operating system. But that's, I think, what I find exhilarating, and of course, open source being a very important point, a very important aspect in preserving software in perpetuity.
So kind of speaking about people not necessarily understanding open source, yesterday we saw that blog post from Oracle about don't reverse engineer.
Jesus. Gift from heaven. Oh, my God. It was, so we saw, Mary Ann Davidson, whose name may live in infamy, who is actually already infamous in security circles and has already just regularly speaks the kind of the Oracle playbook, and regularly talks about how security researchers are basically a problem and that they, the vendor, know best. And it's this very like this amazing, it's this relic from the 90s or the 80s even, about it's like that actually the problem with this is that you found the security issue, not the underlying security issue.
Sure.
It's like it's kind of like the Cold War in that it's like it's hard to remember that, like, oh right, like there was a wall in the middle of Berlin. How weird. Right. But for us when we were kids, like that felt immutable, right? And it's like they're like, wow, vendors didn't want to hear about security problems. Vendors don't believe you should be able to reverse engineer their software. Wow. And of course, having been the one that developed the software that you use to reverse engineer, which was a DTrace, like reverse engineering is something I feel very strongly about. And in fact, I have, if you'll forgive the brief tangent, one of the things we discovered with DTrace is the vendors in particular that could not deal with their software being visible to people.
All right.
And so I had a vendor in particular, ISV, who was complaining about the performance of Solaris relative, this is back in the day, Solaris relative to Linux. Okay, fine, we heard this a lot. And they're like, no, everything's the same hardware, everything's the same. Solaris is a dog, Linux is really fast. Like, okay. And you look at the profile of the application, it's like 100% in user land. And it's like, listen, like we've done a lot of dumb things, but if you're 100% user land, like there's only, like it's just you and the microprocessor. It's really not the operating system. And you, of course, using DTrace basically instantly discovered that it's spending all of its time in totally unoptimized code. It's like this code has been, in fact, and then another second or two, I realized this got debugging enabled on this binary. So they got debugging enabled, and on the Linux binary, it's totally optimized. So you're minus x05, x03, x04 over here on Linux, and you're minus G over here. I'm like, well, there's your problem. I'm like, well, we can't change the way we build the binary. Sorry, so it's got to be faster. It's like, hey, this is a little hard because you've got the debug version and you're comparing it to the non-debug version. It's like, you can't actually do that. Like, there's some physics to the problem. They're like, well, you have to solve it, I'm I'm like, actually, can you please rebuild the software? No, we can't rebuild it. I'm like, okay. So you realize you're also shipping these massive binaries to Solaris because you're shipping your all of the stabs, all of the debug information. They're like, no, like we can't rebuild it. All right, God, Jesus. So it was a half an hour, very frustrating conversation. Like, okay. All right, but let's hear about DTrace. Fine. So I demoed DTrace for them because when DTrace was still very new. I demoed DTrace, and the guy's like, yeah, no, don't like this at all. No. I'm like, don't like what? What do you mean don't like? Like don't like you don't like you can't not like penicillin. What do you mean don't like? He's like, yeah, we need to this has to be disabled for our customers. We can't allow our customers to run this on our binaries. And I'm just like, and unfortunately this was the first time this had happened to me. So I wasn't real now I'm kind of braced for it. I just don't deal well in situations where irrationality takes me by surprise. I just know myself well enough to know that like these are the situations in which people are most likely to call the police. Mm-hmm. And I'm like, what do you mean? It's like, well, actually, like we can't certify on Solaris until you disable DTrace for our application. And I'm like,
oh my God.
I'm like, disable DTrace for, let's see. It's like, I'm like, okay, disable DTrace for application. And I'm just like, my brain just didn't deal with that very well. And I'm like, okay, you know what I'm going to do? I'm like, that's fine. First of all, we're not going to do that. So you can forget that idea. We will always enable DTrace to be enabled for you. And I'm actually going to do something else. I'm actually going to go one step further. You are shipping your entire source code with every binary. Witness previous conversation. I'm going to give to your customers a tool that will allow them to take your binary and reconstruct your source tree. How about that? How about I will see you and raise you? And this guy was like, ah! He literally like both his hands went up. He's like, ah! And all these hands went up, and some people are like, oh my, like what? Like Cantrill just strapped on a suicide vest. I mean, people are literally like, and like 5 people start screaming at once, and I get like ushered out of the meeting, and it was definitely like, and the sales guy's like, what did you do that for? I'm like, what do you mean, what did I do that for? I'm like, I was basically, I mean, so did not deal very well with that particular situation. How did we get here? I'm so sorry. I always try to like leave a path back for myself. And I end up on these tangential rants, but sometimes you go back like, oh, where the birds ate the breadcrumbs. All right, I do not know where I am. I am in a forest of anger, and all I can think about is Reuters was the company. I've got no hesitation naming it. This company was Reuters. And if you talk to people that use Reuters software, they're like, oh, I hate those guys. I'm like, yeah, of course you do, because they're jerks. Anyway, how do we end up here?
Oracle.
Thank God. Of course we ended up here with Oracle. I should have known.
Yes.
Oracle is like the North Star of rage. Whenever you're disoriented, you can just use Oracle to orient yourself. Of course we ended up here with Oracle. All right, so anyway, I believe strongly in reverse engineering. And Marianne Davidson has this blog entry talking about how reverse engineering violates the end user license agreement of Oracle. Just don't do it. And just like, oh my God. And of course, it's like not surprising at all. Of course Oracle believes this. But I believe, like a lot of people believe, that reverse engineering is a natural right. Reverse engineering is like my freedom of speech. You can't, nobody gives it to me. Like that is a right that I have, that I'm endowed with as a person. And I have got the inalienable right. If I own something and it's in front of me, I have an inalienable right to understand how it works. And the patent system may prevent me from duplicating it, and the copyright system, but nothing is allowed to prevent me from reverse engineering. My belief. And I think a lot of people have that belief.
Yeah, that's
whatever. So, I've seen his attitude before, and so of course, my tweet was that the Oracle, if Oracle software engineers need another reason to be ashamed of their employer, here you go. But what was interesting was that people started that a lot of people were paying attention to it. And it kept getting a lot of momentum. Of course, I'm trying to like feed the fire because I think that we are being collectively too easy on Oracle. I mean, Oracle's behavior, and then kind of like there's a frequent lunchtime discussion at Joyan. Is Oracle's behavior actually worse than it has been historically, or did the Sun acquisition merely give them more surface area to behave badly? Because if you look at what they did to Java, what they did to we forget that Jenkins was Hudson. Right? People forget, like Jenkins, like there's a facial scar on Jenkins that we should not forget. That was Hudson before Oracle went totally 100% evil on Hudson, and they became Jenkins. What they did to Illumos in terms of closing the operating system and turning that back and reproprietarizing the operating system. What they've done to MySQL. What they've done to the LibreOffice folks. I mean, just go down the line. You cannot behave any worse than they did. And then they add the kicker, we're going to take Java and we're going to use that as grounds to go sue Google and assert that the APIs are copyrightable, which we all know it's like, that can't be true. If that's true, we have no industry. Mm-hmm. I mean, again, natural right, inalienable right. What they're doing is capital W wrong. And so I always love it when other people kind of when the fire starts building. And then, so like the fire's building, and then she deletes the blog entry. And you're just like, okay, what's that about? And that I can guarantee you, because Ellison does not care. But for my money, that's Oracle legal, because she actually did create a liability for them. I mean, if you think about, you're an Oracle customer, hey, it's like, hey, next time I have a security breach, guess who I'm suing? You. Like, I didn't violate my EULA at all, but you have demonstrated negligence in generating this thing for me. And hey, you know what? I, as an Oracle customer, just might challenge that tenet that proprietary software companies have found so dear, namely that this software is not warranted for any purpose. Right? When you buy software, the cornerstone of proprietary diabolical software companies is that software can't actually be used for anything. And if you used it for anything, that's on you, not on me as the proprietary software vendor. Because if we say, actually, this is warranted for a purpose, then actually, maybe I treat you the way I treat a contractor. And if I have somebody pour my foundation, as it turns out, that foundation then collapses, I'm going to go sue that contractor. I'm going to go litigate that. If a bridge falls down, there's going to be litigation. If software panics, if a database corrupts its data, there's never any litigation because it's warranted for no purpose. So maybe, just maybe, an Oracle customer might challenge that most basic tenet, that most fundamental tenet, and then the whole thing collapses. And I think Oracle Legal is like, yeah, okay, yeah, we need to not get anywhere close to that. So I think Oracle Legal made her take it down. It'd be very interesting to, and then you have the Ed Screven sock puppet. It was like, does not represent the views of Oracle. It's like, very good. Thank you, Ed Screven. Ed Screven is Ed Screven is actually the CTO of Oracle. The person he was the CTO for 15 years. No one had ever heard of him. Anyway, if you need a sock puppet, you can definitely put Oracle Legal can always put Ed Screven on the hand to have some comments. And the comment there was, does not represent the views of Oracle. It's like, actually does represent the views of Oracle. Funny story. But then, and the kind of the epilogue to it is just and this is where I wondered if I was hallucinating or not. Then about midday yesterday, the hash Oracle fanfic tag comes up. And I'm just like, oh my God, this is an internet meme. And I was like literally tears in the eyes. I'm like, oh my God, it was great. And it was terrific. I obviously did my own. I had to have my own contributions. And I felt I was doing a little too many of these. What I was basically doing, I felt a little embarrassed. All I was doing was Googling Darth Vader quotes and then just replacing things with technological terms. It's and it was really, really, your sad devotion to that ancient religion hasn't helped us enforce our EULA. I find your lack of faith disturbing, that kind of thing. Anyway, I was just doing that. It was just too easy. And I felt like I need to stop doing this. And actually, the joint engineer was goading me on, man, you don't know how many times this meme is going to come around. Gotta, if Oracle fanfic is trending, now is the time. Okay. But it was great. Oh my God, it was great. And it was great because I actually do think, and I think this is the kind of the serious point in all this, is that we as software engineers need to have a moral compass. And we don't have a code of ethics. We don't have the way physicians do and so on. But I think it's incumbent upon all of us to have a moral compass. And the way Oracle is acting is fundamentally wrong. It's capital W wrong. And, cocktail conversation about whether they've gotten worse or whether they merely had more opportunity to be bad, but they are actually bad actors. And they're not just big company. No, not just big company. This is actually bad behavior. They need to be held responsible. And we as software engineers need to hold one another responsible. And, it's people are well, are you going to think less of me if I work for Oracle? It's oh, no. Yeah, of course I will. Yes, of course I'll think less of you if you work for Oracle. It's you don't have to care about my opinion, but don't think I'm not going to think less of you if you go work for Oracle. It's your name on the flag. And companies are often incompetent, and Sun was plenty incompetent, and Joyent has been incompetent plenty of times. Incompetence is okay. Malice really isn't. And I think it's incumbent upon all of us to make sure that it's our name on the flag and that we're proud of what we're doing, and that we make our companies and our communities, we make them represent our values and our morals, our principles. Anyway, sorry.
Cool. No, it's all good.
Thank you.
Man, you drop the Oracle match, and it's just,
Right? Gosh, we're gonna have to have like a quarterly segment with Brian or something, right? Brian's rant.
Exactly.
That'll be awesome.
Welcome to Brian's quarterly career limiter.
Well, this has been phenomenal,
Yes,
Ryan. We thank you so much for taking the time to come on with us.
Yes.
Oh, you bet. That's a lot of fun. I mean, obviously, yeah, you winded me up and let me go, and clearly you just have to get out of the way. So I'm sorry to go on so many tangents. So
that was all.
It was great.
Stuff.
That makes it awesome.
Well, and keep up the strong work, guys. I mean, it's been fun to watch it. So I obviously love what the BSDs are doing. Again, it's a great kind of sibling or cousin relationship, definitely family. And let's roll on Unix.
Yes.
Great. Well, thank you so much for being with us, Brian, and we'll look forward to talking to you again in the future for sure.
Yeah.
You bet. Thanks a lot, guys.
Okay. Well, we just got to give you a little breather here before we go into the next Cantrill interview. I mean, I assume
sure
you need a second. So
your stomach is sore from laughing, and you haven't caught your breath yet.
So you need. While we're doing our little thing here, you need to start making your next round of nachos, get some more food, order the pizza that you've been meaning to do. Like, it's time because, we're going to go to interview 2 and 3 here in a minute. So, but before we do that, of course, we need to mention our next sponsor this week, which is going to be IX Systems. Website for that, ixsystems.com/BSDNow, where you can go and fill out the little form, get in touch with one of their sales engineers. And what's really cool and unique about the IX sales engineers is they understand technology. So if you call up and want to talk Unix shop with them, that's good. Like, the more details you can feed them on what you're going to be doing with any particular hardware you're going to purchase, the better they can design it to fit your particular needs. So if you're doing a lot of storage, great. What kind of storage are you going to be sharing with SMB? Is it NFS? Heck, are you doing FTP? Like, those are the things you should probably let them know. Big files, small files. What block size do you want to configure as? What kind of redundancy do you need? Like, again, tell them all these things so that they can help figure out, which drives, what configuration.
Is, everybody wants their NAS to be as fast as possible. But if you could tell them the minimum level of performance you require, it's like it has to be at least this much. Then they can design a system that can guarantee to give you that many IOPS or that many megabytes per second. And then obviously
under worst case conditions.
Right? That's what you have to design for. Is under the worst case conditions of completely random IOPS and all this terribleness, we're going to get at least this much. That way we know that we're not going to end up being slower than what we need and not being able to work under the workload we need.
That's correct. So yeah, IX makes this all possible. So we really do promise, and we've had a lot of good comments from people out in the community who've told us what their IX experience has been like. Yeah. So definitely get in touch with them and tell them you heard about it here, because they like to hear from our listeners. That puts you in a little bit different class of
But user. I won't buy anything anywhere else anymore. It's just so much easier, and I know I can just trust it.
That's right. So definitely get in touch with them today. I think you said they had some sort of new FreeNAS University thing.
Yes.
So what's going on?
They've started up IX University's FreeNAS and OpenZFS training.
Okay.
They say there's lots of ways to get help with FreeNAS. They have the handbook, the forums, the blogs, the videos, the IRC channel, all that stuff. But those mostly help you with the what, dealing with a specific problem you're having, but not necessarily the why. If you actually want to learn about how ZFS works, so there's the two the ZFS and Advanced ZFS books that I wrote, but even that is not quite the same as an interactive class. So our friend and FreeNAS expert Michael Dexter has created a set of video courses for this. So the first one, Introduction to FreeNAS, is 30 minutes and it's free. So you get to try what it's going to be like, get the format and so on, and make sure you're going to like it before you go and buy it. So that talks about, what FreeNAS's capabilities are, the basics of ZFS, like checksums and snapshots and so on, why you would want OpenZFS instead of hardware RAID, and that kind of thing. Then Module 102, which will be available this month, goes into using the FreeNAS wizard to set up your disks initially, navigating the admin interface, determining which RAID Z level best meets your storage requirements. You want more redundancy, even if, it means having to buy a couple extra disks. how to select and use your file shares, understanding the directory services that are supported so you can actually integrate your FreeNAS with your existing network and single sign-on and so on, how to perform basic maintenance tasks, and configuration and best practices and so on. And then they'll have an advanced FreeNAS setup module that depends on you having covered all the material in that first module, which will go much deeper into FreeNAS and OpenZFS in general. So there's a link here to sign up, and
No, that's definitely really cool. I mean, how many storage vendors can give you that kind of expertise all packaged nicely, and they want to teach you about what the best things are you can do with your storage. That's really cool.
Because they can sell you the great hardware and put the great software on it for you, but you still have to end up using it.
Yeah, definitely. So get in touch with those folks today, and we promise your next purchasing experience will be a good one. Okay, so interview number 2 coming straight at you right now. Buckle up. You're going to be in for quite a wild ride.
We're joined again this week by Brian Cantrill, who's CTO over at Joyent. So first of all, welcome back to the show.
Great. Thanks for having me. Fun to be back.
Yeah, your last interview was epic, and I think our most highly raved about episode ever. So hopefully we can build on top of that.
Yeah, the only thing I regret is at one point I got very animated in a story and I flipped off the camera. I wasn't flipping you off, but I was kind of giving the bird as kind of a rhetorical device.
It's a double version of it?
Yeah, there may have been a double version of that. And unfortunately, my kids are now at the age where they actually consume all this stuff on the internet. And so my kids watched it, and I have now lost all kind of moral high ground around the house. And now they're like, they've gone around flipping everything off. So I really got to watch myself. It's dangerous. Anyway, no, it was great. I had a lot of fun.
That turned into an animated GIF meme as well.
It did, apparently. I know. Yeah, it's dangerous. Yeah.
And then there was you face palming was very good. Another animated GIF that had cut out there.
Actually, I actually am kind of worried about developing a closed head injury and having CTE in my forebrain from having constantly facepalm myself. I'm worried that I'll be talking to a neurologist in 20 years being like, are you sure you never played a contact sport? I'll be like, I facepalm myself a lot at high velocity. So yeah, that I need to maybe wear a helmet. Maybe that's what I need to start doing. Is wear a helmet.
So I thought we'd start off the interview with maybe a slightly lighter question than usual. But so which piece of code have you been working on most recently?
Oh, that's a great question. Actually, it's a great question because the thing I did actually my most recent push actually was the rare improvement of the system solely by removing code. We actually had actually a pretty interesting issue. So to give you the backstory here, when we are low on memory in the system in SmartOS, one of the things that we look for are fragmented memory caches. And in particular, the dnode cache can get really fragmented. So you recall from ZFS, we have a dnode T. And if we have a slab-based allocator in the system, in fact, the original slab-based allocator done by Bonwick, and if you have a slab that has kind of a single object allocated out of the middle of it, that memory can't be reused elsewhere in the system. And one of the things we observed many years ago is that the system gets low on memory and it's fragmented at the slab layer. And what you'd like to be able to go do is go relocate and kind of reclaim some of these dnodes. So this is a problem we observed probably 6 or 7 years ago, and maybe 4 or 5 years ago, added the ability to the system to, when it's low on memory, to go move these things. But when you're developing things that are going to act when the system is low on memory, you really need to be very careful about how that's done, because it's very easy to generate really deleterious effects. And one of the things that this thing had done is, if it can't find, I'm sorry, this is a much longer answer than you probably wanted, but when it, so it goes to ask the dnode cache. KMEM says, okay, we're low on memory. So it asks the dnode cache, hey, can you actually free some stuff up? Tell me about this buffer. Tell me about this buffer. And it's asking the dnode cache about buffers. And the dnode cache is saying, yes, you can actually move this. That is, say, you can copy this object somewhere else. Or no, you can't move this. Or I don't know. And I don't know means, gosh, I think I freed this. but I actually don't know. Like, this may be freed and sitting in what's called the magazine layer. So one of the things that was added to KMEM to allow it to scale, added and a work that was done beyond the original slab paper, but was outlined in the 2001 slab paper, KMEM paper, is the ability to have what's called a per CPU magazine. And a magazine, just like the munition term that inspired it, Bonwick's a bit of a libertarian, bit of a goofball in that regard. The magazine holds rounds, and those rounds are actual buffers. So when you free on a CPU, you're kind of freeing into your little magazine. And then when the magazine gets full, there's a queue of full magazines. And if you need to allocate, you're going to allocate out of the full magazine. And all those are kept per CPU. If you get too many magazines per CPU, those go into a global layer, and you get this global layer of full magazines. And this becomes important because what this code used to do, the KMEM move code, it would talk to the dnode cache, ask, do you know about this buffer? Dnode cache says, I don't know. And then the code says, okay, I'm going to hunt the magazines. And it literally had the verb hunt in the function name, and which I almost want to, like, you should never have something in the kernel that's called hunt. You know, we do not go hunting in the kernel. We don't search in the kernel. We need to be very careful about, if we're hunting, that's the wrong verb to have in the OS kernel. So it hunts through the magazines, and it needs to go through all of the magazines on the per CPU basis, which is kind of bad enough because it has to grab per CPU locks. But then it has to go through any full magazines at the depot layer. And the problem is that because we are tight on memory, we've already asked this thing to liberate any memory that it's not actually using. So we have all these full magazines at the depot layer to the point of, like, we had like 3.1 million buffers in this one of the dumps we looked at. So for every buffer that it wants to relocate, it iterates over it hunts over 3.1 million buffers. So this is like order of n squared doesn't even capture it. And because this is happening at a time when the system is low on memory, you end up like, system is fine, system is fine, system is fine, system is terrible, and we have no idea what's going on. And because you're doing this with locks held, it's really hard. I mean, if you've had these problems, it can be really hard to figure out what's going on, because all, your stat tools, your ability to create processes, your ability to instrument the system, everything stops. And then all of a sudden, it writes itself again, maybe minutes later, and you've got no idea what's going on. And we were using DTrace enabling and so on, and we were only seeing this in production, of course, couldn't reproduce this in development. I mean, that's, as always, of course, I don't even bother asking anymore. And finally, we got a dump from this thing, and we were able to iterate on this and figure out what was going on, and found, like, oh my God, this thing is iterating. I mean, over 3.1 million buffers. It's got a lock held. Something else is blocked on that lock. Something is blocked on that. Something is blocked on that. Something is blocked on that. The thing that's blocked on that is the stat tool trying to give us the information. And so we're like, you know what? This whole idea is busted. Like, we should not be hunting magazines, in particular because if the dnode cache doesn't know, first of all, it's very likely that it is free, it's in a full magazine, and it's going to be given back to the system soon anyway. So we can just delete all this logic. This logic never should have existed. It was a terrible idea. I mean, that's a bit strong, but it was not – the emergent behavior was not well thought out in terms of why is this code being called. This code's being called because you're low on memory. If you're low on memory, you don't need to hunt into magazines to defrag a slab because you're under memory pressure. Like all those, any memory that's in a magazine that's been freed, that is going to asymptotically approach being freed because we're under memory pressure. Anyway, so I was able to just delete code, which is great. It's like the diff is just minus. I wanted to make it just deletion, but there were comments that had really embedded this notion in it. So I had to modify some comments and add some comments explaining why we don't do this. But I didn't have to change I didn't have to add a single instruction, which felt great. It feels terrific when you do that. Mm-hmm. It feels like you're removing like a cyst or something. I mean, this is like if you've ever had if you've ever kind of needed something surgically removed that is literally adding zero value. Surgeons love to remove that stuff because it's just like, oh, it's so delicious. You go in, I'm a surgeon, I get to cut you open. I love to cut things. That's why I'm a surgeon. I'm a borderline sadist. I get to cut you open. I get to remove. I get something called lipomas. And I had a giant lipoma, and I still get lipomas kind of in various places. And I had a big one on my arm that was kind of, this is way too much information, as my kids would say, but that had turned into kind of the size of a golf ball and was beginning to really disturb people. So I'm like, all right, I got to get this thing removed. And that like that's what the KMM Hunt magazines was like the lipoma on the arm. And man, my surgeon loved removing it. He had so much fun removing that lipoma. And my father, my father's a physician, whenever he would look at it, he would feel it, and you could see in his eyes, like, I want to cut you open right now. I want to remove this thing now. It's like, oh, it's like this visceral. These people are, anyway. I get squeamish around actual bodies, but I do understand the visceral appeal because I love to surgically remove code. So anyway, I got the surgically remove assist, which was this Hunt magazine logic, and should probably have a collection of verbs that we should just go searching for in the kernel, and just like, wait a minute, why do we have Hunt should never appear in a function name? So anyway, that was that, which was fun. Got to put that back earlier this week.
Awesome. That's a great story. See, this is why we ask you questions like this.
Yeah, you never know what you're going to find, you know? So and that's been a nasty issue for us. I mean, that is actually it's been a really serious issue that is, we run ZFS in production in this production-facing service. And this is the kind of issue that you only discover after years and, really pounding on the system. So it was fun to actually get that thing removed.
Yeah, I've actually run into something kind of similar in FreeBSD with the networking stack, with the specific driver for the network card we have. Our server is in a fairly unusual situation where it actually sends jumbo frames to the internet. So it wants to allocate 9K chunks of memory at a time.
Does that work? Does the internet appreciate that? I mean,
our transit provider carries it across their entire network as 9K and fragments it at their edge when they drop it to somebody who doesn't have 9K.
Yeah, that transit provider is like, oh, brother, it's the jumbo guys again.
They offered when I got hooked up, and I was like, oh, sure, that sounds like a good plan to me.
Oh, they offered. Yeah. All right. Well, then they only have themselves to blame.
Exactly. But, you're trying to allocate these 9K, but pages are 4K. And so there's a little bit and it's like, how do I get 9K of contiguous memory after the machine's been up for a year?
Right. Where the hell is that stupid number from, by the way? The 9K. Also, like, jumbo? Like, that is not it feels like what we call a jumbo mortgage in the Bay Area. A jumbo mortgage in the Bay Area doesn't buy you a driveway in Fremont. I mean, the jumbo frame being 9,000 bytes, where the hell is that number from?
Yeah, because
9,000.
It's not big enough to be jumbo, right? It's like, six times the regular size.
Right, and it's not even like a power of 2, is it? It feels like, it's 8192 plus some. That's what it feels like. It feels like it. I don't know. Be interesting to know. I'm sure the history there is sorted.
Yeah. So before we get into talking about Linux interfaces and that whole thing, could you tell us a little bit about why you have to care about them? Or, you work on SmartOS, which is Lumos based.
Yeah, exactly. Why don't I have
Linux?
Right, exactly. Right. Well, you have clean water. Why do you care about waterborne illness? It's like, well, I normally wouldn't have to. That's why I have clean water. Unfortunately, or fortunately, I guess depending on your perspective. So we implemented, starting some number of years ago, a Linux personality, a Linux system call table on top of SmartOS, LX branded zones, and it allows you to. It actually works incredibly well, in part because of the FreeBSD and SmartOS share a kind of definition of what the operating system is. Linux does not actually share that definition. I mean, one of the starkest points of contrast between the BSDs and the Lumos and so on and Linux is what the operating system is. And for Linux, the operating system is only the OS kernel. It is not beyond the OS kernel. Whereas for you and for us, the operating system is the whole thing. Right. So, for you and for us, LS is part of the operating system. Whereas for Linux, LS is just a program that you happen to run and that you get that from a distro. And this is why you get to kind of the legitimate, old flame fests between GNU Linux and Linux, because so much of what people think of as Linux is actually that GNU stack. I mean, glibc is just one libc that you can run. And, I disagree with that. There are a lot of ramifications of that distinction. I think many of them are negative for the user. There's one positive distinction from my perspective, selfish perspective, and that is that because Linux is just the kernel, if you implement that kernel interface in a totally convincing airtight fashion, if you have a Linux system call table that effectively has all of the behavior and side effects and so on of the Linux system call table,
Upstack apps will just run. Everything just runs once you have the system call table in place and working perfectly. That wouldn't actually be true if you tried to go implement a SmartOS personality on Linux. Would be much more complicated because of the fact that barrier is considered to be much more porous, whereas it's not porous at all. It's very rigid, and they are very, very rigid about ABI compatibility across, which is great for me. It's kind of surprising, because I felt like for many years Linux would just kind of break things, where FreeBSD and Illumos and SmartOS have always, we believe in not breaking user apps. But, Torvalds kind of discovered religion late in life on this one. And, frankly, like a lot of people that discover religion late in life, he's an evangelical. I mean, the guy's nuts. I mean, he's insane on ABI compatibility. They will break. It doesn't matter how broken the ABI is. They will not fix it if it's going to break any app. And that ABI for them is not at the library interface the way it is for FreeBSD and it is for us. That ABI is the system call layer. So if you can get that system call layer working, everything Upstack works. So that's what we endeavored to do. And actually, this was done originally at Sun back in the day, but was mothballed because it was thought that Linux was moving too fast. This is before Torvalds discovered religion. And then we resurrected it about a year and a half ago. I should just say we. It's actually a member of the community resurrected it and resurrected it, got it working, and was using Skype, using the Linux Skype binary on an LX branded zone on SmartOS, and sent out mail to the discussion list being like, hey, this seems to work. There's some limitations, but this seems to work well enough. I think this might be of interest. It's like, yes, that is of interest. Thank you, open source community. I mean, you never know. That's the great thing about open source. You never know when someone is going to come along and do something that you never would have done, right? So that was great, and we resurrected it. That was in early 2014, and spent all of 2014 and a lot of 2015 taking that to its logical completion. And that, which has been great, that has meant I have taken the deepest possible whiffs of dirty Linux underwear. I cannot tell you, and I'm sorry, no other metaphor will do. I mean, that is the only metaphor that captures it. I mean, I know everything that everyone ate for dinner. I mean, it is it's really pretty ugly. So we've had to go into, and on the one hand, I had kind of hoped that that the stereotypes I have of Linux would not hold true. Unfortunately, I came out with the conclusion that they hold much truer than I thought they did. So that's a little bit of a tragedy. And I think we were talking about EPOL last time. Unfortunately, EPOL is just the tip of the iceberg. I mean, it is really kind of far and wide, just semantically a mess, unfortunately. And some of this, the stuff that kills you, I mean, some of the stuff, whatever, you try to be forgiving because we all make API mistakes, right? When you develop an API, it's really easy, especially if you're not using that API yourself. If you're not developing the consumer of that API, it's really easy to have something that's totally unusable. And and they've had plenty of examples of that. Some things that are just like actually so unusable. Actually, the really comic stuff is the stuff that's so unusable that even Linux has abandoned it. I mean, the slums that are so filthy that even Linux won't live there. Those are amazing. So things like denotify. So denotify, which you probably don't know about denotify. You'd be forgiven for not knowing about denotify. Denotify is stands for directory notify. This is the way to get events on a directory and this is KQ has got the vnode you've got vnode based KQ events in BSD. For event ports we've got file based events, so this this kind of makes sense. But the way denotify was implemented was just comically bad in that, among other things, the way you would indicate this was via the functal interface. You're kind of like, okay, what does that smell? So you do this via functal, which is a little bit goofy. The way you would get notification that something has happened to the directory that you're interested in is via SIG.io. And you're just like, okay, get the helmet on, poof! Like, what do you know? Not signals. Seriously? And this is like where someone just like saw the word signal. It's like, oh, I want to signal a process, so I'll use a signal. That must be the right thing. It's like, no, please just stop for a second. Please. Just stop for a second and try to understand what you're doing. And signals are a totally regrettable mistake in so many ways. You definitely don't want to use signals to convey meaningful information. please. But so they did SIG.io, and the SIG action would have some modicum of information, but not nearly enough to actually figure out what the hell happened. So denotify was actually considered to be so bad that they needed a replacement, which again, we actually haven't had to implement denotify, thank God, because no apps use it. And so they replaced denotify with this thing called iNotify. The I standing for inode, still a bit dubious. And iNotify was designed to deal with all of denotify's problems. So one of the problems that they had with denotify was that you could only get notification on an FD that you actually had open, which I think and the problem being that you can't unmount a file system that someone has a denotify on. This is the kind of thing where I think actually from the SmartOS perspective, Lumos perspective, and probably from the FreeBSD perspective, I'm like, I don't know that that's a bug. If somebody is asking for notification on a directory and has the FD, I mean, the fact that they have the FD open, maybe that should prevent an unmount. Yeah. Or, so I think that, you know what I mean? I think it's like you're in kind of there's an interesting semantic discussion to be had there, but no discussion was had. It's like, no, that's bad. We don't want to have that. We don't want to force you to have a file open, an FD open, to be able to get notification on it. So they did iNotify, which is strictly path-based. And it is almost plausible. So with iNotify, you can have events on a directory, for example, and one of the events of the directory is, hey, a file has been created under this directory. And now that said, you have an event queue in the kernel. That event queue is of bounded size. It can overflow. There are lots of things you need to go deal with, things that KQ doesn't quite have, EventPorts doesn't quite have. But so it's a bit dubious, and so you're kind of implementing iNotify, or I was implementing iNotify, and I was saying, what, this is almost kind of useful. This isn't so bad, actually. I'm kind of impressed. I was actually kind of secretly proud of Linux that they had done, yes, they had done the wrong thing in denotify, but they were actually trying to do the better thing, which is good. That's a sign of some development of frontal lobe. That's good. I thought this was good. And we're going to deal with the hard link issue. It's like, okay, deal with the hard link issue. Well, they didn't really deal with the hard link issue much at all, because hard links do create a problem, right? And iNotify, this is really, really weird. iNotify, so you do iNotify of a particular path. One of the challenges is if you do an iNotify of a directory, you will not just get creation events of files in that directory, which modify that directory. You can then get modifications of files that are in that directory. And that's weird, right? Because when you open a file in a directory, that's an action on that directory. I kind of have that directory. I know this file is in the directory you're interested in. But once that file is open, it can be unlinked, right? So what does it mean for a file to be modified in a directory? Files aren't modified in directories. Files are just modified. Open files are modified. They don't need to be in a directory, right? They were in a directory when they were opened. They're not necessarily now. And by the way, they could be in one directory or multiple directories because you can have a hard link to this file. And the super goofy thing that they did, and I don't know, this is one of those things where it's like, does someone actually think this is a good idea, or is this just an accident of the implementation? That if you've got two hard links to a file, and you've expressed interest in the directory /var/temp/foo, and we've created var/temp/foo bar. Okay, and now we've modified var/temp/foo bar. You're getting events. var/temp/foo bar is being notified. Great. I now create a hard link to var/temp/foo bar over in var/temp/baz. So I've got a hard link var/temp/baz bar that is a hard link to var/temp/foo bar. If I modify the file through var/temp/foo bar, you get notification. If I modify it through the other hard link, you don't get notification. It's like, you're inventing semantics that don't exist. You know what I mean? It's like
they need to decide, is iNotify based on paths, in which case it should be called pnotify, or is it based on the inode number, which is the same if they're a hard link?
That's exactly it. That's exactly it. And the thing is, on the one hand, again, this is a bit of an inside baseball thing. It's a bit unfair. iNotify is a huge improvement over denotify for sure. My God, it doesn't use signals for crying out loud. So it's a huge improvement. But no, you're exactly right. And you know what's funny? Because this is actually a huge issue, I think, for our communities, and that's something that I don't think the Linux community really gets. Nomenclature matters. It's really important to us to figure out what names mean, because that name will be used by future generations to understand what it does, to extend what it does, to know what they're doing is appropriate or not. And names really matter. So you're right. I mean, it should be, if it's going to be path notification, it should be p-notify. And by the way, if it's path notification, that forces you to think about problems that they didn't really consider. If it's inode notification, you shouldn't have this crazy-ass goofy behavior. You know what I mean?
It doesn't matter if it's in a directory. It's just an index in the file system. It can be anywhere, and anything can happen to it.
And they do this all the time. It's like, all right, so I'm sorry. We're going off on a rant. Like, strap on. Like, you've done it. Like, we're going to escape to – we're going to achieve exit velocity. We're aiming – next stop, Urt Cloud of Rage, because we're getting out of here. So, okay. So I'm using one of the things about doing this Linux system call table is I'm constantly, like, trying out all this crap in Linux. I'm constantly on the bleeding edge of garbage in Linux. And so – we're using CentOS 7 or whatever, and I'm trying to use Yum. It's like, oh, Yum doesn't exist anymore. Instead, it's DNF. You heard of this?
Nope.
DNF? DNF. Okay.
That's did not finish.
Yes.
That's what happens when you crash and burn in a race.
Yes. Thank you. DNF is did not finish. If you have ever come on, like, haven't you guys ever jogged a block in your life? If you've ever run a 5K, DNF is did not finish. And you had the exact same question I had. It's like, DNF, what does that stand for other than did not finish? Of course, you Google it, and it's like, DNF is did not finish. Like, okay, so what does DNF, please, what does DNF stand for other than did not finish? And you're trying to figure out what it stands for. And finally, you get the email from the creator of DNF, who's like, why do people keep asking me about this? DNF doesn't stand for anything, okay? It's just something that occurred to me. It's just like, oh my God. Do you wonder why people keep asking you this? Because nomenclature matters. They're trying to figure out what the hell you're trying to do with DNF. And they come up with some retro namer about just a fancifier of some terrible retro name, backronym or whatever. Which is, it's like, oh my God. And so they do this over and over again. I mean, and okay, like, if you're playing your systemd drinking game, definitely I'll go ahead and take a drink because I'm going to say systemd. Systemd. What the hell is that? Like, it's the system daemon? That doesn't mean anything. It's like, why not call it thingd? Or, it's like the whole thing is the system. So, like, what do you mean the system daemon? What boundary where does systemd stop? What do you say, oh, this component, it doesn't belong in systemd? Because if it's in the system, by the way, the manifest destiny of systemd is to consume all software. I can understand why people get fidgety around it. You know what I mean? And then it's even worse. I don't know if did you see this? They did this SD event, VenSD, I think. This ePoll. I just saw this over Hacker News over the weekend. So it is an ePoll event library that systemd uses. And it's actually, on the one hand, like, very gratifying because you read all of their complaints about ePoll, and you're like, oh my God, it's not just me. Because all their complaints about ePoll are all the complaints I have about ePoll, and they're complaining about how it's not usable, and you've got to make this layer of software on top of it. It's like, okay, great. So they did this thing that actually looks somewhat reasonable, but it's welded into systemd. And I'm thinking, from my selfish perspective, boy, I would love to use this library that does what ePoll should do as a library, run its test suite against our stuff, and just make sure that there are no edge conditions, right? Make sure that we're always looking to test our software and make sure that it works. So I'm thinking, oh, just take this library and test suite. I'm like, wait a minute, there is no library for this thing. Why? Because it's in libsystemd. It's like, what? It's like, if there is a name worse than systemd, it's libsystemd. I mean, first of all, if you ever have like lib my daemon name, you're doing it wrong. I mean, honestly, stop. You're doing it wrong. That is, you don't understand what a library means. You know what I mean? It's like it shouldn't be lib name of my command. That doesn't make sense. What are you trying to do? And it's like, boy, if they had only made a separate library for this thing, which would be a totally reasonable thing to have done.
If you want somebody to be able to use this somewhere else.
And have you seen Pottering's? I mean, God, I hate to go here, but Pottering's screed on other systems and how people need to just stop using other systems. I mean, it's actually terrifying, I have to say. I mean, it's like, this is why there is so much resistance. The idea, because there is a kind of idea that actually, no, you should not actually be deploying on a different system. My system is the only system. And especially for a system that is so misguided in so many fundamental ways, and if nothing else, has a totally profound desktop bias. Isn't that ridiculous, by the way? That systemd comes out of the desktop side. I mean, it's like, what? I mean, Linux is not a desktop operating system. I mean, I hate to kind of break this news, but like, why is anybody in the Linux community having terms dictated to them by the desktop? It's like, what? Are you people out of your mind? I mean, it's like if I want to not be able to attach to my local Wi-Fi, I'll run Linux on my desktop. Other than that, it's like, sorry, the Mac is Unix on the desktop. I'm sorry. Obviously other people do other things, and I honor other people doing other things on their desktop. But that ultimately, these are server-side operating systems. I mean, certainly the sweet spot for FreeBSD, the sweet spot for SmartOS Illumos, and the sweet spot for Linux are all on the server side. Why are you letting this kind of insane desktop demographic hijack the future of the operating system? I just don't even get it. Where were we? I'm sorry. Where do you even start? I know, this is, I just kind of like, I feel like I kind of like come to in the gutter being like, God, what state am I in? I remember like basically DNF and then blacking out. Anyway.
So actually, yeah. So what we were going to ask you was, one second here, fixing audio. Was, which library do you have, do you want to complain about?
Oh God. Yeah. God, where to start?
But just to circle back to the previous point you had about nomenclature. The one that gets me is KVM, it's kernel virtual machine or whatever. It's like, sorry, all of my servers already have a KVM.
Have a KVM.
For the keyboard and the video and the mouse.
Keyboard, a video, and a mouse. I mean, come on. And like, kernel virtual machine doesn't even make sense. It doesn't even make sense. What is a kernel virtual machine? It's like, why not call it a kernel virtual machine OS CPU? Why not call it a CPU DRAM NIC? It's like, they're like, let's just mash a bunch of things together. It's like, that doesn't make any sense. No, I'm totally with you. And KVM is one of those things where I've just like gotten past my anger, but I know it's important to kind of resurrect that, because it's like, this nomenclature really, really, really matters, and because it reflects the craftsmanship and the intent, and I know, yeah, we take this stuff very seriously, and that's why I think actually it's really important. One of the things I never feel that it's a waste of time or energy to discuss nomenclature up front. And it's not a point of minutia. And I really try to get, let's get the thesaurus open. Let's really try to think about what it is we're trying to convey. And more often than not, when there's a disagreement about nomenclature, there's a third choice that hasn't been considered that everyone is kind of thinking of, but no one has kind of latched onto it yet. And then when that choice is proposed, it's like, yes, that's what I meant. Exactly. And then that nomenclature helps. I mean, it's the cornerstone of software is the nomenclature. And if you lay that cornerstone, upended and throw it into the street, it's like, well, that's why you have a slum, because this is why you can't build skyscrapers, because your cornerstones are in the street.
Yeah, it's kind of, chemistry. There's all these rules, and then you can take anything and describe it, and it makes sense, and everyone will know what you're talking about.
Exactly. It's amazing. You'll find it just amazing. It's very liberating when things actually make sense. And you also have this moment of like, when things don't make sense, everybody has to have the same, like, I am not understanding this correctly. Like, I don't get why. Okay, this is me. And you have that same kind of like self-doubting, like, I don't understand this. And this is the problem of it, things not making sense. It's like you are imposing a burden on people that actually do understand things, because they begin to doubt themselves. We used to have the Solaris installer used to ask this terrible question. You go to install the operating system, and it would ask you this question: are you on a subnet? Yes or no? And I thought I knew what a subnet is, but I must not, because why is it asking me if I'm on one? It's like, I know I'm on the internet backbone. No, yeah, I'm like, yes,
is it
think
possible
I'm on a subnet,
to not be on a subnet? What does it mean to not be on a subnet?
I don't even know how.
Do you have an IPX network? Is that what that means?
And I'm sure there are an entire generation of technologists that, like, they didn't waste their lives over it, but I'm sure everyone wasted, like, it's a good, like, 10 minutes of, and this is before Wikipedia. You can't just, like, Google it. You got to be like, okay, I need to go get someone else. I need to go seek help because this thing is actually, I don't understand what's going on. And then you realize it's like, no, this thing's just stupid, actually. It's a dumb question. It shouldn't be asking you this. And then the rage comes. I think we finally got rid of that question, but it's such a moronic. Anyway, so when you do these things and you just throw out these things that have no meaning or have the wrong meaning, you end up creating this huge amount of confusion from actually well-intentioned, bright people who would understand the system and would actually help you, but instead they're enraged because you've named your thing the wrong thing. I mean, let alone how it's implemented.
Mm-hmm. Right. So as we get started this week, half hour in at this point.
Sorry, yeah, right, exactly. Are we ready to get started? Are we on yet?
You wanted to talk about Linux interfaces. So which specific ones are really high on your annoyed with list, I guess?
So I think, the ones where to me it rises above manslaughter and actually becomes murder one are where you actually have people years ago saying this is the wrong thing to do. And you don't actually, and the one that just kills me is mab don't need. So recall there's an madvise system call, and madvise allows you to give advice to the system about how memory will be used. And there's a mab don't need that you can say, and if you look at what does POSIX say, I should bring up what POSIX says on mab don't need. But POSIX will tell you that I don't think I'm going to be using this in the near future. Like I'm not going to be I'm not going to use this. And what FreeBSD does, I think you guys have mab don't need, don't you? Do you know if you with that?
I think we do, yes.
Yeah. So what FreeBSD does, I would assume, I'm almost certain, and was certainly what we did, what basically every operating system did, is when you say map don't need, it's like, okay, so if I actually need to make available some physical memory, if I need to page anything out, this is first on the list. I'm going to page this out. Now, note, I'm just going to page it out. I'm not destroying its mapping. I'm just paging it out. It's going out to the swap device. And if you need it back, you might incur a page fault, but then, your data will still be there. Well, Linux got this one totally confused with another construct called mab free, and FreeBSD has got mab free. We've got mab free. I don't know what I think the origins are in kind of the mid 90s, maybe even earlier. Mab free says, I am actually done with this. I'm not going to use this anymore. But what I want you to do is, if you need memory for someone else, give them this page, but don't page it out. It doesn't need to go to the backing store because it's just trash as far as I'm concerned. So I know if I touch this again, there'll be one of two things. It will either have what it's got on it now, whatever crap I don't want, or it will be zero filled because someone wanted that memory in the meantime. Okay? And makes total sense. So that's mab free, and that's mab don't need. Well, they totally screwed this up. And what mab don't need does is it says, actually, I'm going to rip down this mapping, and the page is now gone. And if you touch the page again, you will get zeros, guaranteed, on mab don't need. Which is like, what are you doing? Wait, no, this is advice. Like this is, and again, it's a nomenclature thing. It's like mab free, like that's a verb, right? Mab free it says that's a verb that says I expect that I'm kind of I'm pushing the bounds of advice, and I'm saying that you can free this if you want to, but it's advice, you don't have to do it. Mab don't need is literally saying I want you to purge this now, and if I touch it again, it's guaranteed zeros. Which is terrible. I mean, it's terrible. Like, why would anyone want this construct? And it's a dangerous construct to have. It's a dangerous construct to have because then you can become dependent on it. And people look at this like, oh, madvise, mab don't need. Like, that must be fast. Like, if I want a free memory, I bet that's a fast way of doing it. Of course, they don't bother to measure it because it's not fast at all because you're having a conversation with the VM system about actually purging this from the system versus mab free, which actually is fast. I bet this is fast. I'll use this to free something, and then I will implicitly rely on the fact that the B0 has been done for me if I touch it again. And unfortunately, Gemalloc, which I think of Gemalloc, I think of the girl band from the 80s, the cartoon girl band from the 80s, but this is what I'm totally dated. But Gemalloc, which is this memory allocator that crash landed courtesy of Facebook. Gemalloc relies on this functionality. It relies on the fact that mav don't need is actually going to zero the memory. And as you can imagine, the consequences of not B0ing, of implicitly taking away a B0 on a reallocation, turns out like the manifestations of that are pretty subtle. And so we had applications that were just dying in really peculiar ways because, of course, you're dying way up stack in an application that was actually relying on the fact that this was B0'd, and now it's no longer B0'd because the system hasn't B0'd it because we were implementing mav don't need the way you should implement mav don't need, which is to say purely as advice. And by the way, we never actually got rid of this page and you got your old page back. So it got back junk, and then that junk was dereferenced, and then you're dying in like way up stack in really weird ways, and then you have no frame pointers because they don't say frame pointers because that's too slow, and then you're trying not to be like, okay, I actually need to go take my medication before I actually start punching my laptop because I can't even get a stack trace where we are. It's really bad. And so we finally figured that out. The reason this one felt so grievous is because you go back to these conversations. Like, on this one, you're like, seriously, who's to blame for this? This is really, really bad. This semantics are totally different from every other Unix. This feels so willful. Like, who did this? Who pulled the trigger on this? And you can find conversations from as early as the late 90s of people saying, oh, by the way, Linux did this wrong. Like, someone needs to fix this. Someone needs to fix this. Someone needs to fix this. Oh, this is broken. Like, and you get all sorts of people saying, I loved at one time, this is like in 2003, someone called it a crime against common sense. It's like, it totally is a crime against someone gets it. I'm glad someone else is contemplating pressing charges. So it turns out, any guess what Unix this came from?
No.
Where did this come from? Okay, so let's just go. We're going to play Guess That Broken Unix. So let's go rattle off some broken Unices. Obviously this did not come from BSD. Obviously it did not come from Solaris, Illumos, SmartOS. Any guesses?
AIX.
Ooh, good. Great guess. Great guess, because if I say broken Unix in the Unix word association game, you say AIX, which would be, if we were on Unix $100,000 pyramid, we would just win. I'm totally with you. AIX has got all sorts of broken semantics. You know AIX maps null? Did you know this? AIX maps null. It's like, well, that's a terrible idea. So you actually have a page at null, and it's got 0 for the first 512 bytes, and then it's got a bunch of other like fruity stuff above that. Like, oh, there's your PID and a bunch of other random stuff. It's like, well, that's actually a terrible idea. So yeah, AIX, totally weird. As one person told me, it's as if Unix were re-implemented by an alien race, a well-meaning, benevolent alien race re-implemented Unix. It's like, why are these comments in these strange runes that I can't read? It's like, oh yes, well, yeah, we were searching the universe for tungsten when we wrote that. It's like, okay, so no, AIX is a great guess, but not AIX. Any other guesses?
I don't know that many old Unixes.
Then we got to do Antiques Roadshow. Okay, let me tell you, it's not. It is not. It's not DGUX from Data General. It's not IREX. IREX is actually always pretty well thought out. It's not Dynix PTX. It's not. Let's see, who else is it not? It's not Venix. It's not QNX, which is not really a Unix, but it's got kind of Unix in the name. No, it's not any of these things. It actually comes from Digital Unix and then True64. It's like, oh my god, of course. So some well-meaning knucklehead at Digital basically added it, or someone was either copying the True64 semantics or the Digital Unix semantics, or I don't know. So someone did the wrong thing a long time ago. But the thing that's so frustrating about this particular example is so many people over the years saying this is broken and this is untenable and we need to fix it. And there's just a total, not just a reluctance, but a refusal to actually understand why this is such an issue, why this is so pernicious, why it makes it so difficult to develop cross-platform software, and why it now, especially as this achieves ubiquity, and now libgemalloc, years and years and years and years later, develops this unwitting dependency on this behavior. They don't even realize that they are depending on totally Linux-specific brokenness. There's nothing in the man page that's like, hey, by the way, we were total idiots on this one, and you really shouldn't rely on this. I mean, at least if there were that, you'd be like, there'd be a modicum of self-awareness. But there's nothing. So these things end up with encoding these semantics that are fundamentally busted implicitly, and it's left to us to go pick up the trash, the garbage. And it's heartbreaking when you see these apps, and we've seen them, where it's like you look at, they're calling mav don't need on these very big segments of memory, and we, the operating system, are having to do a bunch of work to actually go purge that memory, rip down those. I mean, as you know, ripping down mappings is expensive in the operating system, right? People have this idea that like mmap is fast. It's like, why? Because it's 4 characters? It's like, yeah, it's 4 characters. It must be. And mmap just, it feels fast. You know, it's like pinstripes on a sedan or something. People think like mmap is fast. Like, no, it's not. Mmap feels fast because it's the operating system kernel, the VM system, that's having to do all this work. And when you actually ripping down a mapping takes a lot of work. You know, ripping down a mapping, unlike map free, which is very quick, when mav don't need, I've got to go around and I've got to actually go shoot down TLBs. I've got to go do a bunch of, I got to modify PTEs. There's a bunch of stuff that has to be done. And it's a very bad idea. So it's all just very painful, unfortunately. And that one's just like, well, there's nothing to be done. It's like, well, congratulations, knuckleheads. But like, this is what we're going to live in. So. It's like we got to live in this particular body of filth for the rest of our lives. And so this is the kind of thing where it's like, this is why these semantics matter, because when you make these decisions, if you, to the degree that you achieve ubiquity, these things survive in perpetuity. And the best thing we can hope is to have mab-free implemented by Linux, which it still hasn't. Mab-free been implemented by every other system except for Linux. Hope that mab-free is implemented by Linux. Hope that Jem Malik wakes up and realizes, actually takes a stopwatch to what they've done and realizes that they made things slower, not faster by using it. And then, you know, maybe we can slowly reduce our dependency on it, but we're never getting away from it. And now we've got to live with this forever. So, you know, slow clap for that one. And it just feels like you knew this was the wrong thing to do. You had people telling you that it was the wrong thing to do. You didn't listen. You, the collective body, didn't listen. And it's, on the one hand, it's like, you know, you're angry about it. On the other hand, it's not like it's even any one individual. It's an ethos, right? It's a way of thinking that's at fault here. And it's the whole idea of the fact that nobody is taking responsibility for actually setting architectural direction here. They are just, you know, taking responsibility for making sure that things don't break over what was there prior. And that ethos shapes everything about the system. And, you know, my kind of big conclusion about the kind of the difference in thinking is Linux is not designed. This is the problem. It evolves. And anything that resembles design, worse, anything that resembles design wakes up all these antibodies, right? What was the first reaction to ZFS by Linux? Rampant layer violation. It's like, wow. Because, it's a lot of code. It's like, yes, it's a lot of code. It does a lot of work. You know, it's like, actually, why don't you go look at the code, see what has been done, and use your brain to figure out if this is just loquacious, logorrheic code, or if this is actually a hard problem that's been solved in a concise way, which I believe and you believe that ZFS is. And, you know, you look, I mean, this is the reason, you know, why is DTrace still not Linux? Because they want to evolve their way there. They don't want to take that revolutionary step. They want to evolve their way into all these things. And some things you just can't evolve. Some things this is not a biological system at the end of the day. It's a software system. And some of these things you actually need to go have someone rethink it, come up with the right thing, and then be allowed to integrate a large body of work. But this explains why containers are not just a mess on Linux, but there is no container construct, right? Containers have to be in air quotes. It's a namespace. It's a C group. And namespaces were a way that Linux felt they could evolve their way into containers. But you can't evolve your way to security. You can't. No. You know, you and I know this.
It's like,
right?
It has to be what you start with and then build the other things around it. But
you have to design it. You cannot as methodically approach security. It doesn't work that way. You know, and yes, you got away with it with the simple stuff around, the POSIX IO interfaces or what have you. But when it becomes when the going becomes much more difficult, when the path becomes rockier, and you're talking about containers, or talking about ZFS, or you're talking about DTrace, or you're talking about KQ, you're talking about things that are more involved, you actually can't just evolve your way there. You actually need to design your way there, and there's just no capacity. And in part because anybody who has that ethos, I mean, if you have that ethos, why would you sit around fighting in the slums of Linux? Come to FreeBSD, come to Illumos, come to SmartOS. As like, we're happy to have you. And by the way, your good ideas will cross-pollinate to other systems that share your values. So like, stop fighting, and that's what people do, right? And that's what I don't want to speak for you, but I assume that's one of the things that draws you still to the BSDs. Exactly. One of the things that draws me to the BSDs and to Illumos, so on. So
exactly, the fact that things actually get done, and you can allocate memory, and it doesn't do stupid things.
Right. You don't have an killer. And people are like, where's the killer? It's like, what are you even talking about? It's like, where is killer? I mean, the killer is so deeply unconscionable, And it's like, I'm not even sure if you meant to set off the another prairie fire of rage with this, but the idea that we actually just rely on the fact that if we begin to run shy of resources, that an assassin is just going to start wiping people out until things are better. It's like, well, that's a terrible idea. That's the worst of all worlds. I mean, and no, it pretty much is. It's awful. It's like, okay, what? Okay, why do you live this way? Why do you do this to us? It's like those of us who know a better way. It's very painful for us to hear this.
Yeah. On BSD, we have something kind of like that. When you eventually run out of swap 2, it will find an offending process and kill it. But there's a system to mark, say Varnish or something, the big application that's using a lot of memory that looks like the most juicy target for your OMM killer, but is the whole point of the server. Leave that one alone.
Yes. And I think, and that's the issue. Because if you've got a resource oversubscription problem, especially with DRAM, you've got a fundamental problem, right? If you're out of swap, you can't page things out. Yes, someone has to get out of the boat. The thing is that, like with FreeBSD, we do the same thing where it's like and actually back in the day, we used to, the first thing to die, because we used to kill things based on who's consuming a lot of memory. It's like, well, that's a bad idea, because as you say with your Varnish example, you're killing the point of this machine. One of the things that was a particularly common victim was the auto mounter. You're like, oh God, do not kill the auto mounter. Like, you kill the auto mounter, and it's like, hey, now you have you used to have one problem, now you have n problems. And by the way, now you have a bunch of things that are trying to do things and can't, and are now like allocating memory to indicate phonetically that they can't do things. It's like, you made this problem much worse. So what we did, and it sounds like you guys have done similar things, is like, you need to have some way of conveying to the system, no, like, this is more important than that. You need to have some way for the system to try to infer this is more important than that. And there are various ways to do it, and we use various tools, and you use various tools. But the point is, it's not an killer. It is attempting to turn what it is an attempt to make an accident survivable. It's an attempt to turn a crash into a crash landing, really, and try to allow the system to right itself to some degree. And if it's a Varnish server, get back to Varnish. It's a hard problem for sure, but just and this is why, in the easy problems, when they're punting on the easy problems, that the hard problems are going to be grim. And that's, it's so you're not necessarily surprised when it's grim. What really kills me is then things that actually kind of depend on those implicit semantics. That becomes a real problem. Like, oh, don't worry, we'll just be killed. Like, I just use as much as you want. Like, it'll just start killing people. It's like, no. Oh, God, please don't. Anyway.
All right, so switch to a slightly lighter topic maybe for a minute. Twitter, I put out a call on Twitter for extra questions. We got some interesting ones. So Twitter asks, what's your favorite version control system?
Ooh, actually, I was actually a huge fan back in the day of Teamware. So the history at Sun developed something called the Network Software Environment, NSE. And Larry McVoy, who was at Sun at the time, loved the model of NSE. The implementation was terrible. He developed something called NSE Lite, because NSE was really the first bring over modify merge source code control system, pioneered that model. And that model just makes total sense to me. That's kind of I went straight from kind of the RCS dark ages to Teamware at Sun in the mid 90s. And wow, why would anyone do anything different? This is great because I can modify a bunch of files without you having to be aware of it. And I've got my own workspace. I'm not checking out files. I am creating a body of work that's self-consistent and then integrating that back into the system. So Teamware was way ahead of its time. It needed a bunch of improvements, but it was way ahead of its time. Larry left. He did something called BitKeeper, BK, and was still alive and kicking. BitKeeper was, I think, great. It actually made good on a lot of the deficiencies of Teamware. Then, of course, there was this kind of famous meltdown between Andrew Tridgell, who was trying to reverse engineer the BitKeeper protocol, and Larry didn't like that very much, and so he revoked the Torvalds license for BitKeeper for BK. Because the irony is that not that long ago, Torvalds didn't believe in source code control as a point of principle. Like, I don't believe in it. It's like, you can't not believe in it. That's not something you can
believe in gravity.
Believe in infinite mortality. Like, that's something I believe in. It's like, no, that's not a belief system. Like, that's antisocial. That's something you should express only with shame or I mean, we can give you actual drugs that will medicate away that condition. It's like a psychosis. But so he didn't believe in source code control. With BitKeeper, he kind of finally seen the light. It's like, oh, source code control. This is amazing. It's like, hey, welcome to source code control. That's amazing. All right, great. And then, of course, when the license got revoked, wanted to go write his own thing, which, of course, became Git. And, of course, Git is what we're left with, right? And Git is fine in that it is the bring over modifier. The model is right. It is, and everything uses it. And enough is right about Git that we look past all of the unbelievable rage over Git. And it is, I mean, talk about not designed. I mean, and verbs that are totally confused. I mean, it's just Git is so profoundly, deeply confused about so many of its fundamental primitives in the way it names things. So the interface is truly terrible. I mean, unbelievably bad.
We talked about names, nomenclature, and so on, and it's like, well, let's take checkout, the word that's meant the same thing in every version control system ever, and make it completely something different.
We'll make it something different. I think no one will be confused. And so, I mean, that's obviously, that's a major problem with Git. Unfortunately, as with Linux itself, it's good enough, unfortunately. So I, like everybody else, I've got the stuff that I cut and paste and I run with Git. I'm afraid to do anything when I go to Google something, because the man pages are useless basically, and you go to Google something to do something and you see that the top hit you've already visited, it's been highlighted, oh, and you almost want Chrome to be like, are you serious that you've not retained this? Like, do you know that you've been to this page 18 different times? And by the way, here's the timeline. But I don't retain it. I can't retain it because it doesn't make sense.
Exactly.
The verbs don't make sense. And none of this stuff actually makes so. And obviously I'm not alone in that. But apparently that's just porcelain. It's like interface is now porcelain. Like I'm a prima donna because I want things to make sense. But so I Git is the one I use, the one we use, but not necessarily. It's got the right model. It does enough that's right, basically.
Although, at Lisa, James Mickens described Git as Git is Donnie Darko as a service, a confusing movie about time travel and parallel dimensions, and then you put your source code in it.
That was so funny. So we actually just watched that last night as an engineering team. I was weeping with laughter. James Mickens is so funny. And no, I think it's one of the very few technical videos I've actually brought home, and I actually watched that with my wife last night. I love that video, his Lisa 2015 video. There's actually a bunch of good. I mean, that one is almost pure stand-up comedy, which is great. It's very, very funny. He's got his technical talks are actually great because they've got a bunch of technical meat on the bone and are still actually just as funny. He gave a talk. There's a talk at Harvard where Margot Seltzer's introducing him that I saw. That I've been going through his whole. I'm now binge watching James Mickens because I've read his stuff in Login, but I've never actually seen him present. And man, that guy is hysterical. He's very, very
funny. The first video I saw him in was, but I read one of the Login articles about computer security, and it was like, when you're being massaged upon, there's nothing you can do.
No, it is, and it's nice to. And the thing is, it gets to the fact that there is the sense of community that we have in Rage. It's this very kind of peculiar thing where the reality is, and we've accepted this as an engineering team at Joyent. We actually like it when people are wrong on the internet. We can deny it. Everyone can deny it. But the truth is, if everybody were right on the internet starting tomorrow, people would feel an emptiness that they wouldn't be able to place a finger on. It's for whatever reason, we find solidarity in being upset about things. I mean, I'm sure that there's something very deeply wrong with us, but there's something that I know, and I want like a rage network. Like I want to, other people that hated systemd also hated EPOL. It's like, oh wow, oh great, I probably hate this. I would, you know what I mean? It's like you want a way to like connect via the things that you don't like, which on the one hand, it doesn't feel negative, though. It feels positive. I don't know why. What's wrong with us?
Well, speaking of that, you kind of maybe accidentally coined a term earlier in the show, and I've went and bought cloudofrage.com.
Very good. Yeah, that's it. No,
Live during the show while you weren't paying attention.
There you go. That's good. There's something about it. There's a fraternity in Rage that I don't understand completely, but I definitely feel it. I feel that bond. And in fact, I don't want to tip my hand too much, but Ines Simbra, I don't know if you know Ines, she's great technologist, feels exactly the same way. She and I are going to be organizing a conference to allow everyone to get our Rage out. Ooh. So look for that coming up. Could be good. It will be great, I think.
I'll sign up for that.
Yeah, there you go. I know. I feel the same way. It's gonna be great. We got to kind of figure out. And amazing. A lot of people are interested in it. So we're gonna. It's gonna be a lot of fun. So look for that. TBD coming early 2016. We're just hammering out a date and we'll be announcing that soon.
Make it the same time as FOSDEM so I can come.
Oh, when's FOSDEM?
Like January 30th and 31st or something like that.
Perfect. Yeah, it's gonna be February. Yep, no problem. We actually wanted to do it on Valentine's Day, but Valentine's Day is a Sunday. We want to do love letters to technologies we hate.
There you go.
We do, it's not even hate. Hate's not the right emotion. It's rage. It's not. It's more because there are plenty of things, by the way, that I totally respect about Linux. I mean, I am not a Linux hater. Actually, I am very frustrated with it. But we all have Linux to thank for the fact that we're not running Windows everywhere, right? That Unix won in part because of Linux. So it's a more complicated emotion. It's a kind of a rage, but it's a rage that is coming out of a sense of frustration that things could be better, not that you want to actually annihilate something else.
Yeah. So I was going to ask the next Twitter question, but the FreeBSD developer chat room just noticed I was interviewing you and it started throwing questions at me live. So they're
great. Let's do it.
So journald, this is a thing. In order to log a message with journald, you open a file, you write the message in, and then send a file descriptor? What?
I mean, and this is where literally I actually forget about this because I mean, the things that most rage on systemd are the things in the operating system that we need to support to allow systemd to work. So I actually forget the things that actually induce the most rage out of systemd. But journald and journal cuddle, I mean, this is actually an affront again. I mean, because where does that idea come from? Like, walk me through how you could possibly feel that that's a good idea, assuming that you're not a totalitarian that feels that you need to control all information on the system. And this is where you get to the systemd problem. It's the system. If you're going to log something, it should be logged through me in a proprietary binary format. It's like, what are you talking about? And so I can't use it. And by the way, when that thing gets corrupted, you're done. Right? When that binary gets corrupted, it is so ill-informed. I mean, I almost feel like I almost want to punish whoever comes up with that idea. It's like, okay, we are now going to wave a wand, and you now have to run a system in production that only uses the junk that you just came up with. We are actually going to send you into a dystopian future where this technology has actually triumphed, and you alone must deal with the ramifications. I mean, I always want to be like, it's the ghost of technology future, taking you into the future, being like, it's like, but oh my God, there's so much disease and pestilence. It's like, yes, that's because your idea has triumphed. I mean, you want to kind of get this across to people. This is a terrible idea. It's like, the unikernel thing that has come up recently. People are romanticizing unikernels, and I think you got to deal with anybody who's talking about unikernels like a teenager that's been caught smoking. It's like, you now need to run nothing but unikernels in production. I'm going to make you smoke the whole pack of unikernels, and you're going to learn when you come out of there that it's a terrible, 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 terrible idea, and that the only reason you're conceiving of this is because you don't yet have an adult mind. I mean, we know that the mind is developing well into the late 20s. So, you may think that you're in your mid-20s, but you're actually a teenager in terms of the actual frontal lobe. So you think this is a good idea, but it's actually a terrible idea. Those are your hormones speaking, and you must actually smoke the whole pack of unikernels to learn why. Not that I've got an opinion on unikernels.
So we were going to get to your response to the Sam Kotler series of tweets, but then he started tweeting new things at us.
Oh man, I know. Oof, I know. I thought he was kind of like taunting the bull, prodding the bull. I'm like, this is not a good idea. And I feel like, as if I'm gonna kind of rage as a segment, I need to treat myself like an athlete. I need to like taper properly before the actual event. I can't actually get like pre-enraged. I saw the earlier part of those tweets. I don't even want to know where he went. I mean, he was on a rip through many broken subsystems.
Yeah, that's just, like, why is Linux's crash management facility so bad?
He's like, no. And this makes me mad. I mean, because for me personally, and this does come to a really strong point of principle, post-mortem debugging has been so essential to me and to us and to develop reliable software at userland, reliable software in the kernel. When the software fails, we need to get a snapshot of its state to understand why it failed. And this is the cockpit voice recorder. This is the flight data recorder. And the reason that aviation safety has been able to be on a ratchet of just aviation has gotten safer and safer and safer and safer and safer. The reason is because of the cockpit voice recorder and the flight data recorder. And you look even now, with Air France, with the accident in the Southern Atlantic, AF 447, where until they got the action, I mean, it took them years, and amazingly, they actually found the flight data recorder. Until they got the flight data recorder, they didn't actually know why that plane had crashed. The speculating is because the pitot tubes. Turns out it's because there was pilot error. Pitot tubes were involved. It was pilot error. They stalled the aircraft out. We would not have known that if we had not actually had the data. So even now, we need that data. It's like, how, when you don't get a snapshot of a failed system, how can you possibly hope to diagnose this? I mean, it's like having a city that is overrun by serial killers and announcing, first thing we're going to do is close the morgue. It's like, wait a minute, what? Like, we need to actually solve these crimes. Like, no, there'll be no more crimes solved. And it's certainly, I guess it's a way of being kind of willfully ignorant, but it is really, really, really bad. And it's one of those things that, again, if you can't get kind of the obvious stuff, if you can't understand why SIG.io is a bad idea, you're probably not going to understand why you need post-mortem debugging. And you can find a screed, and this is like, I actually do need to be medicated when I read this. There's a screed from Torvalds from like 2001 where he talks about the fact that he doesn't want the system to be debuggable because making the system debuggable makes developers soft. You're just like, are you kidding? I mean, that's actually an irresponsible attitude. That's actually beyond just something I disagree with. That's actually socially irresponsible. Yeah. I do believe that we actually as technologists have a responsibility to, if nothing else, our best effort to generate a reliable system. And yes, economics will sometimes dictate things. And, yes, we're not able to focus as much on reliability sometimes as we want, but we're trying to. And the idea that we weren't even going to try to make it reliable because adding the mechanism for increasing the reliability will somehow make developers soft. What does that even mean? It doesn't make sense. It's such a medieval, it's such a medieval kind of idea. Anyway, oh man.
Okay, so now for a question that shouldn't lead to a rant.
Oh, wow. I can't wait.
Do you have any hobbies outside of open source?
I've got 3 kids. You wanted to not lead to a rant, and yet here we are. No, and actually, my kids are getting old enough now that they don't only drive me nuts, and they're actually getting old enough. I have to say that one of the greatest satisfactions in life is to be able to share your hobbies with your kids. And so I play Ultimate, and now my kids are old enough to play Ultimate. I ski. My kids are old. I ski with my kids, or I used to before we had a drought. But looks like we're gonna get some rain this year, so get some snow this year, so we'll be skiing again. So it's great to do that. That kind of stuff with your kids is actually, and when you've had kind of a week of rage. The ability to go, or my son's a Boy Scout now, going hiking with the Scouts. It's very therapeutic, very cleansing. So those are the 10 things I tend to like. But when you got 3 kids, if you've got kids, you end up being pretty occupied. I've got kind of 2 full-time jobs, but that one fortunately is becoming less frustrating as the kids get older.
Cool. And was there anything else you wanted to add before we wrap up?
Boy, no, I think we've got it. Or at least for this episode of Rage with Brian. I feel like I'm becoming like the Andy Rooney of BSD Now. Like, please, someone let me know because I don't want to be like the old guy, kind of get off my lawn. I don't want to be. I just want someone like let me know if I sound. I don't want to sound crotchety. I want to sound. If you're young and listening to this, if you're in your teens or early 20s, let me know if I sound out of touch. And because I want to be uplifting. I don't really want to sound cranky. I'm not a cranky person. And I actually hope that people take away from this that the aspiration to do better, not that they should be upset about the state of the world, because we actually can do better. We know how to do better. And when we look at these things that were done improperly, the things that make us upset, we can use that to help guide better work in the future. So I think it can be inspiring in that way. Trying to end on a vaguely positive note so people don't think I'm just kind of filled with rage, because I'm not. I'm not. I'm like I don't actually bottle any of it up. The rage just kind of pours right out of me. I'm like an open valve. So, none of it is. It's not corrosive at all. But it is important to me that people use this as inspiration to do better, not as a way of thinking that the world is terrible.
Okay, hope interview number 2 is just as good as number 1 for you. Definitely a lot of fun, and Cantrill's been a hoot to have on the show. We did this 3 times, so we got another one coming. You just got to sit tight here. So consider this your intermission.
You're probably going to need it at this point.
Yeah, you're going to need it, right? So before we start number 3, of course, our last sponsor for the week is going to be Tarsnap, and the website for that, tarsnap.com/BSDNow. And I know, there's lots of different backup providers. Heck, you see them advertised on cable TV and stuff, right? You should use this software to back up your clients. But how many of them really let you look at the source code? And how many of them make cool claims like, oh, we encrypt everything on your system before it leaves and goes out over the wire?
Well, I'm sure
you control the
lots
key.
of them make
Nobody
a
else.
claim like that, but they don't back it up with the source code so you can prove it.
That's right. As I say, Tarsnap's the only one that says, okay, prove it. Like, so here's the source code. Oh, and you don't even want to trust the binaries that we provide? Fine, we put them up there for convenience, but maybe you want to compile it yourself because you're just a little extra special paranoid. Well, Tarsnap makes that possible as well. You have the source. You can compile it on your own, so you can only run the binaries that you yourself have created. Which, again, how many backup providers go to that level of, just that level of detail?
I don't know many other people that are as paranoid as Colin is.
Yeah, so if they're that paranoid about what they do with Tarsnap, then you can rest assured that all your data is in good hands there. Yeah. So definitely get in touch with the folks over at Tarsnap today. Clients for just about everything under the sun. I think last week, 2 weeks ago, we had an article about how you could even run it on Windows now using like their Linux emulation without having to use Cygwin. That's kind of cool. So definitely check it out.
Other thing is, they actually mentioned in the FAQ here, you don't have to worry about deciding when to do a full backup versus incremental backup, like with traditional backup software. Because of the deduplication feature that's built into Tarsnap, every backup is both a full and an incremental at the same time. So each archive actually has all of your data, but what you actually upload to Tarsnap is only the stuff that's actually changed since last time. And the Tarsnap on a server side will reconstruct the archive that has all your files in it. So when you want to restore, you just have to download that one archive, and it's got all your files in it. But you didn't have to upload all your data every time. So you don't have to do a full backup ever except for the first time. But every time you go to restore, you have a full backup available with your latest data.
Yeah, that's really, really cool. So definitely check it out today, folks. If you ever talk to anyone over there, not that you'll probably need to, it just kind of works. But if you do, tell them you heard about it here on BSD Now. We would appreciate that. And, definitely say hi to Colin for us if you see him at a trade show or whatever, because they write some really cool stuff. And I know Alan and I both use it for our backups here. So you should be too. Okay, so Cantrill number 3 is coming straight at you right now. I promise this will be the last one. So take a deep breath. We're about to begin and enjoy. Okay, well, we're joined now by, of course, Brian Cantrill. Has been here a couple times, and we welcome you back, of course. So for those who don't know, he's the CTO of Joyent. So gosh, I think everybody knows you at this point. So let's just get right to it. First of all, thanks for being here again today. We appreciate it.
Thanks for having me. Great to be here as always.
Mm-hmm.
Okay, so Alan, you lead us off. What do you want to start with today?
Well, I guess, we took a little poll of FreeBSD developers earlier when I mentioned that you were going to be on the show and asked them what they wanted to hear you talk about. And
right.
A bunch of them picked this tweet you sent recently where it said, decades later, Linux is still broken in the same ways.
Yeah.
Explain.
Yeah, everything that was still wrong with Linux is still everything that's wrong with Linux. Yeah, so that was in reaction to a particular piece. Linux is having an issue, as operating systems do from time to time, with what's called on bug or bug on, right? It's bug on.
Mm-hmm.
And bug on is the Linux variant of what we have is Verify and Illumos. And I don't know what you have in BSD, but it is effectively a living assert. So an assert that's not compiled out. An assertion is asserting an invariant. And assertions are one of those things that, one discovers post-pubescence, one discovers assertions as a software engineer is a very healthy thing. Mm-hmm. And we have assertions in the operating system. Historically, assertions were compiled out. We added a variant, and I'm sure BSD's got the same kind of thing.
We actually called them invariants.
There you go, invariants, perfect, right. Mm-hmm. So it's an invariant, we call it a verify, same kind of thing, where it's like, this should never be false. And if this is false, we need to crash the system. We actually need to reset the system because our state is entirely unknown. Because what we thought to be true is false. The invariants have become violated. And so Linux has a variant of this too, but they're so sick of the operating system crashing as a result of these. You're like, okay, if the operating system is crashing, you fix the bugs.
The bugs,
like, no, we don't fix the bugs. No, instead, we're going to omit a stack trace and simply drive on. So it's like... I'm trying, in my older age, I'm trying to be less prejudicial, but you're making it so difficult.
Wasn't there a Simpsons episode where the the idiot lights come on or whatever, and he's like putting duct tape over him? That one's fixed.
Yeah, right. Fix that one. And it's so deeply, deeply, deeply wrong. It's so deeply wrong because it's an invariant of the system. And if this is wrong, you've got no idea what else is wrong. And you are actually, you should view this as a precious opportunity. You have the opportunity to programmatically say an invariant has been violated, and I'm going to bring us down while we're in this discrete state. By the way, we'll take a crash dump of this. We will take an image of system memory, and we will be able to debug why the invariant was violated. And oftentimes, and actually the easiest bugs to find are when the violation of the invariant is close to the subsystem at hand. Mm-hmm. Oftentimes that's not the case, right? Oftentimes the invariant has been violated because something has gone wrong much further afield in the system. And actually the invariant is acting as a bit of a canary in the coal mine. Sure. But if you don't bring down the system, there's not a question about whether the system is healthy. The system is not healthy, and even to say that to use that metaphor is the wrong metaphor because this isn't a biological system; it's a mathematical one. It's not that the system is unhealthy; the system is wrong. It is actually wrong, and anything it does now is potentially wrong and potentially devastating. I mean, God forbid,
right to the file system.
You write to the file system. Right. God forbid you do something where the data corruption, because that's what it is, in memory actually is able to escape out to persistent storage, and now you've actually lost someone's data. And now you've created a much, much, much more egregious problem, a much worse problem, and it's egregious and negligent because you didn't actually stop the system when you knew it was wrong. You tried to cover it up, basically. You tried to, there was a fire in the utility room, and you're like, well, let's say if I close the door and put a wet towel at the base of it, we should be fine. It's like, no, that building's going to burn down. I mean, if you see something, say something, right?
Right.
And you have an opportunity here, and this is a mistake that people continue to make. They continue to make at all levels of the stack, I find, where they find that an error is something that they just want to go away. And so they just try to eat it. And, for certain kinds of errors that might make sense under certain kinds of situations, but not when those errors are programmatic errors, not when you know that the program itself is wrong. When the program is wrong, it's incumbent upon the program to kill itself, to commit seppuku, to ritually kill itself and present its body for the medical examiner to be able to figure out what was actually wrong. So, P.S., you can fix the problem, and you can actually. I mean, if you have a rampant problem where you're dying on all these invariants being violated, well, that's an all hands on deck situation to fix the actual problem, debug the system. Don't try to cover it up. And it's just so nauseating.
But that ruins our uptime statistics.
Well, what's funny about that is it actually reminds me of an old quote about Windows admins versus Unix admins, right? On Windows, if something goes wrong, you just reboot and lose any chance of figuring out what happened or being able to examine the state of the system, right? On Unix, something goes wrong, you look at it and try to figure it out and stop it from ever happening again. You don't just reboot and hope it doesn't come back for a month.
No, please debug it. And you see this again and again. We see this with many different kinds of systems, and we see the problems that we have found that are the most pernicious in production are in systems that have had an error, a programmatic error that they have attempted to eat, but that programmatic error has had widespread symptoms, and they end up in a failure mode that's much more difficult to debug. And because the reality is that a system that's failing fatally is a relatively easier problem to debug in that you have a starting point. Like, the invariant has been violated. You have the next question to ask. Why? What has violated the invariant? You've got a route to take when you're debugging a system. If the system has not failed, but just sucks, and you have no starting point. It's like when the system is just not behaving properly, and yet that can often be, and we've had this happen many times in the past, where the system sucks because there was an error that should have resulted in the system being reset that hasn't, and now you've got, for example, a connection that's actually a dead connection, and we are continuing to send data over a dead connection, and because of a programmatic error elsewhere in the system. And if we actually had taken a core and reset, one, the system would have come up, and then two, we would have been able to debug the situation, and now we're in a much more complicated situation to debug. So, yeah, we got to debug it, God damn it, please don't. And then, but to see it just kills me that, so Torvald, so what they're going to do is they are changing bug on, they're just going to search and replace. And if you read that email, you need to be have all sharp objects away from you. They are going to use, I know, SED can fix this bug.
Yes.
No, SED cannot fix this bug. So they're going to change every bug on to warn on. And it's like, there, I fixed it. It's like, okay. And so now, if you actually have a Linux kernel programmer that has, the poor right-thinking individual that is living in the ghetto of Linux, just trying to do the right thing, and has an actual legit bug on, if this happens, please panic the system, that is now just going to be turned into a warn on, and now you've actually introduced bugs effectively in systems, or certainly made any bugs that do exist in the subsystems much more difficult to debug. It's like, God, how dare you? Come on. Aren't you old enough to, Torvalds and I are about the same age. Do you still have this many hormones running through you that you think this is a good idea? Don't you realize that, aren't we getting older and wiser? But, whatever. So,
hey, warn on with Butter FS. What could possibly go wrong?
God. Oh, yeah. Oh, God. Twitch. I do love the whole, the
it's okay. System D will recover it.
Yes, don't. Chris, there comes a point where it's just you're just piling on here. You're just
I'm sorry.
like, can I actually make him pass out? I mean, are you two playing some sort of drinking game where you're going to see if you can actually?
I think we have a betting game on the side here.
At a time here.
See how long before we can make Cantrill stroke out live on the show?
Right, exactly. Like, is it normal? My vision is kind of fading right now. Is the white spots normal? Well, and I do love this whole Butterfest software raid business, which has been a total disaster. They now have like absolute rampant data corruption, and I think what I do think that there's a bit of a misunderstanding that the data corruption from Butterfest, and I love the Butterfest tweet, by the way, that you may want to use ZFS until we fix this. It's like, we may just want to use ZFS. Thanks.
Forever.
Forever. Thank you. Not coming back on that one. But I think what people don't understand is that there is a culture that creates that. That's not simply like, oh, the bugs will be fixed. People love to just like, oh, with enough eyeballs, all bugs are shallow. Like that is that's the famous. Who even said that? Actually, is that an Eric Raymondism?
It might be. Someone like that.
Is that
no, specifically?
I mean, it's clearly like you just go through like the hit list of jackasses, just trying to figure out who actually said that. But that is so deeply, deeply offensive and wrong that eyeballs don't actually debug problems, brains do, and these are not things that you can't crowdsource debugging a kernel panic. I mean, yes, that getting more brains on the problem is great, but there are only so many brains that are actually going to have the expertise to debug these problems. And the idea that if we just have enough volume, if we have enough use, these bugs will magically fix themselves. It's like no, they actually won't. The other thing I think that is actively happening to Linux, I think this is the kind of the peril that they run, is that right-thinking individuals are not attracted to that culture. And so people, even if you're interested in file systems, are you going to go, and you're 22, are you going to go work on Butterfs, or are you going to go work on ZFS? If you are interested in operating systems, are you going to go to a culture that is replacing bug-ons with warn-ons, or are you going to go to the BSDs or to Illumos or what have you, where you've got cultures that are not just more innovative, but also more rigorous in their thinking? And I think that in an all open source world, there's total freedom of choice for technologists, and the differentiators become almost the cultures, and these cultures become self-perpetuating. And so I think there's a danger that you end up with Butterfesses over and over and over again.
Yeah.
And I just wonder how many of these is it going to take before people kind of like connect the dots that there's actually there are broader differences than simply the technology.
What befuddled me was how they didn't catch this sooner, because the test case they did for it of create the RAID Z and like DD zeros into one of the drives and then run a scrub.
Right.
The FreeBSD handbook has every new ZFS user do that on purpose to watch, show them how a scrub works and repairs the data. Like our newbie guide has every user do that exact experiment to prove that ZFS works. And no one had ever done it with Butterfs? Ever? What?
Right. Well, and I think that this is the idea. Well, you wouldn't do it because it's not ready for production yet. It's like that. It would be mean to do that because it's not. It's like no.
That's just setting us up for failure.
When also it doesn't understand what software is born ready for production or not. And if the software that is, especially software in the data path, it's not. You don't make it ready for production later. It's like security. You don't retrofit it onto an extant system. You either design it for production use or you don't. And it's not something that you asymptotically approach. I mean, yes, there will be bugs in the system, but the bugs in a system that is actually designed for production use, that is actually a salvageable system. Bugs in a system that was never actually designed for production use or thought that production use was something that would be done later or by the little people, it is not actually tenable. And with ZFS was, people don't realize this, that ZFS was designed to be used in production from day zero. So it's just that it didn't have features in the beginning. So I mean, my home directory was on ZFS starting in, I want to say 2003. Certainly by 2004 when we had a mail server, and the kind of the first time it was really ready, we all kind of piled on, and it was it was in production. Now, I mean, ZFS was still missing a lot of features. ZFS still had bugs for sure, but those bugs were not of the variant that corrupted data. ZFS's bugs were all of, and I mean, still, when we have bugs in ZFS, they tend to be of ZFS taking long vacations, mysterious vacations, from which ZFS always returned. But it'd be like, oh, ZFS, where are you?
Right.
And so we had things like, big snapshot deletion, right? On big snapshot deletion, we'd be in syncing contacts forever. And ZFS would disappear for 45 minutes. Well, it
45
deleted a
hours
large
sometimes.
snapshot.
Sure,
Yeah, right.
sure.
Right. This is something we fixed years ago. But that's the difference between a ZFS that had been run in production for a month and ZFS that's been run in production for a decade, not corrupting data versus not corrupting data.
It's just, how did no developer do the test? It's a 10-minute test.
Well, no developer does the test because that is not what the culture is. The culture is not around integrity. That's not integrity is something that's almost mean-spirited and inconvenient. I mean, my God, you might actually panic a running system. You might ruin the uptime numbers. I mean, how cruel to ruin the uptime numbers to panic a system that is actually suffering from data corruption. That whole zeitgeist is fundamentally flawed, and it's self-perpetuating in that it creates software that never becomes correct. So I think that it'll be interesting to see if that culture changes. I mean, the one thing I will give Torvalds credit for is total amnesia and no sense of needing to square new things.
Uh-oh. Did I lose you guys?
No, I'm still here.
No.
My past self and my present self can meet in the middle. Like, he feels none of that responsibility. So, I mean, he might, who knows, maybe, he will fall down in the shower and all of a sudden all the warn-ons will go back to bug-ons. I don't know. I mean, because this is the guy who did not believe in source code control as a point of principle, which is just like, what point of principle is that? So no, did not believe in source code control as a point of principle, and yet is the inventor of Git. So,
Go figure.
I saw a hilarious tweet the other day. It's like, Linux is almost as if the guy who invented Git wrote an operating system.
Right. So would you say that they're just more into the feature bingo right now in the better FS land as opposed to
I think that
production bingo?
No, you know what? I honestly think that Linux is just not attracting people who are interested in OS development. I think that it is Linux is for people who view operating systems as done and uninteresting, and the operating system is something that's basically regrettable. I mean, there's been what innovation have we seen first in Linux? What OS innovation have we seen first in Linux? I struggle to come up with one, right? Because the innovators are elsewhere. So what people are using Linux for is like, look, we need an operating system for the phone, and we don't care what it is, or I just need to run. It's the same mentality that drove people towards Windows in the 90s, and they just don't care about the details. So I don't necessarily think they're being driven by features. I just don't think they're being driven by much at all. I mean, I think that Butterfs seems to be kind of, certainly with being encouraging people to run ZFS. And ZFS on Linux seems to have legs, which is great. I mean, obviously from a ZFS perspective, we really want to see ZFS on Linux. I think I have a newfound appreciation for just how immature ZFS. I mean, it was a little bit depressing at the ZFS Developer Summit how many of the ZFS on Linux presentations were essentially trying to add things to ZFS by reinventing facilities that already exist in other operating systems. Where you're just kind of like, why don't you can kind of reconsider some larger choices here. But no, we have to. Okay, all right, whatever. So I mean, things around like fault management, around debugging, and so on, where so they're basically being dragged into, I would say, by being dragged into kind of modern operating systems. I don't think they're necessarily. I don't think it's a feature frenzy. I just don't think it's much of anything. But I don't know. I mean, I've already spent too much airtime. I actually don't care that much. And every time I'm like, I'm beyond. I just don't care. Then there's something like the bug on thing where it's like, God damn it, now I do care. I'm trying not to care. Right. Trying so hard not to care. Thank God for Twitter.
Every now and then the wind shifts and the dumpster fire smoke starts drifting across your lawn. You're like, dang it.
What the hell is that? God, that smells bad. Yeah, that's exactly what it is. And again, thankfully, that 140 characters of stress relief, it's very healthy. I'm sure my kids implicitly Well, appreciate it, because I don't come home and scream at them or do whatever I would do if I locking all that rage up inside would be really very corrosive. So I'm glad that I can constantly release it.
Well, let's talk about something happier then.
Yeah, seriously, let's
about
happy talk.
the OpenCFS Dev Summit.
Yeah, which was great. I mean, it was fun. It was, it's always fun to get that crew together, people from a bunch of different technologies. There's a bunch of different interesting stuff going on. I mean, I think that we are. One of the things that I like about where we are now versus, say, a decade ago, is that these open source is so far along now that you got people from across different communities collaborating in kind of single open source communities. So we're getting a lot of great work in ZFS. I mean, I loved some of the crypto stuff that's happening now. ZFS. So ZFS does not have encrypted data at rest historically, and it's always been like that one checkbox item that we're missing. And you can definitely make an argument, and God knows I have, about the validity of encrypted data at rest, because if you need me to encrypt the data that the operating system, am putting to rest, that means that I'm the threat vector, that I'm the actual attack vector. The operating system, you do not trust me, and if you do not trust me, like, we're in deep trouble. Like, I'm in charge of running you. Like, I enqueue you to run on a CPU. Like, I restore your register state, dude. Like, if you do not trust me, we've got serious issues. You kind of have to trust me. So the idea that, like, we're going to encrypt data at rest, I've always felt like that's a bit dodgy.
Well,
I mean,
how
it makes
often
sense.
is your computer off for the data to be at rest?
Mm-hmm.
Right, and I think the case has always been, well, I want to be able to EOL these disk drives. I've been using these disk drives for years. I'm going to rip them out. I'm going to throw them out, and I want to be able to. Okay, that makes more sense. Now I'm taking them out of this trusted environment, the data center, running the trusted software, namely the operating system, and now I'm going to throw them in the untrusted dumpster. And I don't want someone to be able to get those disks. That makes sense. But there's always, if you've been on Wall Street, there's a little cottage industry actually around the actual destruction of disks. So they will actually annihilate your disks for you. And I swear at all these financial services firms, which are the only ones that actually spend the cash to go do this, because they basically throw it into this disk wood chipper that annihilates the disk into just particles. And I've never actually seen this happen, but I've heard that it is just like awesome to watch. I mean, of course, you're watching a disk eating machine.
Sure.
I mean, you're watching Diskzilla eat your storage. I mean, how awesome is that? Mm-hmm. And I swear that even if they had encrypted data at rest, I'd be like, I think we better destroy these anyway. I mean, I think it's just so awesome to watch. I don't think they want to. Because they always insist like, I better like see this disk into the hopper myself,
Sure.
so they can of course like watch Diskzilla devour the disks.
Because it comes down to like you're like, the only reason you need the encryption at rest for that case is if the disk is, say, going to become defective, stop working, and you won't be able to erase it or something. But you're too cheap to destroy it. You want the warranty replacement. So you have to send it back.
Want the warranty replacement.
It's like, well, make up your mind. You want if you can either spare the couple $100 to just replace the disk and throw it in the wood chipper, or your data's not that important and you can RMA the disk anyway.
Right.
It's
so there's always been a little bit of right, and this is the netherworld that encrypted ZFS has always lived in. Everyone's like, and at PS, it's like a hard problem too, right? It's a hard problem. There's a lot of stuff to get right. Key management is a huge issue. Mm-hmm. So you have like hard problem, somewhat dubious use case. Like I kind of get it, but I think there's some counter arguments for it. And then so this was true inside of Sun too, right? So inside of Sun, like the dream team did not get put on encrypted ZFS. Maybe the nightmare team got put on it. So there was an engineer that was doing this, and the engineer just did it totally wrong. So they went to go integrate it, and this would have been like 2009. They were ready to go integrate encrypted ZFS, and it's like, well, this is just done wrong. Totally wrong. Go back to the beginning, delete what you have. Like, this is the RM minus RF code review of like, we're actually going to destroy this repo. That's the code review. Code review over, repo destroyed. And so they actually had to go back and re-implement it, redesign it. Well, the problem is that by the time they were ready to integrate it, the operating system had actually closed. So if it had been done properly the first time, we would have had it in OpenCFS, ironically enough. And honestly, it'd be interesting to know, like, if you could go rewrite history, if we knew that the operating system was going to close, would we have let it in? No, I don't think so. No, I think we did the right thing by. I would say we, it wasn't me at all. Actually, it was the ZFS team did the right thing by forcing a total reset on that. We have not had it because it is the one thing that is in the closed proprietary copyrighted APIs Oracle Solaris that is not in OpenCFS.
Although what I found interesting about that is that they implemented it different than Oracle did, because when they originally were going to do the Oracle way, and then they found a bunch of problems with the Oracle way.
They found a bunch of problems with the Oracle way, and not surprisingly, honestly, because it was the same engineer that did the kind of the redo, and just trust me, this is not a surprise, and a total blessing, actually, honestly, that we had to do a kind of from scratch thinking, and this is Datto is the company behind it. Great to see them really contributing it back, and the engineer who's leading the charge on that it was super sharp. People should definitely go watch that presentation. I mean, I always find, I personally am of the type that I have when watching a security presentation, I have a very hard time. My brain wants to shut itself off. My brain is like, sleep is now. And it's like, no. And I have I remember we used to joke that the operating systems lecturer on Kerberos at school, you could put a crack addict to sleep with that lecture. And because it always felt like, you always feel like, okay, God, we're finally done. It's like, oh, no, wait a minute. But the attacker could compromise the ticket granting server. You're like, oh, God, no, please. Please, just let the attacker win. Okay, God, mercy. I want to go to bed. And because you're kind of like locked in that like mode where you keep like kind of drifting off and you're kind of waking up again. So I always kind of nod off during that stuff, even though I really, really want to pay attention. It's an important problem. So when you find someone who's really geared up on it, excited about it, and he was really engaged by it. So that was really fun to see. That was in many ways that was a real highlight of the conference.
He kept it high level enough that you could follow it without having to be an expert, but you could see that the detail was actually there.
The detail was actually there. No, I thought it was. I mean, that is as good a presentation on security that I've ever seen. I thought it was really good, and super young. I think I'm like sitting there like, I think he's like 23 or something. I don't know. But anyway, great. And I think also another thing that's great about it, and we're seeing this in a bunch of companies now and across the community, it is always great when you have people who are starting out their career, who are much younger than I am, much younger than we are, and watching them come in with the same kind of excitement, with the same values, and then better like having new insights and new directions that they want to take things. I mean, that youth and energy is so vital to any open source community, and it's always really exciting to see. I mean, that I think is really, that's the future of the technology, right? So I think that for all of us to be able to work on a technology that is still serving to inspire young people, I think is really is terrific. And engineers again that are starting out their career, and we all remember when we were there, which doesn't feel like it was that long ago. And it's really exciting to see.
Cool. All right, which one do you want to go to next year?
When we were discussing this before, you mentioned the value of small communities, specifically around ZFS.
Yeah. I mean, I think that there is way too much made about the size of a community and like how many GitHub stars do you have? It's like, I don't care. It's like, I care so much more about the quality of a community than the quantity of a community. And at Joyent, we've kind of had an interesting experience where we participate in a bunch of different communities. And we participate obviously in the Lumos community, in the SmartOS community. We participate in the Node community, the Node.js community. We were, as Ryan Dahl worked for Joyent, and we were the company behind Node for a long time. And then we participate in lots of communities in between, Postgres community, a bunch of others. And so we see a bunch of different communities, and boy, especially with Node, you see the curse of a large community. A large community is as much curse than blessing, because it's really hard to have a large community that really crisply shares values. those values become stretched more and more as the community gets larger and larger. And then you get to the point where you hit Node, and honestly, like Node just doesn't share values. And that's what it boils down to. And, a major reason that Node does not live adjoint anymore and lives in a foundation is because we do not share values. And it took me a long time to kind of come to that, because it's a tough conclusion to come to. But what's harder to come to is that we don't share values, and that's actually okay. That our values and your values, not yours, but your values and someone else's values should be able to coexist on the planet, but not in this, that we can't be in the same community, or it's really hard to be in the same community because we want to take the technology in two different directions. And we want to take it in a way that's consistent with our values, which is really much more around durability, reliability, debuggability, observability, around making actually rugged infrastructure, versus doing whatever dumbass JavaScript thing. Sorry, it still sounded like a value judgment, didn't it? We saw this in the JavaScript community. We've seen this with promises, which if you don't know about, I don't even want to burden you with. But suffice it to say, it's a different way of dealing with the asynchrony of JavaScript, but in a way that to us is totally undebuggable and has these failure modes where it's like, how are you going to actually debug that in production? But it was the other folks in the community just didn't care about that. They don't value debugging things in production. They don't value even necessarily running things in production. I was talking to a friend of mine who was in New York, and she was talking to someone else. Apparently, I came up in conversation. That Cantrill guy, he cares way too much about production systems. And it's like, oh, yeah, no, I'm totally with you. I care way too much about reality. I'm so fucking sorry that I care about actually running real systems. I have my profound apologies for my stubborn reality centrism. I'm so goddamn sorry. So, there's that.
Well, outside of production, what exists?
Well, that's the thing.
There's a classroom, right? And it's just a lab.
Well, there's,
and it's not meant to
there's
be
like
really
my laptop while I'm developing, but that's
to me, like, the opposite of production is autoeroticism. And which isn't to say that's wrong. Like, I honor that. It's just a different part of your life that we don't bring to work. The production systems are what we are actually developing. That is the stuff that we are engineering. That is the stuff that ultimately makes a difference in people's lives. I mean, which is ultimately what we're trying to do, right? Ultimately, we are trying to build this substrate of technology, these towers of technology that ultimately allow people to build useful things. That has to be the outcome. And to be useful, it has to run in production. So yeah, I mean, just to me, like, there is no other. But so I think to get to kind of, sorry, back to the point about the smaller communities, I think that when you have a smaller community, it's easier to share those values. And I mean, the ZFS community is a self-selecting community of shared values. And as a result, I don't care how many people are at a ZFS meetup. I don't care if that's not how I judge it. I care if 3 people show up, it's 3 people that I have something in common with. Mm-hmm. And, I feel that way about all of the smaller communities that we're in. I kind of had disdain for people who heap scorn on communities that are small, because I think that they don't understand that actually there's value to that smallness. It's like being in a small town, but even more so because it is so much about these shared values. And when we're small, frankly, it's like there is less to disagree about because we so do crisply share values, and it's more uplifting. And I think that way too much is made of the size of the community versus the quality. And I think that there are a lot of these great small communities out here, and there are great big communities too. But I think that's harder.
Well, just to the number of different conferences I've gone to, I've definitely enjoyed the ones with under 300 people a lot more than any of the huge ones.
Oh yeah, for sure.
It's like I want to feel like I talked to almost everybody that was here, and that I actually recognize some of the people, and that I can walk up to some people, and that they'll want to talk about the same thing I want to talk about.
Yeah, and that you want to see the world, you want similarly enough that you can then share meaningful experience. I mean, I want to have different experiences, but be bound by common values.
Sure.
And that's the trick. And I think that if you begin to not have those shared values, that's when the nerd rage starts to kick in.
Five people with a shared goal will get much farther than 100 people who argue about what the goal should be. Just every time.
Totally. And so I think that, and the value of these communities is that they are totally comfortable about completely sharing these values. And because the other thing that I just hate in open source communities, I do feel that this is especially true over in container mayhem, which we obviously deal with a lot at Joyent, but the idea that there are going to be winners and losers, or there's just going to be a winner and everyone else will be a loser. I think that some people have this idea of kind of like, who's going to be the VMware of containers? It's like, well, what if there isn't one? Like, what if there isn't actually a single winner? I think in an all open source world, I don't think there is going to be one winner. I think that there are going to be many different winners. I think that there are going to be, in fact, that's the wrong way to even think about it. I think that the idea that one technology is going to conquer all other technologies, I think that is a very dated kind of 90s-ism. And I don't think that's the world we live in. I think the world of the future looks a lot more like programming languages, like databases, like operating systems too, where there are lots of different choices to make, and you pick the right tool for the job. So I don't think we're going to have single winners in these domains, and I think it's a mistake for people to believe that there are going to be these single winners.
I think it's actively dangerous. As if the last 30 years have taught us anything, it's monocultures are bad, right? OpenSSL. Yeah. We really wish there was an alternative.
Yes.
Why did we let all the alternatives die off? That was a bad plan.
That was a bad. No, that is a really good argument. That is a really good example because OpenSSL is, and people now know OpenSSL is terrible because like, oh yeah, vulnerability of the week. It's like, well, not exactly but yeah, definitely vulnerability of the week. But for people we were in that code a decade ago, you could see that was going to happen because that code is atrocious. I mean, so a body of software that I wrote a while ago that I still love and use is the ability to take a core dump and find memory leaks. So I wrote this thing called Find Leaks for our debugger that would basically garbage collect the core dump for a C-based system and find objects that are not referenced. And when we turn on the debugging mode of the allocator, we know where these things were allocated. So we can report like this stack with the object with this stack trace has been leaked. It's great. And so we would use this all the time in C-based systems. This is terrific. And so we had a C-based system that incorporated OpenSSL, and there were just leaks all over the place with OpenSSL. And general, like I love memory leaks, right? I love memory leaks. I mean, I don't love the actual leaking of memory. I love fixing memory leaks because they're often really straightforward. It's pretty easy. Like you find the error path, like, there's just the error path. I forgot to free this thing. And you can make a change that's a totally robust, obviously correct change. It's clearly advancing the system. And it's like one of those things. Leaks are those things that I go fix when I'm just like depressed about everything else. And I can just go make some. You need like those things to like keep you moving forward, right? Making forward progress. So I'm just like, I'll just go fix some of these OpenSSL leaks. And so you're like, okay, fine. So you go into the routine and you find that, sure enough, something is not being freed in an error path. But then you realize that so now you need to actually like propagate this error, free this thing or what have you. And you're trying to propagate an error out and you realize that you're in a function that returns void. And you're like, okay. So this is a function that can fail in 18 different ways, but returns void. And if you don't propagate that failure, you've got no way of freeing the thing at the higher level. It's like, okay, all right. So fine. We're going to change that to return an error code. And how many places is that being called in? Please be called in only 3 places. Okay. It's called in 4 places. Or it's like, okay, fine. That's called by a function that then also returns void. And you're like, okay. And you kind of, you go to cscope this stuff, and you finally get to the function that is like, these is all void functions calling void functions calling void functions. Like the whole idea that something could go wrong and, either an allocation could fail or what have you is just totally, was just not designed with that in mind at all. And trying to retrofit that on was just obviously going to be impossible. And you realize that like, man, there's so much smoke when you are not properly propagating error conditions you know that there's fire. You know that there are deeper
Sure.
issues. You know that it's unlikely they got these deeper issues right. So it wasn't a surprise when the OpenSSL stuff started dropping. Some of it was like, wow, that is actually surprisingly egregious. It's actually like it's totally. And I'm sorry to go here, but it is a singular election that we're seeing. It totally is like the Trump outtakes, where it's like, okay, I knew that there'd be vulgar outtakes, but like, wow, that's even more vulgar than I thought it would be. That's stunningly vulgar. And I feel it's the same way with OpenSSL. It's like, okay, you know that there are going to be vulnerabilities, but like, wow, that is actually really brazen. That's even worse than I thought it was going to be. And I mean, roll on Libra SSLs. Libra SSL, am I just dreaming the dream? Is that thing actually going to,
I think it's got a future.
Well,
is it going to save us all? All right.
maybe like it's just a fork of OpenSSL, but it has the
Right,
newer
that's the
API that's will
Right.
eventually someday mean you can write an app without having to use the terrible API. But yeah, some of the guts are still there, I think.
We need the RM minus RF fork of OpenSSL. And I really do think that needs to be a from scratch rewrite. Hopefully someone is excited by that problem, because it's a hard problem to solve. But no, I mean, Alan, to your point about that, it is the monoculture that created that. And people want that monoculture because it's a problem they don't want to solve. Sure. And I understand that. But when you accidentally create the monoculture, when you care so little about the problem that you have effectively single sourced the solution, then you've got these risks that are now systemic risks almost because of the monoculture. So I do think it's a danger when we do approach that monoculture. Fortunately, I think especially in the open source world, this is the beauty about open source, where we're not relying on necessarily the livelihood of companies to preserve heterogeneity, that we're only relying on the software itself, that as the monocultures get broken, they don't get reconstructed generally, which I think is at least it gives reason for optimism.
Yep.
Cool. All right, so next topic, let's throw it out here. So cooperation between Lumos and FreeBSD. So
yeah. Absolutely.
Yeah, so what are you seeing going on there? I know we've talked a little bit about the bootloader, for example.
Yeah. I mean, that's been huge for us. I mean, UEFI, this is an attack on humanity by the ghost of Bill Gates, right? I feel like ultimately it is still the BIOS vendors that actually are holding humanity hostage. I mean, it's just amazing to me the degree to which AMI is actually the existential threat to humanity. And everyone is letting this little tiny company push humanity around. Anyway, it's very frustrating. And UEFI is a huge source of frustration because, we all need to boot on hardware. It's been huge for us to basically be able to collaborate on that. And I put collaborate kind of loosely because we're really taking advantage of the FreeBSD work.
Well, you
gave us ZFS, we give you a bootloader, it's fine.
Right. I kind of feel that hey, we were the leads on ZFS and DTrace. Now that's in FreeBSD. You guys led the charge on the bootloader, and now we're using that. And I think that this is, I think that there's a lot of really healthy cross-pollination between the communities, and I think that should continue. I think I like having the disjoint communities because they do have distinct histories and there are distinctions there. But I also think it's tremendously valuable to have the cross-pollination, and it's not always cross-pollination of technology. I think that one of the things I saw in FreeBSD 11 is the jails. They are finally making the shared memory, the System 5 shared memory is finally jail aware. And I believe I can claim some fraction of credit for that, because I think that might be because of the papers we love I did comparing doing the jails paper and the zones paper. Which I love doing. It was really interesting to contrast jails and zones, compare and contrast kind of the different design centers there and looking at the history. But I was I kind of couldn't believe that the shared memory was not jail aware. And I'm glad it is now.
Yeah,
that's great.
There was some work before on it, but it kind of stalled out, and I think you're
kind of dwindled.
Yeah, and then your talk got someone new excited about it, and then it was done.
Which is great. That is so exciting. I mean, it is great. One of the things that, and this is just the new age we live in. I mean, to think that we're only kind of 10 years into the post-YouTube age, which is amazing. It feels like we've had it forever. But we didn't really have a way of communicating this stuff, really. I mean, I guess we did it at kind of conferences a little bit.
Yeah, you had to travel.
Or like mail order the DVD after the conference.
Disjointed IRC conversations.
Right. I mean, God, this is what we are living fossils, guys. This is what we sound so goddamn old. I mean, it's so embarrassing. When I try to describe that era, you're like, wow, that is not, and it's not that long ago. That's the amazing thing. But to be able to, I think one of the great things today is that be able to serve as an inspiration to someone who you can't say, who's who you've never met, who watches a presentation you gave, and maybe you've inspired them in some not even a direct way, but like you talked about this problem and I got excited about the problem. I mean, you didn't even necessarily inspire me to do it, but you pointed me to the problem, and that's great. I think to be able to have that kind of influence. I mean, and I think it's indisputably making things go faster and better to be able to influence one another in that regard. So I'm glad that to the degree that I was able to influence it all, it's great, and it's great to see that in FreeBSD 11, and great to see. I think obviously we're a huge believer in proper container technology, jails and containers, jails and zones. So roll on.
Yeah, cool. There was quite a bit of other stuff happening. The localization support came from Illumos and went into FreeBSD and Dragonfly BSD, where bugs were found, and then the fixes were pushed back up into Illumos.
Great! Oh, cool. That's
even
great.
The bootloader, that didn't just come wholesale from FreeBSD. Tumis did a whole bunch of work to improve it on FreeBSD before bringing it over, including our support for reading off FAT32 was very slow because nobody boots FreeBSD from FAT32. But Illumos, you pulled out the big image, and so that became a thing. And so a lot of work went both ways there, including I think the reason he and I started working together so closely was I started working on implementing selecting ZFS boot environments from the FreeBSD loaders menu, and he was like, "Well, yeah, we want that feature too." Although on Illumos they implemented it slightly differently, but we collaborated with that and. We really enjoyed having another person who could write forth, so I didn't have to.
Can we just get rid of that? Oh, come on.
Now, come on now.
Speaking as one who's had to do some forth.
Fourth is mother's milk. Fourth,
there's another one, Alan.
Fourth. I love Fourth. And Fourth is so tight. And because PostScript is essentially a fourth derivative. Bonwick used to write his presentations in PostScript. Do you know this? So, and even by the time I came along in the mid '90s, I'm like, why don't you use FrameMaker for that?
Oh no, the feed stalled.
Justify like that's the right way to do it. He's like, it renders so much faster, which I mean, admittedly, like Bonwick's, I mean, they would print ridiculously fast. I had no idea that a printer could go that fast when you would print it out or you like display it on the screen. I mean, it was like being punched in the jaw because it was all raw PostScript. I mean, it was like, and his presentation was like 5K because it's a program. It's a 5K PostScript program. But I just have too many fond memories of programming my HP calculator. That's in Fourth. I think that's what Fourth evokes in me. I mean, I get to the HP 42S, HP 48G, and I know I don't care that I'm a fossil. I don't care. That's fine. I don't care. And I know it's all like the TI. Was it TI 85 now? Just sickening to me.
It's a different generation. The baby boomers had like their favorite rock groups, and for us, it's like, do you remember that calculator?
Oh, God. Remember? I mean. Infix notation is just disgusting to me. I mean, it is just disgusting. How could you possibly? And I remember, saving up for my summer job so I could buy an HP 48 calculator. I'm listening to myself right now. I just sound ridiculous. But whatever. It's history. It happened, And actually, in that HP 48G, I had that was an infamous calculator for me. Did you have an HP 48?
I did not. No.
You guys have this generation? This was a monster. So this was this was like the first. It was an early graphing calculator. It could take these like modules. It had this crazy ass microprocessor in it, the Saturn. You could write software for it. Like you could get Pac-Man for the calculator. awesome. It was a great community. So much fun. And I was taking a linear algebra class, my linear algebra class, and I had this prof, incredibly annoying prof. And this is the kind of prof, like classic math prof, who would spend 20 minutes explaining the thing that's actually completely obvious and then skip over like 6 steps in the proof. So basically the only questions he was really entertaining were questions about things that were pretty much had obvious answers. And so he was kind of insufferable, and he had I remember the first lecture. Sorry, I'm going on a long tangent here. But the first lecture, he had this extended calculator policy that basically boiled down to you can't use calculators, which made sense. It's like it's linear algebra. My calculator could take this course. Course, so it made sense. But he had this go on for hours about how you can't use calculators. All right, fine. So we get to the midterm. And there's a person in the class that would always ask like the question that he had already answered exhaustively. And you're just like, oh, please don't ask that. He's going to go off again. And so this person raises their hand and says, hey, can we use calculators in the midterm? And you're like, no, of course we can't use calculators in the midterm. You idiot, don't ask that question. And he says, oh, yeah, sure, you can use calculators. He had this kind of whiny voice. I'm like, what? He's like, you can use a calculator. It's like, okay, what? You had this whole... this 20-minute lecture on day one about how we can't use calculators. So I raised my hand. I'm like, we can use calculators. Yeah, you can use calculators. But I'm asking this question one more time. Are you sure we can use? Yes, you can use calculators. But if you don't show all your work, blah, 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 you get the answer wrong. Yeah. All right, fine. So I'm like, all right, I need 3-phase power so I can plug in my HP 40. If we're gonna I could just wheel in. Like, is there a room with AC around here, like, so I could actually like cool my HP 48G so it can take this exam? So in the linear algebra, you had that kind of classic taking a matrix to some high power, and you gotta like invert the matrix and take the eigenvalues and multiply all that together, whatever, and you gotta leave it as a product of these kind of 3 giant matrices, and admittedly, I decided that I was really not interested in doing all that work. So I wrote down all the steps that you would do. And then I said, or just do it in your head. And I had the HP 48G do this. It was a 10 by 10 matrix to, I think, the 10th power. And I had this thing crunched. The thing took, this is in 1994, the thing took like 45 seconds to grind out this answer. And it was this 10 by 10 matrix that had like 13-digit numbers in it. And so I handed my exam, and the exams come back, and he is like, one of you has betrayed my trust. And you're like, okay,
oh, no.
Someone cheated on the exam. And he goes off on this like speech about betrayal. I begin to think like, is this me? Is he talking about my exam? And sure enough, because this guy had never used a computer ever, basically, classic mid-90s math prof, he didn't know what that matrix was taken to the 10th power, and he had to calculate it all longhand on the back of my exam, was covered with... And he so clearly wanted me to slip a digit on that, which I obviously didn't do. Anyway, long story. But
did he retire the next week? Like, I'm done.
It's even worse. He did not get tenure. So, and I think in retrospect, he had not gotten tenure earlier in the semester and was just using us as part of his own Stanford prison experiment. So I think he had kind of turned sadist early. But maybe related why I didn't get tenure. Anyway, this is why I think that this is a long fourth story. This is why
the longest fourth story ever.
No, I'm sure this is not. I think if you mention fourth, there is a generation of technologists who will just begin to describe their childhood. I think it has that kind of effect on people. But anyway, I'm glad we got that. So we got the. I'm glad, and we got the Sun font. We got the old school Sun font. At least in the, we found the font that was what the old Spark boxes would use when they boot. So it's a very kind of retro feel to it, which is fun.
Sure.
Cool. So you mentioned papers we love, so that obviously brings us to systems we love.
Yes, very excited about systems we love. So first of all, love Papers We Love. I don't know if you guys have been to a Papers We Love meetup, but they're happening everywhere. It is a great movement, a huge tribute to those folks who wanted to actually discuss papers and have a journal club. There's a lot of great research out there. And, one of the things that kind of a long troll of mine is that academic computer science conferences have become totally practitioner hostile. In fact, Usenix actually made a total mistake. So you may recall I gave this Fork Yeah Illumos talk at the Usenix Lisa in 2011 that became something of an infamous talk. This is where I was rather unvarnished with my opinions about Oracle. And recall that this talk, the Lisa talk, Usenix Lisa talk, I did not go online for many weeks. And everyone thought it was a conspiracy and so on. Of course, I thought it was just incompetence. And when it finally did come online, it actually had this disclaimer that had never been on any Usenix video about the following views are not the views of the Usenix Association. And they had taken that disclaimer and mashed it up and put it above my head the entire time I'm speaking, just so you know that these views, that I'm a total renegade. Anyway, they made a huge mistake of inviting me back to keynote their annual technical conference this year. And I'm like, this is on you, man. You should figure it out. Like, if you don't know what I'm bringing, it wasn't actually video, but it was recorded. And I use that as an opportunity to for a rant that I've been meaning to have for a long time, which is how academic computer science has ruined the academic practitioner relationship with a conference system that is totally screwed up. So academic computer science uses conferences as the publishing vector, which is just totally wrong. No other scientific discipline does it this way. So anyway, I gave this talk, and what I view, and this is a long way getting to systems we love, but part of the reason I don't like that is because it makes conferences fundamentally very negative. It's about kind of who gets into these conferences. And so you don't actually have a lot of the discussion happening there. Papers We Love is picking up some of this best research and then talking about it with practitioners, which to me is much more fruitful. I was a little dismayed by how few academics had heard of Papers We Love, but hopefully that's changing. So I love Papers We Love. I think it's great. But I didn't want to restrict it to just papers. Like, why not? Let's talk about some of the systems that we love. And also, let's talk about the things that are the technologies, these small communities that don't necessarily have their own conference or for whom their own conference doesn't make sense. Let's give these technologies an outlet to talk about what they love and what motivates them. So we pulled together Systems We Love. I made the mistake of tweeting out that, should we do this, which is totally a mistake. This is where you need to rest for a minute before you tweet that out. Because immediately you were like, oh, great. Like, when is it? I'm going to booking travel. It's like,
committed.
Yeah,
I'm already booking a flight. I don't even know where.
And so but we said there was such an overwhelming response. Like, okay, we obviously have to do this. So we put it together. It's coming up. It's in December. Systems We Love, systemswe.love even. The submission is actually, if you're listening to this live, you're listening to this recorded, I'm sure this won't be available for a while, but if you're listening to this live, the submissions are due in a week, less than a week. So definitely get the submissions out there. We've got an amazing program committee. I've been really lucky to pull together a ton of folks from a ton of different communities, and a lot of great submissions so far. So things will be great. I think it's people talking about the systems that they love, because loving systems, which ultimately, that's certainly a bond that the three of us share. Loving systems is a kind of a peculiar thing. And it took me years to realize that is my precise affliction. Because when I was a kid, I actually thought I wanted to be an economist. I really loved economics, and then did what I thought was this hard right turn into computer science. And what I then realized kind of years later is actually what I'm really interested in is systems, and software systems are just the purest distillation of that. And that's what is so exciting about software systems, is that they're discrete, they're tight, you can reason about them, you can improve them, unlike more complicated systems with more humans in the loop, which are much more difficult to kind of reason about and reform. So we're really excited for Systems We Love. I think there's going to be a bunch of interesting stuff there. I've just taken a peek at the submissions and really looking forward to it. So it's pretty great.
Oh, that's neat.
So if we have time, we have a couple of questions from the chat room.
Oh, you bet. Yeah, that's kind.
So they asked about Illumis's firewall, which I guess is still IPF.
It is still IPF.
And Oracle's been importing PF into their Solaris. Would Illumos be interested in something like that?
Yeah, we'd be really interested in something like that. IPF has been a problem for us. So that's it's been It's been a work in progress, to put it mildly. We would love PF. We would love PF, and again, just twitching that. Of course, by Oracle taking PF, that's not work that we can use, and it's not work that they're going to open source. And so wrong. Anyway, but yeah, we'd love that. I think that is it's a direction we're going to ultimately need to go in. IPF has definitely been a source of issues for us. I mean, as always, it's complicated because we use IPF for the firewall that we implement as part of the Joint Cloud. So it would be a complicated transition to make, but I think we're going to need to make in the limit, and we would love to see PF and Illumos for sure.
Cool. So next one was what do you have? Any thoughts on Apple's new file system, AFS?
Yeah. I think that in the Valley anyway, Apple did invent the term NIH, or NIH is commonly ascribed to Apple. NIH, the not invented here syndrome. I think that's what we're seeing, the NIH flag flying high with the Apple file system. There are some, I would say, pretty deep philosophical differences between ZFS and the Apple file system. One certainly is around the reliability of hardware. The Apple file system has the somewhat peculiar notion that hardware is reliable, and it believes in magical hardware. It's
because it's Apple hardware, of course.
It's Apple hardware. It has to be magical. And I've stopped believing in magical hardware a long time ago. I don't like magical hardware. In fact, you could say that the foundational principle of ZFS is smart software in lieu of smart hardware. And we kind of knew that going in, but boy, and I'm sure you guys have your own stories where you've got ZFS on a LUN that is putatively from this very expensive SAN, and ZFS starts reporting data corruption, and everyone says, well, it can't be this from the SAN because I paid so much money for it. It's like, if the SAN is corrupting my data, then what did I pay so much money for? You're like, well, this is awkward.
So you better sit down for this.
You may want to sit down for this, right? You may want to. And honestly, what you learn, you kind of as you become a veteran in the storage industry, you learn that what you're paying for is not data integrity. What you're paying for is the privilege to watch a storage vendor's SVP of sales lie down naked in the fetal position, weeping softly, begging for forgiveness from you. That's what you're paying for. And if you're the kind of sadist that gets off on that kind of thing, then okay, great. But for the rest of us, it doesn't really make a lot of sense. So I think that's a very kind of core difference in belief. That and it's really designed around that company is so welded on to the client. The ghost of Steve Jobs still walks the place for sure, because you think that they got the raw goods to do interesting stuff server side, but they just don't. And it's my understanding that it's really kind of welded around not just magical devices, but kind of small numbers of magical devices. So, Adam Leventhal, my longtime co-conspirator, did a great piece on it on DTrace.org. DTrace.org, kind of a blog that I threw together in as we were, leaving Oracle, that I still need to kind of clean up and get on better infrastructure. But every once in a while, I'll get on Hacker News and see DTrace.org as the top story. I'm like, oh, okay, Adam has posted something interesting. So Adam had a great series of blog entries on the Apple file system where we really kind of took it apart. But I would say that it's, obviously, free to be you and me. Is it open source? I don't think it's open,
they claim that they might open source it some years from now.
They claim that they might. Yeah, that's nice.
I agree that's not
Exactly.
anything. That doesn't mean anything. That is put a ring on it or don't.
That's like when I tell my kids, I'll think about whether I'll let you do that. That
no.
usually,
Exactly.
no.
Right. And that works with kids for a while. I definitely remember when my kids were the age where they say I want this for my birthday, and I would say okay, noted. I would look deliberate, noted. They'd be like, okay, he paid attention. Not paid attention at all. But that doesn't work anymore. So yeah, they might open source it in the future. Don't care. So open source it or done.
Also, I don't think it contains anything novel enough for it to be that useful to be open.
And Sony now relies on magical hardware.
It's like, we'll check some of the metadata, but not the data because magical hardware.
Right. And I just don't understand. The ZFS arguments. And clearly, like they were making, and like we saw this in Linux too, licensing arguments are usually a proxy for technical NIH, right? I just actually don't feel like adopting this change, and a licensing is a convenient way to do that. So I don't know what arguments they made internally to not use ZFS, but they're probably not very good ones. So that's a shame. I mean, it'd be great to see. I wish we could have ZFS on the laptop. It would be great. But honestly, I think that Apple is kind of drifting in the post-Jobs Apple. We kind of saw that movie before, and we're seeing it again. And I honestly think that one of the ideas that was floated to me post-Samsung acquisition is, hey, you guys should take a Samsung laptop and commit to it, get the driver support for it, and allow me to run SmartOS on the laptop. And it shows my character flaws that I think to myself, that's intriguing. It's like, no, that's a dangerous idea. Don't do it. Like, no, that's like I do SmartOS on a laptop. But the only reason that's tempting is because I do feel they've kind of lost the plot a little bit. So
the very first line I ever wrote for the ZFS book that Michael Lucas and I did was, "Your disks are plotting against you, and ZFS is the only thing that can put an end to their treachery."
That is true. If only the discs were that smart. It's like they're not even. It's like the dog is pooping on the rug. Not because the dog doesn't even know it's a rug. It just doesn't. Right. It's a dog. And unfortunately, there are tens of thousands of dogs. And it is. I think people don't realize how bad it is, and how firmware really is the single greatest threat to humanity. They do not understand how, and also people think that the disk pathologies are kind of gentlemanly. They think that like disks commit ritual suicide, and that's not what they do at all. They just start giving you the wrong. They give you the wrong answer. They give you the wrong block. They take forever. We had a problem with the. Seagate. Oh God. When you could remember firmware IDs, that's a problem. Like SU0D is scored in my brain. SU0D was for Seagate, the Seagate Barracuda drives, and there was a firmware bug where it was a logic bug in the head where it would misapply the polarity of voltage to when it wanted to decelerate the head, and it would attempt to accelerate the head when you got to high LBAs. And the controller would realize that this is about to happen. It's like, no, you do not mean that. Like that will actually destroy the drive, and it would reset the drive. So you would have this 650 millisecond outlier while the drive boots. And the pathology of this was much more likely. It was ultimately a race condition, effectively. I don't know. It was ultimately a firmware bug, but it was ultimately much more likely at high LBAs. So you would have this thing where it would be like you'd be fine, you'd be happy, everything would work, and all of a sudden one drive would begin to have these like outliers, and then like 2 drives, and then 15 drives, and then you're actually crying. And so you need stuff like that where it's like the drive is actually rebooting. That's a really nasty pathology, and your hardware. It is you against the hardware, and ZFS is your only hope when it comes to storage hardware. That's for sure.
Yeah. Although it doesn't help when the disk controller just decides you don't have any disks anymore.
Then you've got that. Like what disks? What are you talking
reboot
about?
the machine, and it's like, no, there are no hard drives. And then you power it off for a while, power back on. Suddenly, hey, there's hard drives again.
I almost know
those disks.
Yeah, we actually are dealing with a vendor now that's got a firmware bug where the drives disappear, and when the drives disappear, there are OS conditions that can lead to that. But then it does take resetting the box. When you power cycle the box, the drives reappear. You're like,
I have one where when you power cycle, it didn't. It had to like cool off or something. I don't know. It was the weirdest thing ever.
Right. And like on the one hand, it gives you the solace of like, this is not a software bug. Not the software we control anyway. Not in the OS.
When the BIOS doesn't see the drives anymore, not my operating system's fault.
And not your operating system's fault. No.
Man. What a mess.
That's DOS's fault.
So I think the last one we had here, somebody wanted your thoughts on vulnerabilities, correctness, or security overall in Lumos.
Oh, yeah, interesting. I think that I'd say, we design the security as a constraint. And especially for us, because we do run, I mean, as with jails, running containers on the metal, it does mean that you have to take security very, very seriously.
Sure.
Which is not to say that we've been without vulnerability, or that I would say that I'm sure that, sadly, there will always be vulnerabilities in software, but certainly we have. And actually, I've got to give a real tip of the hat to the ZDI, the Zero Day Initiative. Was HP, now someone else. I don't know where. It was one, like, the best thing HP was doing was the Zero Day Initiative, where they incentivize security researchers to find these things and funnel them back, which has been huge for us. And that's been, I mean, because we've had a small number, and obviously, not a we take them all very seriously, but ZDI has been really helpful for that, and has been and there have been security researchers that we've worked with pretty extensively through ZDI, and it's always of some solace when you see the creativity of some of these exploits. Where you're like, wow, that was because and often what they do is, which you just have to admire the creativity. It's often, especially in mature software like Illumos, it's not one vulnerability. It's it's like two bugs that they're using in unison with a third that only leaks information. So you get a bug that's kind of innocuous that just leaks information, but not information that you can really use, until you've got these other two bugs that you use in tandem, and now you use all three of those bugs together to develop an exploit, which is really. It's crafty when you find them. It requires some. It always because you want your software to not have any vulnerabilities at all. So when we do find out about these, there is that feeling of just total inferiority, and you feel, because like, oh my god, we've got but then you feel like, okay, I'm just thankful that we found this thing the right way and get it kind of resolved. And ultimately, that has to be your disposition, that we're that the exploits wanted. I think that we've got a very robust substrate, one that we've got a lot of confidence in. But that confidence only comes from being able to really attack these vulnerabilities when they exist. And I think that structurally, I don't think we've got issues. I think things have been built the right way. I think that zones are robust and secure by design. I think we've got lots of things that help limit penetration and so on. So the flip side is we were looking at one of these exploits where they were using a bunch of our debugging tooling to help them develop the exploit. And they had a comment like, man, I love developing exploits on this operating system. These, like, the tooling is amazing. And you're kind of like, okay.
Okay, thanks.
Right. Thanks, I guess. Like, oh, God. I mean, this is really all the tooling that I believe so fervently in is actually being used. But then you have to be like, no, this is actually good. This is actually good. You want it to be easy to find these things so we can fix them in the right way and so on. So, yeah, I wish we were without vulnerability, obviously, but I think we've got the right architecture, but they're always going to be out there.
DTrace is the best rootkit ever.
It is. I know. It is. And it really is. I mean, I think people sometimes don't realize that what it means to have DTrace in the global zone. I mean, no, it's like you can see everything. I mean, that's by design. So, and then we've obviously got a lot of things that limit how you are able to use that power. But it is designed to allow you to see everything.
That's right.
So
that's still a good thing. Transparency.
That's right.
Well,
exactly.
Paul Hennenkamp, when we interviewed him about jails, he said one of the best things about jails is that, if there's an attacker in the jail, as the sysadmin in the global zone, you have like one of those police interview room two-way mirror things going on. You can see in what they're doing, but unlike with the regular system, they can't tell you that you're looking, right? You're not connecting in. You're looking through this two-way mirror, and they have no idea that they're being observed.
Yeah, they don't. And so one of the things that we have actually, especially with LX, where we've got a Linux system call table, can actually run a Linux stack. One of the things that I would like to actually do, I haven't had a chance to do yet, is throw out some honeypots out there that are LX zones that we can actually observe attackers, because you can make this an incredible intrusion detection system by leveraging that incredible power from the global zone. And actually, we did have a situation where we were developing LX, and we saw one of the things we do is whenever a program dumps core, we take those core dumps and collect them, and we've got a system in Manta that actually allows us to analyze them. And I noticed that there were all these core dumps from IP tables. I'm like, what the hell is that about? And you look at the core dump, and it makes no sense. I mean, it looks like no sense in that it's just like clearly dereferencing a null pointer or doing something that can't possibly work. But you run IP tables and it works fine. What was going on? And then I realized that actually I didn't realize it. Someone else realized, because I'm like the last person. Sometimes I have a hard time debugging the broken arm. I'm so down in kind of the scanning electron microscope level that I have a hard time seeing the broken arm. And someone else noticed, like, the capitalization of IP tables is really screwy. And they started Googling around, and sure enough, what had happened was there had been an LX zone that had been created with no root password, and someone had rooted the zone and then installed their own IP tables that was now core dumping, because it actually isn't. It's actually on SmartOS, and so the malware basically wasn't working, which was kind of funny. But I think it does show that you can do actually a lot when you can observe an attacker, and it'd be really cool to build an intrusion detection system where because you wonder if you kind of could throw one of these things out on the internet in a controlled way, if you couldn't find some of these things that are being used in the wild before people realize it. Maybe you could even find people that are exploring new 0 days before they're actually in use. I mean, that'd be pretty cool.
Yeah, that'd definitely be cool. Okay, well, I think that was the last question we had. So is there anything else you want to mention before we wrap it up?
Yeah, no, I feel like I'm all ran. I feel like, see, this is I came in almost pre-exhausted from having to wrangle with Skype. So I never know if I'm like turning into like the Andy Rooney of operating systems, or am I like, I don't know if I'm. So hopefully I'm not too cynical and embittered.
No, this was perfect. Well, we appreciate you giving us an hour and 10, 15 minutes. However long it ended up being. That was perfect.
Always happy to do it. Great to talk to you guys as always. And you have always a fun conversation. And thanks again for all of the great technical the collaboration between.
I got to ask, are you going to make it to Meet BSD in November?
That is in
Berkeley.
Where is that? That's
in Berkeley.
Oh yeah, definitely Berkeley. Yes, I am to the point where I really need to travel less at this point.
Okay.
But Bay Area, absolutely. Yeah, it'd be fun.
Yeah, that would be a lot of fun. And it's going back to the birthplace of BSD. So it's like. That doesn't happen very often.
Awesome. I feel like that would be great. We should do some. I went to some Oktoberfest last week and gave a fun talk on oral tradition and saw in the role that oral tradition plays in software engineering. But it would be great to have some talks. I don't know if people are going to have some talks and kind of some of the early days of BSD would be really fascinating.
Last year's or 2 years ago, Meet BSD was Kirk McKusick talking about the original TCP/IP stories and how that came into BSD and so on. And it's always one of my favorite things.
That'd be great. Yeah, was that video? I have to go check that out.
It's on YouTube.
All right, I'll check that out. With at this last one, I did I did an out loud reading for the first time ever in my presentation. I did an out loud reading of, if you've ever read "The Bug Count Also Rises," which is a Hemingway spoof about debugging like proprietary software in the 90s, but it is so beautiful. So I'll leave you with that. The Bug Count Also Rises. You have to go check that out.
Nice. Well, again, thanks so much for being with us today, Brian. We appreciate it. Until the next time, though, we'll definitely let you know. We can get you back on here again.
Cool. Absolutely.
Okay, everyone. Hope you enjoyed all 3 of the Cantrill episodes this week. I know it was a ton of fun. It's a good thing we recorded these over a period of time, Alan. I think it would have killed us.
Well, I was even surprised actually looking at it how close together the first and second one were. There was only like 15 weeks between them, which I guess that's not a short amount of time, but
But it was, it was a big deal. Like, we needed him back. Come back, Cantrill. It was good. It was definitely good stuff.
So much good
stuff. So hopefully we'll get him again in the future and have some, make it what are we going to go for 6 episodes total? That way we can have 2 trilogies and then we can have like prequels. Maybe he can talk about older stuff.
Yes, I still have to ask him about the eCache parody story.
Okay, there you go. There you go. But anyway, of course, stay tuned for that in future episodes of BSD Now. But as we wrap up this week's show, we got to remind you all the usual stuff. Send your questions, comments, and show ideas, topics, or stories you want mentioned on the show to feedback@bsdnow.tv. That's the only place we monitor, so please do send everything there. Otherwise, we may not see it.
We have Asia BSDCon coming up, so we need all the emails you can send us so that we can manage to schedule everything around that.
Yeah, we're trying to do we have to do some episodes ahead of time. There's some travel involved. The FreeBSD Storage Summit's coming up the week before,
well, it's
too.
like,
So
it's the week that I leave for Tokyo. Like, I fly out to California on the Sunday afternoon and then do the storage conference on Monday. And I managed finally, with some work, to find a flight home Monday night instead of Tuesday morning. So I don't have to spend the money on a hotel room for a second night. But it means I leave California 25 hours after I got there. And at like 11 p.m., meaning I get back home at like 6:30 a.m. on Tuesday.
Oh, Lord.
Yeah, it's going to be. But it's because I leave for Tokyo on Friday. So getting home Tuesday morning instead of Tuesday night actually gives me a little bit more time at home.
See, you're going out a lot earlier. I leave Monday for Tokyo, the following Monday. So it's not so bad. Or is it Sunday? No, it's Monday.
Are you sure?
Anyway, either way, it's still going to be a crazy week. I get there Monday? Maybe I leave Sunday. I don't know. I need to go back and check my flight, right? I know I
better show up at the right day at the airport, or otherwise it doesn't work very well.
Yeah. It's one of those things I always get confused because, let's see, the conference starts Wednesday or is it Thursday, Friday?
It technically starts Thursday.
It's Thursday. Okay. Yeah. So I arrive. Let's see. I leave Monday, arrive Tuesday, and then I have Wednesday off because it starts Thursday. Yeah, so I leave Monday.
Okay.
I have one full day off before the Dev Summit starts.
Well, remember last year we all agreed to get there earlier so we could do more touristy stuff?
I can only ever manage to do one extra day usually, unfortunately, with my schedule. But
for me, it came down to the flight was a lot cheaper to go on the Friday instead of on Sunday, which I was planning to do.
Well, next year I will remember that. Maybe that's what I will do. That sounds good. But anyway, as we were reminding you guys, feedback@bsdnow.tv. Send us stuff. We need things for future episodes for the weeks we're gone. And of course, if you're coming out to Asia BSDCon, that'll be awesome. Come say hi to Alan and myself.
A couple people did at FOSDEM. It was very nice.
Oh, very cool. Very cool.
Although a couple people were like, so I recognize you. Did you teach at my company or something? I'm like, no. Did you maybe watch the podcast? They're like, no, that's not it. And I'm like, it's probably got to be.
Right, it's got to be you, or somebody was watching it when you walked by, right? You saw somewhere. Anyway, so this week is all wrapped up, folks. Thanks for sticking with us. I know it was a long episode, but hopefully you enjoyed it as much as we did getting to record these with Cantrill. And we'll be back same time next week.